Welcome everyone to our fourth day of PHDwin Week. We really appreciate you joining us this week for what I think has been a pretty engaging conference. What do you think, Nick?
I agree. Couldn't agree more. I think yesterday was really fun. It was good to have Courtney, of course, always starting off a good day with that. Brandon Penner, also from Anthem, right? With Gavin. So I was really happy to have him on. David with the ethics thing. It was a great day.
Yeah, I loved. So we had David Clark and David Pasenda going back and forth for that ethics presentation. I thought that was really engaging, that extra discussion. And so, again, that was a requirement for anyone wanting PE hours for PHDwin Week. We will have the ability for y'all to get the certificates afterwards. But with some other notes kind of for today, we've moved the schedule around a little bit today. So we're actually going to have on the schedule right now, originally for the morning show, we're going to have Ifer Lee on. He's going to actually come on after our D&M presentation to talk a little bit about what's going on with our international efforts in PHDwin. Instead, we're going to have a special guest on, a vendor that we're looking to work with that's going to show off some cool software, some cool technology. That's what we've really been trying to showcase this year, Nick, is technology, right?
Mm-hmm.
Have you? And I know you've seen some stuff that's got you inspired, right?
Oh yeah. As I was saying to the forecast guys, I think that was Tuesday.
Mm-hmm.
My background is data analytics largely, so I'm very interested by all this new stuff, and I love how TRC incorporates these cutting edge tools and gets people on and gets the conversations going. It's a really cool thing.
One thing I love about moving to SQL Server is that allowed for these kind of integrations. That really opened up the world some as far as who we can work with and how we can work with them. Also, there is many different tools that are necessary for an oil company to be effective, whether you're an operator or you're a consulting firm or wherever you are, A&D shop, wherever you are in this industry. And I will say that we don't want to be everything. Some companies try to act like they're going to be the entire software stack for a company. And I know why that's tempting, Nick. It's really tempting to be like, oh, we could just go to one vendor and we get everything. But usually, quite frankly, what we've seen in the past is that kind of vendor integration by acquisition doesn't usually have the integrations that you expect because those previous pieces weren't built to work together. So we find it works a lot better for us to work on our core piece as the system of record, and then try to find other vendors that have shown talent, that have shown competency, which hopefully we're highlighting this week, right? And bring those people in and work with ones that we know can live up to a high standard that our clients expect of us and anyone that we point to. And so that's something that we really appreciate about PHDwin Week. And then so after this morning show at 10 a.m. is going to be our flagship presentation for today from our platinum partner, DeGoria McNaughton. I've had the privilege of working with them a lot over the years. This particular engineer, Alvaro in particular, is someone that I really admire, has done a really good job of taking on a lot of our new concepts and helping us kind of move that ball forward as far as where we need to go. And so I'm really looking forward to his presentation and having him on. And then at 11 a.m., if you've been following along with the mini training course with Dr. Wigwe, today is the final part of that mini training course. If you've missed any part of it, we will have the replays available. Right now, all the replays are on YouTube. It's just this one contiguous block at the moment. But the plan is after PHDwin Week, probably next week, we're going to have a lot of cleanup we're going to have to do, but we're going to slice PHDwin Week into the individual segments, and then we're going to have replays of the segments available in our client portal. So anyone who's a registered client has that client portal access. You'll be able to watch the individual sessions. But if you just want to catch up right now with what we've been doing with PHDwin Week, you can just go on YouTube, go on our YouTube channel, and you can see the replays of the previous days. And then I'm on at 1 o'clock talking in depth about details of data. So how data is qualified. This is about version 2 and version 3. So I know some of y'all are still in the version 2 world. This presentation's for you. Some of y'all are looking to move to version 3. This presentation's for you. Some of y'all are in version 3. This presentation's for you. This is just a broad scope of how data is set up across the PHDwin ecosystem. I try to make some analogies. Hopefully, I'm going to make things a little more understandable. But it's kind of tough sometimes to get a lot of data in. I mean, you had your big presentation yesterday, Nick. It's kind of tough to to get as much in that session, right?
Yeah, yeah. I had to I had to kind of speed up at times and try to get it to all work but also be palatable at the same time. If anyone has any questions about anything that I covered in there, I would be happy to meet with you next week, maybe the week after that. Go ahead and reach out to me. My email is njoyce, that's NJOYCE at PHDwin.com. I'm also on the sales team, so you can reach out to sales at PHDwin. My extension is 302, or sales is extension 4. So I'd love to answer any questions anyone has about that.
Yeah, and he would love to give you that demo live, maybe on your data, right? That's a big part of what we want to provide for clients, is that if you bring us your data, we want to show you a demo. We want to give you an idea of how effectively to use the program with the data that you have in place. If you do not have any data, we do have demo data. That's what you were showing off, right? So we could always go to that demo data set. But, one thing that I feel like happens a lot in this industry is that people can do something really well whenever they've got a canned demo, whenever they know the wells well. And I'll tell you, Nick, I'm just as bad about it. For the longest time back in the 2015 area, I would just use the same data set every time because I knew the way the wells work. I knew where it went. I knew where the decline curves would line up. I knew where the auto fit would mess up. It was like a rigged game almost, right? But instead, we really want now, especially in the version 3 era, for you to bring us the data you have. So that way we can show you how to effectively make your company more effective with the product that we have today. We're really confident in version 3 and what it can do with almost any piece of data that you bring to us, a PhD file, a spreadsheet, even an MDB file. Bring it in. We'll do the best we can with it. Right, Nick?
Absolutely. I love, I always say to clients or leads who want to do a demo, I would love to get your data and start working with that, because I like to get my hands dirty. When I was in support, I would always have my hands dirty, and that was fun. I loved having these puzzles to figure out and help out with people's projects, move them closer to deadlines. Some of my most enjoyable days here have been when clients have a deadline and I can actually help them get there, because then I kind of turn it on, and then it's more fun that way. And so, I can do the demo with the demo data set. I can do that all the time, but I've done that so many times. I like to have creative problems to solve. That's always more fun for me. So feel free to bring any of that forward.
Another thing about it is too, Nick, is that we know y'all got to do a real job. I always tell people we're not selling iPhones. Me and Nick here, we're not selling iPhones. There are some people that do click around and PHDwin for fun. Larry Connor, we gave the Connor Award to Larry Connor on Monday. I'm pretty sure he clicks around it sometimes just for I got a couple hours to kill on a Saturday. Let me go click around and PHDwin. But for the most part, most of y'all are using this as a full-time job. We do the surveys, the support surveys. And one thing that's come back consistently over the support surveys is that 50% of the people that use PHDwin are in it full-time, in it 40 hours a week. And that's always stuck with me. That's always something I've thought about whenever we're putting together PHDwin Week, whenever we're putting together training materials, whenever we're deciding what goes into releases and what value to give to people and what to prioritize. And, there's a lot of people I'm getting the calls all week, people that wish they could sit down with us right now and watch PHDwin Week, but aren't able to catch the stream. We do have hundreds of people that have been catching the stream, so we appreciate everyone who is showing up. But I feel for all those that have to work this week and aren't able to come enjoy this. That's why we have the replays available. But that's also why whenever people come to us to support, or their new clients coming in on the sales, we want to help with your problems. We want to go to where you are, whether that's answering the questions you have that day, whether that's converting your spreadsheet, right? We've been doing a lot of that kind of stuff recently. We want to go and make you more effective, because at the end of the day, the software is only going to work for you if we can prove that it can provide real value with the work that you actually have to do, and not just, our favorite, hand-picked wells from the Barnett Shale or something like that. And so that's something that I really feel strongly in. And so if there's anyone that does want to do a demo of version 3, reach out to Nick here. You want to do a demo for version 2 for some reason? I guess that would be me. I'm the version 2 guy. Reach out to me. Again, sales@PHDwin.com can get to either one of us, and we'll be happy to help you out and show you how to be effective in the program. Also at 2:00, Zach Warren's going to come on. He's going to have a really enlightening discussion about data. I honestly think, just seeing some previews of this might be one of the more controversial ones that we've got this year. I think if you don't know what you don't know, a lot of times there's a lot of unknowns in this industry. And we end up teaching clients a lot, Nick, about how data works and about how other data providers format their data. I mean, this is a constant discussion, right? It seems like every day that we have to teach people that API numbers aren't actually like the social security number that everyone thinks they are.
And things change so quickly. We get those updates from data providers. Sometimes we get updates through clients about data providers and things that are being changed. And but we collect that information quickly and we try to spread it out to our client base as quickly as possible. And then we do have a lot of those conversations.
And so that's, part of how we're constantly trying to evolve, as the environment changes, we try to work within that environment, but we're very careful about not cornering ourselves. So that way the client ends up getting cornered as well. I'll give you a very clear example. A lot of people ask why we don't have some sort of auto magic feed to tie into any particular data provider. And the reason is because a lot of those auto magic feeds that just pull in the data without going through like a DRI 98C, something like that, they require an exclusivity. They require certain kind of contractual agreements. That means that we can't be open and work with the next vendor and bring whoever we want on the PHDwin week. You really start to get handcuffed. A lot of these larger companies, again, we're not a large company, but a lot of these larger companies, they use their market leverage to try to keep people in their ecosystem. And, a lot of people don't read those terms. A lot of people don't know what they're getting into. I will say we do read the terms and the data providers, and some of y'all, I don't think y'all know what y'all are signing up for. I see a lot of people doing cool things with technology that is cool, but they're doing it based upon some provider data that basically says in that agreement, you can't do this. And we're very careful about this because we want to be a vendor here for you the long run. We don't want to be sued out of existence for our own reasons, right, Nick? But also because you're relying on us. You put all your data, you put all your work, you put 40 hours a week into PHDwin. We want to make sure we're around to support those efforts. And we want to make sure that if any single vendor goes up too much on cost, changes their terms in some disadvantaged way, that we can be able to pivot with you into whatever the next thing is. And that does require sometimes for things to be quote unquote less slick, but it does mean that we're always watching out for our clients to make sure that we have that flexibility and we can work with new partners like Josh, who I'm about to bring on just a second, who's going to show some really cool technology that we're really looking forward to working with. So I'll bring you on just a second, Josh. Just one more announcement before I bring Josh on. At 3 p.m., we're going to have a quick start. So we're going to have a quick start after this morning session, and then we're going to have another quick start at 3 p.m. And then those are all from QED. So thank you, QED, for providing these excellent quick starts that I think a lot of people have gotten a lot of compliments on those. A lot of people are benefiting from. And then just like the previous days at 3:30, we're going to have a Q&A session, try to bring people back on from the day and try to have a bigger discussion and answer your questions about what we've covered in PHDwin week today. But for now, let's go ahead and bring Josh on and talk to Josh Groves. This is Josh Groves, and he's going to talk a little bit about his technology platform and, maybe how we can integrate some. So hold on one second. Let me bring Josh in. And there he is. Hi, Josh.
Hey, how's it going?
Welcome to PHDwin week.
Thanks so much for having me on.
We appreciate having you. So give us a little bit of background, Josh. What do you got going on over there?
So my personal background is I started working with a couple operators. I'm actually here in Newfoundland in Canada. And so I started with a couple operators, offshore oil and gas there. Going up through my career, I worked as a consultant for a while down in Houston and Calgary. So kind of grew up through the shale revolution. I really started in 2013 in Houston. And so got a lot of exposure working with operators all across the US. And then started running development teams. I switched over from consulting onto the software side, led development of a couple major oil and gas applications. And then that takes us up to 2021, where I actually decided to go out on my own and form Pod2 with Matt. And so Matt Harriman is the CEO of Pod2, and he actually started it in 2019. Our experience has been mostly on upstream planning. So, rig scheduling, the broader asset planning or field development planning, operational scheduling, all of those kinds of workflows. And so Pod2 is both a consultancy and a software company. And so we started, Matt started it, like I said, in 2019. He started by consulting with operators all over the place. Again, on those planning workflows, trying to understand every level of the planning organization and how to improve it, each one of those workflows, and how they integrate across the organization. And then when I joined in 2021, I started building up the software side of Pod 2. And so that's what I'm talking about today. But the software side started with a couple applications. So we created one free application called the Upstream Planning Radar, which is just trying to show the ecosystem of all the different tools and software in this space, because there's so many and people don't know which ones integrate. So that was just a free one that we put out, and that was to support the consulting side of the organization. And then after that, we created an Aries QC tool called the Pod 2 Validator. I think it was referenced earlier this week, actually. So that one is meant to go through Aries databases and just apply QC checks, like make sure that all your B factors are in a reasonable range, because everybody's dealt with that before, or like make sure that we didn't miss an exponential segment at the end of a forecast. So that was the next product that we put out, and that was really to test the market and make sure that we're able to develop software and deploy it and release it to customers. And then the newest product is the Pod 2 Planner. And so that is exactly what I was mentioning earlier. So rig scheduling, field development planning, basically any planning workflows in upstream oil and gas, we're interested in supporting with that tool.
I think that's excellent. And yes, you are exactly right, Josh. We did reference, so whenever Kimberly Ayers was on Monday, we did reference your validator. I have to admit, I did not know about it, obviously, because it's not a tool for my program. It's a tool for a different program, until she brought it to my attention. And I thought to myself, really, that's what the other side has to deal with, that they need to pay a third-party application to go through and clean it up. Just to be clear, I really want you to show, we talk about your entire ecosystem, but I don't see that particular tool ever coming into the PHDwin space, if only because a big part of how we've set up PHDwin is to make sure the data is valid before we get it back into that back end in the database. But I'm glad you provide that tool. I know a lot of people here, like I've started asking around, and it's a very popular tool. A lot of people are depending on it to make sure that whenever they're in that ecosystem, things kind of glue together. But that's what we pride ourselves on, is to make sure that our forms and all that are kind of doing the checking along the way. But, we're all about an ecosystem also, where if someone comes up with a good idea and a better way to do things, we're all about that. But we're really about data consistency. We call it data discipline, Josh. That's what our big mantra is internally, to make sure as we integrate with other tools, as just the different parts of our program work together, you can't put in like a Q for a B factor or something in our form, or in our grid editor, you can't put in just like a nonsense date in that form. So that way garbage data doesn't get back into the database. But we do understand that's not how the workflow is with all the other software. Some of them, people are just really hacking on the database, in which case you need a tool like yours to clean it up, right?
Yeah, exactly. And that's where it came from, is just over the years working with, I've worked with every popular economic software out there, but Aries especially, building integrations with Aries, we kind of struggled with that, because a lot of the time was actually spent rather than integrating, we were actually trying to debug what was wrong with the database that we were bringing in. But PHDwin, we used to integrate with PHDwin version 2 back in the day too. And, we never had those types of problems. Like it had its own complexity, but the data quality generally tended to be higher, which is great.
I want to be clear to everyone here. So at this point, we don't really have any integrations to show the audience yet. I wanted to bring Josh on. Josh was kind of last minute. I really appreciate you kind of jumping in last minute, Josh, because I feel like you've got a great tool. You've popped up, your tools have popped up a lot in conversations that I've had with people recently. And also, Josh really influenced what we did for PHDwin Week this year. You reached out to me last year. You talked about how you like to see more technical sessions from us. On Monday, I really did a deep dive in our SQL data set. I honestly would never have done that if you wouldn't have mentioned it, because we really like to keep the complexity in the background somewhat. We don't want our clients to be scared of thinking they have to be wizards. That's why I spent, like, whenever I did that presentation, I spent like 5 minutes going, what do you need to know in SQL to use PHDwin? Nothing. I did this whole song and dance. I had the top hat to make sure people understand they don't need this. But sometimes maybe we go too far. Maybe sometimes we're not as clear, that you can do these things. Because the other side of it that we get nervous about, and I know you'll understand this, Josh, is that that other data set that you work with a lot, that other vendor is pretty stable at this point. I mean, those tables aren't changing that much. You get more customization of what we see on the tables by individual operators than the actual vendor changing it. While we're changing our underlying data structure in version 3 pretty significantly from build to build. And the next build, we're actually going to have a new qualifier. We're completely qualifying the taxes as its own bucket, right? And that's requiring like half the tables underneath to be redone. And you know how database works. Whenever you touch here and you change the structure here, that can have a lot of effects all over. So we, in the early part of version 3, have been nervous about people building too much on top of our current data set, because we wanted to have the flexibility to be able to change things along the way and not get it where it's ossified. Like, because it will get to a point where once we have the main features out, once we've done the things that we've really came into version 3 to want to do, we'll get ossified, and we'll get to the point where you can build the integrations on top without coming to us. But now we want people to come to us and talk with us, because we might change things, we might break it and we do have some people that try to build some stuff on early 3 that's all broken now. And I'm sorry, y'all, but we try to be upfront about it, that we need to be able to change and pivot to be able to extend this as more and more companies are using version 3 to be able to account for those needs. But also, we want to stay in our lane. So to get to your rig schedule a little bit, Josh, I'm looking forward to integrating with this tool, because this is something that we're not really wanting to get into as much. We do have a project manager, right? Nick, tell them about the project manager a little bit. Tell our audience about what the project manager can do.
Right. So that's where you manage. I mean, in my experience, I'll do these demos a lot where we have to build prospect cases based on a group of picks, from a certain field, average out that production, make a bunch of type curves, or make a type curve, use the type curve as a success case, create a bunch of prospects, and then you manage those prospects in the project manager. And that's where it is all grouped together into one project. So that's usually what I've used that for.
But it's really about controlling economic timings. We're back to economics. Right. We're back to forecasting. So our rig scheduler, I feel, is a really good tool especially compared to version 3 that had nothing like it. It was just like a wizard to make duplicate cases almost, and then you're off to the races, right? So we do have this new way of managing timing for rig schedule, but people come to us and go, well, wait a minute, Jonathan, there's just one bucket here for fixed costs, but I have a whole stream of fixed costs, because I got the truck and I've got the rig guy and his safety hat and all that. Where do I put them all? And I'm like, stop. We're not an accounting system. Stop. We're not going there. We're not going to go to that level of granular detail. We just want to be able to connect to some other system and bring that economics in. We want rolled up data. We want the total overhead. We want total completion, right? We're not going to get into that nitty gritty. So I really appreciate a tool like yours that can get more of that granular detail and also can be flexible with how the scheduling works. You're just dragging around on the calendar, right, to change that timing. When us, it's it's more back to like the QI and the start date and all that, and changing economic timing rather than like rig timing is the way what we see it. And so we think that there's a lot of potential here to integrate with a product like yours and extend it in a direction that we really don't want to go, but I know the need is there. And so do you have any thoughts on that, Josh?
Yeah, for sure. And that's where we started with this, the Pod 2 planner. It was just working with, like I said, the consulting side of Pod 2, meeting with operators, and everybody saying to us, we have our rig schedule in Excel, and then we take the timing out and we put it in PHDwin or another economic software. And Excel is not working for us anymore, because it was fine when we had one rig, but now that we have 2 or 3, it's just unmanageable. Or especially for smaller operators, a lot of the other software out there for bigger schedules isn't a good fit for them, just because it doesn't work intuitively, or the costs tend to be higher. So they're looking for something that matched how they wanted to actually rig schedule things out. So drag and drop on the schedule, like you said, a simple UI and integrations with all the different software that they use in their organization. And so that's why we started building it. We worked with operators during our beta period. We had a closed beta, and worked with operators to actually design the entire UI around their workflows. And that really influenced the design early on. And then once we felt comfortable that we had the design right, that's when we opened it up and had a public launch. And so, yeah, just like you said, people definitely have a need for this, and a lot of the existing solutions just weren't working for them.
Either they weren't working or they've gotten sucked up by these big companies that I'll just be honest with y'all. I know y'all ask for us to integrate with, but they don't pick up the phone whenever John Smith at TRC calls, right? And so, and so that's why I love bringing on someone like you that's competent, that's got a great reputation, that's already working with a lot of people in our ecosystem. We have, a lot of mutual clients that really appreciate the work that you've done so far to go in a direction that we don't really want to go. We don't want to pretend like as a small company we can touch every single part of the industry. We really want to be the system of record. We want to be like the data warehouse that you're pulling the data out of to do the scheduling, or pulling the data out of to do the visualization and Spotfire, that sort of thing. And so that really means focusing, staying in our lane, making sure that we have good economics, making sure that we have good sensitivity models, good ways to do things that a lot of these quick platforms can't do. Like, as I said, like we can't break down the cost on a rig scheduler, but I can give you differentials scheduled out for 30 years, right? It's just where do you put that effort? Where do you put that time? And we've always tried to search for that balance. And I think that your platform and your company is a really good complement to what we're doing in our ecosystem. So I'm going to open it up a little bit for you, Josh. If you want to share your screen and show people a little bit about what you're working on, I think everyone at this point, I think we've got the anticipation up. Let's go ahead and get a little demo,
right,
if you don't mind.
Sounds good.
All right, let me pull it up real quick. Here we go.
How's that? Okay. So what you're seeing on screen now, so this is the Pod 2 planner. And so it's a desktop application, and there's a lot of different reasons we did that. But one of them is because we can allow really quick iterations locally. So we don't have the latency overhead, but also we can do integrations with other on-prem software. So if you're running any other software locally and you need to do like a database level integration or connect to files or other tools locally, then you have that option with this. So the first screen you see when you open up an existing plan is this schedule overview. And so down on the left here, we have resources. So this is anything that you want to actually be able to see visually as part of a plan. So it could be things like construction crews, drilling rigs, frac crews, or you could even do things like permitting or other resources here. So it's open. It's whatever you would want to see on this kind of view. And then going across the right here, these are all the individual activities. And so right now I'm grouped by pad, but you can actually drill into the individual well level. So I'll zoom in here. And so each one of these colored boxes here, these are activities on one pad. So I switch back and forth between a group view. You can see it's grouping it up to the pad level. Also configurable. So some people run development campaigns that are larger and they want to group everything together. So that's also totally possible. And so what we've tried to make possible here is the most common workflow people have is, I have this well and I originally scheduled it out on this date. And so what you're seeing right now, everything's been automatically scheduled based on a bunch of rules that describe how things should be laid out on the schedule based on prioritization and which dependencies exist between activities and that kind of thing. So what happens here is I can actually drag and drop these live on the schedule, and I can see exactly what's happening as I do that. And so if the well turns out I can't actually drill on this date, I can just move it out to September. And as I do that, you can see it's trying to fill this gap that was introduced by any other activities that fit in there that still prioritized, but it'll try to fill in any gaps so that you don't have this this downtime on your rig for no reason. So you're trying to avoid laying down the rig. And sometimes moving the date's not enough, and you actually want to schedule onto a different rig. So you can just switch rig lines just by dragging it and dropping it. And even before I let go of the mouse, we'll already see the impact, exactly what's happening to my schedule. And also not only my schedule, but you might have noticed on the bottom here, we also have a bunch of metrics that you typically care about in a planning workflow like this. So that's things like CapEx, production, revenue, and we're expanding this over time. So it's basically any metric that would be important to you while you're moving things around on the schedule. So as I'm moving this pad, you can see exactly what's happening to the production live. And so this is really handy also, if you're trying to stay under a CapEx budget for the year, you can choose how you want to view all of this information. And so this is the scheduling option. And so we also have the option of doing prioritization. So this is actually saying exactly which date it's going to happen on. But you can also say, you know, I just want to prioritize things. I just want to rearrange my schedule. I don't necessarily want to hard code a date for anything. And so that's why we have planning mode. And so in planning mode, you're just changing the order of these things. And so when I do that, you can see these are all just snapping into place. So I don't have to manually position it exactly right. It's just reprioritizing things on this rig so that it'll use the order that I want. And there are lots of reasons to do that, but this is also extremely popular. So again, built around the exact workflows that people are running. All the information for this, I mentioned the drilling rules earlier. So all of the rules are described by these development templates. So we have all the activities that each well is going through. So for each one of these, I can specify default. So by default, I want to have a lookup and figure out my drilling duration based on the well type. And you can scale these based on things like lateral length or any other variables that you'd like. So you have default durations for everything, which of course can be overridden. So each one of those activities I was showing, you can change the duration from 10 days to 20 days. So as you know information about what's actually happening, so in other words, as you have actuals about the drilling duration, then you can just put those durations into your schedule and it'll auto schedule around those. And this also describes things like when first production should happen based on the template, how things are grouped together. So some activities might make sense to develop as a pad, and some others might make sense to have a larger group, so like a development group or a co-development group or something like that. So those are the rules. The resources, so they're pretty simple. So you have things like mobilization, how long it takes to mob between activities on a different pad, for example, and then when the resource is available. So all the assumptions, pretty straightforward. So they're all in here like you probably expect. And so this is how we come up with the default schedule before you start tweaking it, and all the metrics that you saw in the other view there. And so just jumping to the inventory. So this is actually where you see all the individual wells. So if you click on any well here, you can see whatever attributes are important to you. So, you know, this is a pretty typical setup where you might have API number, a basin, lateral length. And again, you can use all of these variables in formulas. And so all of the well information, so we have ownership here, shrinkage, all the things you'd probably expect. So this is a really quick tour of the planner. So one thing we have under settings here is all the different integrations that we support. And so this list is growing all the time. And so as Jonathan mentioned earlier on, we are really interested in adding a PHDwin integration. And so I actually prototyped something yesterday. I'm on a 10-day trial of PHDwin. So I have 9 days left to complete the integration unless we can figure something out there.
I'll give you more time. Don't worry, Josh. You're good.
Sounds good.
We'll get it going.
Okay. Yeah. So, you know, the idea is that the timing that you saw in the schedule, we want to make it really easy to bring into PHDwin. And so you can do it today already just by using, you know, we have these export options. So if you wanted to just export the schedule dates, you can just hit export and it'll open up Excel, kind of like how some of the PHDwin grids work. So you get this view. And so you could technically bring these dates, all the timing, right into PHDwin in this format. You know, you might have to reformat it a little bit, but it's all there already. And so some people are doing that, but we want to have direct integrations. And so the idea is you could select which SQL Server instance you want to use, which PHDwin database and scenario, so that we can get the qualifiers right. And then have a really simple interface like this, where it's a push button, so you could have export to PHDwin. And so in PHDwin, what that might look like, again, this is a prototype. So I have these two wells here from my schedule, and so they just have some default timing. So these are PUDs, so they're future dates, and so these were just guesses based on an old rig schedule. But now that I actually know from the planner what my rig schedule is going to look like, I can actually hit export to PHDwin. And so when I do that, there's no progress indicator right now. But when you swap back to that well, you can actually see the timing come across. So that was actually scheduled on December 24th based on the updated rig schedule. And so the idea is to have this kind of really simple workflow so that you can update your rig schedule. Once you're happy with it, you can publish it to PHDwin. So this would be first production dates, but you could also do things like CapEx timing. So one thing I didn't show is under CapEx models, you can get really detailed on how you want CapEx to be forecasted for future wells too. So these can be formula based, and we handle spread across the months, or if you want to offset when the CapEx timing actually hits, you can describe all that in here. So one other area that could be interesting is bringing across CapEx timing or some other timing that might be interesting on the PHDwin side, because then you can start using those dates for your economics.
I agree. I could see CapEx timing. I can see actual forecast timing. And also, I mean, you've got revenue in this tool, right? So I could see a thing where we're going back and forth and you're taking our calculated revenues and sticking it in your tool. So that way they align between the two programs, right? So there's a lot we can do here. One thing I wanted to bring you on, Josh, normally I will say, normally I would not bring someone on. You did great here to come up with a demo. Normally I wouldn't bring someone on unless we've gone farther along with the integration. But I kind of wanted you to be on this call and kind of show our ecosystem what you're working on, because we would really like to build an integration like this around a client. So if you're watching this right now as part of PHDwin Week and you're like, man, I need this. I'm a PHDwin client. I need a tool like this. Give Josh a call. Reach out to me, jsmith@phdwin.com, and let's try to build integrations around your actual workflow and make it really practical, because I think me and Josh are on the same page of we want to go with actual client workflows, and me and him can sit down and think of a million ways to integrate, but what's the best way that works for it? And I don't know about you, Josh, but at least for us, whenever a client steps up and sticks their neck out and says, I think it should be this way, then they end up being the one to define it for pretty much the rest of the ecosystem. We really look to those people that I call them flag carriers that are willing to stand up and say, I have an idea, I have a dream, I have a vision of where this should go. And then guess what? They're the ones, you're all copying them, right? So, so much of how we do water forecasting, it was Larry Connor, you're all copying him. Or how we do wellbore completion. Yesterday, we had the Jessica Bird on from Blackstone Minerals. You're all doing it how she just defined it, right? And that's not to say that we're not willing to be flexible. We're not willing to change things, but we like to be practical, and we like implementations to come on the world. So that's a great tool, Josh. I have to admit, Nick was sitting here gasping next to me as you were showing it. So you got a good demo there. We look forward to working with you more on that. I want to kind of back up a little bit in the time that we have remaining, though, because one thing I think is critical about your tool, and one of the reasons why I think we can, do it integration, is that you do have a local tool. The part of the big conversation in the industry right now is, local tools, local databases versus cloud hosted databases. And a lot of people come to us and out the gate, they go, okay, you cloud hosted, right? There's either almost an assumption, or that's like the first question. And, we're on-prem. We do everything on-prem. Our SQL server is installed on your computer. We're just like you, where everything's local. Some of the reason we do it is what you mentioned, is for latency, but some of it is also just the fact that, I'm with these big banks, and there's so many requirements for data and all that. They don't want data to go off site. They have the SEC, everyone breathing down their neck. And so it's very difficult to have a chain of custody for that data. But whenever it's all on-prem, they can manage that, right? Isn't that a real advantage, Josh, for an on-prem setup?
Yeah, exactly. And our whole philosophy around the entire technology side of Pod 2 is we'll just use whatever ecosystem makes the most sense. So when it comes to choosing whether we run on the cloud or on-prem, we're kind of agnostic. So, we'll use whatever makes the most sense. For this tool specifically, for the planner, that you want to have fast interaction. So if you're dragging and dropping, you don't want to make a request to the cloud and maybe the cloud is really fast, but even still a split second, we're talking about it in terms of milliseconds here. So you want it to go as fast as possible. And so that was a big reason for us. Being able to connect with other vendors locally was important to us. So, a lot of the cloud-based solutions need separate client applications that then sync between on-prem applications and the cloud. So we wanted to avoid all of that just to make things as easy as possible. So like the single push button would be possible with PHDwin, for example. And yeah, absolutely keeping data locally so that people can decide how they want to store it. That's another big reason. So it makes security questionnaires for operators really simple, because it's up to you. However you want to manage your data, it's your own data, so you can decide. So that is a big part of it. So yeah, our philosophy is we use the cloud where it makes sense. And so some components might be cloud based. So if it makes sense to, run a lot of different simulations on the cloud because that's what you want to do, then maybe there's an opt-in to that so that we can offload some of the calculations to the cloud, or like our license checks are cloud based. So there are certain cloud components where it makes sense, but otherwise, yeah, for this application, it makes sense to be on-prem first.
That's a great point, Josh. And I want to be clear about that. We try to do the same thing as well. So we have the training classes that we do every other month in Houston. And those training classes that we do are actually cloud hosted. So anyone that goes to those training classes, we have a cloud implementation of version 3. When you sit down at the desk, you're actually going into our cloud, and that's what you're working in. And it's a good experience. I mean, we built version 3 to be able to, if you want to host it in your own cloud, we can do that with you, and we can set up that good experience. But at the same time, there's two things that keep coming up that I keep coming back to that I think a lot of people don't realize, which is, first of all, what you talk about, the latency. A lot of times people don't realize that there's that latency, and whenever you're going back and forth, there's some things that you can't do as easily as whenever you're sitting there. And sometimes in those classrooms, people will have, the different screens will refresh at different times, whatever. We have a classroom of 20 people. And so we have to have pauses and all that to make sure everyone's looking at the same thing. The other side about it too, and you might be able to speak to this, Josh, is it's more expensive than people think. A lot of these cloud products, they come in, they get venture capital back, and doing so, they kind of hide the cost of what all that data costs and the hosting costs and all that. Yep. We try to be really transparent about our costs. We actually did a look into it. And if we ran our cloud product like full-time 24/7 that we're doing the training class, it costs something like $20,000 for an implementation, which is much more than what we're charging for our on-prem product. And yeah, sure, there's some companies that are like, I can do that, I can afford it, and it's great. And we'll work with you if that's what you want. We could help you set up that, right? But if a lot of our clients, I mean, I just said that number and they went, what? And that's not what they're expecting, because maybe they get in a product that they're basically being subsidized by a venture capital money or something like that, and then some initial period. And we both know what the game is. The game is to lock up their data and to make it so that it's in some sort of castle. So that way, once you get past the introductory period, you're having to pay the big actual rate, right, to get your data back, to get access. And then also, we've tried to work with some of these companies, and they put in their terms and conditions selling things like insights out of your data, or, selling derivatives out of your data. And a lot of people wonder, how can these companies know really well what the expense is in each individual field and all that? Well, guess what? They're hosting your data over here, and they have an insight that they boiled out over here. Sure, they scrub the names off, they file the serial numbers off, but that's part of the terms and conditions to be able to move this data around. And we don't really want to be in that game. We're not venture capital back. We don't want to subsidize people in and then pull the rug out from other way. We really try to be really transparent about our costs. But that's not where the industry is, and that's sometimes not where people's headspace is. And they don't realize how much these things can actually, the expense that can actually be had for doing these things off premises. And so I don't know if you want to speak to that or not, but that's what our experience has been.
Yeah, absolutely. We're kind of the same. So we're self-funded and or bootstrapped, and any savings that we can get and pass on to our customers, we're going to take that, because we don't want to just opt into the cloud just because it's the modern thing to do, or the normal expectation. We'd rather look at the workflows and design technology directly around those workflows, what's going to work best, rather than what people think might look good, because that is the problem, that the cloud costs are really high and people don't realize. A lot of these cloud providers, they do have periods of time, like you mentioned, that you can get discounted credits, or you get so many free credits, and then once that runs out, then that's when you have to cover the cost somehow. So either your subscription fees go up, or you do something you have to cover the cost somehow. And so our philosophy on that is always, we're going to try to reduce overhead as much as possible and pass those savings on to our customers. And that's part of the reason why the planner is way less expensive than the other planning tools out there.
That's why we're less expensive too. I'll just say it, than a lot of our competition, is because we're doing the same thing. We bootstrap everything. All of our technology is built out of our cash flow, and we're not beholden to anyone. Because here's the thing, people, whenever you go with the venture capital backed product, those people want to be paid back. Those venture capitalists are not investing just to support you forever and subsidize the industry out of the goodness of their hearts. They're looking for an ROI at the end of it. And I think a lot of times people get short-sighted because they see a great introductory rate, and that's what they get pulled in on. And it's not just here in this industry. I mean, the cable company, the phone companies, switch your phone plan or whatever for X amount of money. It's the same thing. It's about lock-in. It's about getting people, moved over, and then boom, here's the real bill. And so let me ask you one last thing when we got just a little bit of time left. Can we hear a little bit about the company culture at Pod 2? I want to hear about your vision, your long-term view. It seems like that's something that y'all really consider.
Yeah, absolutely. So our driving mission or what we think of that looks like for the company long term is we just want to improve work generally. And you've probably seen our tagline around what we say, like, work shouldn't suck, basically. And everything we've been building is around that idea, is that if you speak to a lot of the operators, especially, the turnover rates are higher than ever, especially in planning teams. Like, that's our expertise. We work directly with planning teams. We see people quitting their jobs because they're just not happy anymore. And so we want to figure out ways to improve that, because people shouldn't have to go to work miserable every day. So we want to find ways to improve that. And so that, hearing about people's experiences with last minute economics changes, for example, led to the creation of our QC tool. Because if you can catch things up front, then maybe you're not having to stay up all night reworking your database because there are problems that slip through. The planner started because, like I mentioned, people weren't able to keep up with what they were trying to do in their workflows. And it was the same thing. People were working over the weekend, missing out on all kinds of stuff just because the tools that they had weren't sufficient for what they were trying to do. So we just want to improve work generally. And we believe in that. Everybody that works in Pod 2 believes in that fully. And we really try to embrace that philosophy within our own company culture too. If we find things that just aren't working at the company, then we try to cut them out or find another way to do it. We just really believe in that idea that work should be something that you can look forward to rather than it's kind of like a drag every day.
Well, I think that's a great philosophy. I think that you've got a great product there. What do you think, Nick? Isn't this pretty good?
Oh, I'm very impressed. That was a really good product, really good presentation.
Yeah, you have a great demo, Josh. And don't worry, we'll be working with you. We'll be making sure you get more access to PHDwin. As I said, if there's any clients out there that want to work with Josh, want to work with us, you see a future for your company here, be sure to reach out to us and we'll connect you with Josh and we'll make sure that we work some things together. But Josh, thank you so much for jumping on PHDwin. Let everyone know where to find you real quick, if you don't mind.
Sure. So our website is pod2, like number 2.co. We're all pretty active on LinkedIn, so you can look up Pod2. That's our company page, but look me up individually. Josh Groves, CTO of Pod2. Matt Harriman also posts a lot of good things. He's, like I mentioned earlier, he's the CEO of Pod2. He's probably even more active on LinkedIn than I am, so definitely worth a follow. But yeah, reach out anytime. We also have we started a Slack community a while ago. Just for the broader ecosystem. It's just called Upstream People. It's not like a Pod 2 branded thing or anything. It's just we wanted to have a community outside of LinkedIn where people could chat back and forth. So there is an open Slack community. If anybody's interested, you can message me. I post it on LinkedIn from time to time. We have some great conversations on there. We just had a really interesting conversation about using convolution to model shut-ins and ramp-ups for production forecasts. So that might be something that viewers are interested in. So if that sounds interesting, please just message me, or you can find the link on LinkedIn.
You know what? We're interested. Send us the link and we'll be pushing out to our clients. How about that, Josh? We'll get you some.
All right.
Well, we were interested in that. We want to be part of that conversation. So thank you for being part of PHDwin Week. Thank you for jumping on kind of last minute. I know I kind of caught you like very last minute on this, Josh, but you did an incredible job for very little time. So we'll be working further. I got to let you know, there's a lot we can overlap. There's a lot we can do. We love your company's philosophy. We love the work that y'all have done before. So I'm looking forward to working with you. And thank you again for jumping on and being part of PHDwin Week 2024. It's been great.
Awesome. Thanks so much.
So that's Josh with Pod 2. Be sure to look. We'll send out some email information so that you can follow up with Josh and maybe get in his community. For now, we're going to sign off on the morning show and switch over to a quick start from Aaron Randolph, who, a lot of people can think is one of the best trainers in this entire industry. So I'm really looking forward to that. So Aaron's going to talk about shrinkage models in version 3. So we're going to go ahead and start that in just a couple minutes. But again, thank you very much to Josh. And thank you all very much for joining us on PHDwin Week. Tomorrow, 9 a.m. will be the last morning show, and we've got a very special guest tomorrow from the OGGN network. So I'm looking forward to that. That's going to be a fun day tomorrow. We got a lot of fun stuff for tomorrow. But just again, to finish out today, so after the quick start, 10 a.m., our flagship presentation with D&M. And then after that presentation, I'm going to bring Eifert Lee on, who works with D&M, and we're going to talk a little bit about international economics and PHDwin, and how we're trying to do our best to work with partners like D&M to make this entire industry a better place. But thank you very much, Josh, for jumping on, and thank you all for watching. Just a little bit, your stream will update, and then we'll get into that quick start. But we appreciate it. Thanks, guys.
Aaron joins us to present shrinkage models in PHDwin v3. Please welcome Aaron.
Hi, I'm Erin Randolph from QED Energy Associates, and in this QED Quick Start, we're going to cover shrinkage in PHDwin version 3. Where do we find shrink in PHDwin version 3? Well, there's a form for it. So in this forms flyout, under case production, there's a form for shrinkage. I'm going to double click on that to open it up in our work area. And we can see the products associated with the selected case. And you can see we can shrink any product. I'm going to select gas. So I'm just going to click on gas and drag it over to this area and drop it. In the percent field, you're going to put whatever percentage is going away. So if you wanted to shrink gas by 5%, we would type a 5 in the box. Now, what if we wanted to check the shrink on all of our cases? Well, I would look at the grid editor for that. So in the flyout, I would, open up grid editor, and I drag all of my cases into it, select shrinkage from the menu on the left, and then click edit. And this is going to show me what my shrink amount is on each of the cases that I selected. And I can see I only have shrink on that first case. So if I wanted to add my 5% shrink to all of these cases, then I would want to create a model for shrinkage. So I'm going to open up my models form, and under the shrink model group, I'm going to add a shrinkage percent for the product gas. I'm going to call it and give it a double click, give it a name. I'm going to call it 5, let's spell it out, 5% shrink. And then I'm going to put a 5 in the box. Okie dokie. So now I've got my shrink model, and now I'm going to use the global editor to add this model to all of the cases. So open up that. I'm going to select all my cases. I'm just grabbing the summary node in my case list and dragging it over, and that pulls all of the cases under that summary node into my global editor. In the shrinkage group in the available fields section, I'm going to grab shrink models and drag it over. And then I want to apply a shrink model that I just created to the product gas, because the model I created was for gas. I'm adding a percent, and then this is the only model that exists, so it automatically populated. So now for all of the cases that I have selected down here, which is all 40 of my cases, it's going to apply this 5% shrink. I'm going to click apply. Global edit is complete. Now I want to check, that this model did apply to all of the cases. So I'm going to go back to my grid editor. I'm going to select, make sure shrink is still selected. I'm going to make sure I have all 40 of my cases, which I do. And I'm going to click edit. I'm not really going to do an edit. I'm just going to check that this model column has my 5% shrink on it. Additionally, you can make models that have multiple segments. So if you know your gas is going to shrink by various amounts over time, you can time that out in your model. That's it for shrinkage. Thanks for tuning in.
At QED Energy Associates, we can provide lots of reservoir engineering tech services. We do database conversions every single day. Next time you have a database conversion you need, feel free to shout out to us to get a binding quote. We provide reservoir engineering techs on-demand consulting services. We can dedicate a technician to your account. They can work at your office or at our office. You can hire one of our technicians at any time. Please check out our custom classroom training services or our one-on-one training services that can be offered in your office. At QED Energy Associates, we believe that competency and years of experience don't necessarily go hand in hand. So we test every technician on our team to ensure the level to which they are currently competent. It's my job at QED Energy Associates to make sure that every purchase you make is a good one. If ever you buy something from QED and you're not happy with it, please contact me, Courtney Stevens, directly at our office. You can get us at any time at dreamteam@qedea.com. Thanks so much to John and the team at PHDwin. This is the team over at QED signing off from another great Quick Start.
Thank you.
Thank you, Aaron. That was very informative and a great quick start session. We really appreciate QED Energy Associates for all their great quick starts. Our next session is going to begin at 10 o'clock. And so make sure to catch it. This is going to be D&M talking about some advanced techniques. I know y'all don't want to miss that. And so in a couple minutes, in 2 minutes, we're going to have Alvaro from D&M on to talk about what he's been working on. And then afterwards, after that presentation, I'm going to bring Ifer Lee on with me to talk a little bit about our work with D&M and our work across the world with PHDwin. And then Alvaro is going to come back at 3:30 later today and answer your questions. So don't miss this session. This is one of the highlights of PHDwin Week this week. D&M at 10 a.m. starting in about a minute. If your stream does not ever automatically update, we've gotten some notes sometimes on YouTube and all that doesn't update, just refresh your browser and then you'll be able to catch back up. Thank you very much.
Our next keynote presentation features a new speaker from a top reserves consulting firm on PHDwin Week. Alvaro Betancourt became part of the DeGolyer and McNaughton team in 2017, bringing his expertise as an engineer. With a wealth of experience in reserves and resources assessments, Betancourt follows both SEC guidelines and the PRMS framework. His work spans various conventional and unconventional fields, not only in the U.S., but across the globe. He has a deep understanding of low and ultra-low permeability reservoirs, as well as experience with secondary recovery projects like water floods and steam floods. Betancourt's contributions also include tertiary recovery methods, such as carbon dioxide-enhanced oil recovery, for both independent and publicly listed oil and gas firms. Please welcome Alvaro. His presentation will cover diagnostic-driven multi-phase well performance analysis and production forecasting.
Good morning. Thank you for attending my presentation at PHDwin Week 2024. My name is Alvaro Betancourt, Senior Engineer at DeGolyer McNaughton. The presentation for this morning is entitled Diagnostic-Driven Multi-Phase Well Performance Analysis and Production Forecasting. The topics that will be discussed throughout the presentation can be grouped into two main subjects. The first one is diagnostic-based decline curve analysis. Here we are going to talk about various methodologies and approaches utilized to derive a decline curve analysis forecast. The next topic is multi-phase decline curve analysis. Here we are going to start by presenting this methodology step by step and show examples to validate the process. In addition, we will have a discussion on gas-oil ratio profile estimation through an empirical but data-driven methodology. The question posed in this slide is the following. What can we do with our data? This is our rate and pressure information to extract useful insights for well performance analysis and forecasting. The main reason for this question is that rate and pressure are the most basic pieces of information which are easily and readily available. In most cases, the only pieces of information we have to perform analysis on well current and future performance. One answer to this question is based on data operations. And by this we mean taking our base, rate time, and pressure information and transforming it in as many ways possible so that trends or diagnostic signatures come to the surface. Here we are mentioning some data operations such as auxiliary functions. The most common example is the productivity index or the normalized rate by pressure drop. Data smoothing. There are many mathematical methods to accomplish this. The most common are rolling averages and different types of splines. Calculus, and by this we mean numerical derivatives and integration. This is going to be a very useful concept for our analysis, and I will expand in future slides on this topic. There are other data operations such as more advanced mathematical functions and transformations and artificial intelligence algorithms. I will not go into the details of these, but it's a topic that is having a lot of interest in recent times. To conclude, some practical advice. Please do not oversmooth or over-edit the data. By changing too much our base data, we risk losing the character of the trends. There must be a balance when applying our data transformation, and we must try to maintain data fidelity. In this slide, I will introduce the QDB plot. The QDB plot is a log-log graph in which three data functions are plotted simultaneously: the rate, the nominal decline, and the p-value. These three data functions are the basis for formulating a variety of decline curve relations, from the traditional ARPS exponential and hyperbolic functions to modern relationships such as the power law exponential model. The decline and p-value formulations are based on ARPS definitions using rate time information. The decline is obtained through the derivative of the rate, and the p-value is obtained through the second derivative of the rate. These two functions are graphed along with the rate to construct the QDB plot. The examples of this slide show the QDB plot for three wells in the Permian Basin in three different reservoirs. The diagnostic work starts by observing the decline behavior or trend. A power law signature is commonly observed. By this, I mean a straight line graphed on the log-log plot. Note that the ARPS hyperbolic model approximates a power law model in late times. The QDB plot is a powerful tool to assess the p-value over time. In the traditional ARPS hyperbolic model, the p-value is a constant, and the QDB plot helps identify the late time p-value to be used to predict future performance. The QDB plot is a powerful tool to generate a diagnostic-driven decline curve model in a short amount of time. An additional diagnostic function that is used to determine the p-value behavior is the beta derivative. The beta derivative is directly related to power law type flow regimes, but it can be used to investigate late time p-value by approximating ARPS hyperbolic model to a power law function. Here, the p-value will be the reciprocal of the beta derivative. The beta derivative formulation is based on a single rate derivative. This is useful to avoid excessive data noise that is common when successive derivatives are computed over the rate data. In the examples presented from the Permian Basin, the beta derivative was computed and plotted on a log-log graph. The diagnostic work starts by identifying a late-time beta derivative value, and from it, obtain a p-value used in the hyperbolic model. The beta derivative plot is utilized along with the QDB plot for a more robust diagnostic interpretation of the parameters used in the decline curve models. Continuing with the diagnostic interpretation of the decline parameters, one of importance is the assessment of the terminal decline. The terminal decline is a parameter that defines the modified hyperbolic rate time model and is the decline value at which the hyperbolic model switches to an exponential model. The diagnostic work starts by computing the decline from the same formulation utilized in the QDB plot. The difference in this example is that decline is converted from nominal to effective, which means it will be measured in percent change per year. Once this function is computed, it can be plotted on a Cartesian scale graph to identify trends. The example shows a group of wells from Marcellus Shale which have a common decline behavior. The group trend can be extrapolated to a late time value, and the final value read will suggest a terminal decline. In this example, the group of wells shows a terminal decline of approximately 5% per year. The diagnostic interpretation can be further validated by comparing the trend of the group of wells with the trend of an older vintage well that has long-term production. In this example, the older vintage well clearly shows a terminal decline value consistent with our interpretation of the group of wells. One of the main assumptions for the validity of decline curve analysis is that the well's flowing pressure should remain constant. This is rarely the case in many operations, especially in unconventional reservoirs. One option to address the changing flowing pressure in the well's life and be able to apply a more meaningful decline curve assessment is to use the pressure drop normalization of the rate data. Theoretically, the variable rate or pressure responses are obtained through convolution or superposition. However, we can use rate time production data and normalize it by discrete pressure drop changes. This is the difference between initial pressure and the flowing pressure. This approximation will help us obtain a more meaningful diagnostic work. In the equation, it shows us how to compute the rate pressure drop normalize. We start with our rate data, and then we divide it by the pressure drop at each time step. The most common time step is days, but it can be months as well. The pressure drop is the difference between the initial reservoir pressure, considered constant, and the bottom hole pressure at each time step. The graph shows an example in which the rate and the normalized rate are plotted simultaneously. The green markers are the oil rate data, and the red markers are the oil rate pressure drop normalized data. The observation here is that due to the change in pressure, the decline behavior of the rate is not easy to observe. However, the decline behavior of the normalized data is much more evident and therefore more accurate when applying diagnostic tools like the ones we discussed before. In this example, the graph on the left-hand side shows the rate time data without normalization. The diagnostic interpretation of flow regimes suggests a long linear flow period. If we were to use a decline curve model to extrapolate the linear flow, we would certainly end up with an overestimation of the ultimate recovery. Now, on the graph on the right-hand side, we have normalized the rate data by the pressure drop. The flow regime diagnostic interpretation shows a deviation from linear flow and have allowed us to interpret the late time p-value using a straight line analysis. In conclusion, the use of pressure drop normalization enhances the diagnostic signature of the diagnostic plots. This behavior is clearly observed in the interpretation of p-values, which are more evident using the QDB plot, the Veto derivative, or the power law approximation of the hyperbolic relation. Once we review the concepts of diagnostic-based decline curve analysis and various types of diagnostic interpretations for the decline parameters, we can utilize these concepts and apply them to the multi-phase methodology. The multi-phase decline curve analysis methodology is based on the extrapolation of various data functions such as total fluid rate, flowing pressure, fractional flow on water, and gas-oil ratio. Transforming and combining these data, we can obtain ultimately a production forecast for all phases: oil, gas, and water. The general methodology steps are the following. The first step is to compute the total fluid rate, combining the oil, gas, and water phases into a single equivalent liquid phase. A constant factor can be utilized to transform gas into oil equivalent. Then, the total liquid rate is normalized by pressure drop, with the same methodology as we discussed earlier. Step number 2 involves performing decline curve analysis on the pressure drop normalized total fluid rate. Here, we will utilize the different diagnostic methodologies we have discussed to interpret p-values, decline trends, terminal decline, and finally obtain a production forecast. Next step is to extrapolate the flowing pressure, either bottom hole or surface pressure. It must be the same used to calculate the pressure drop for rate normalization. Any functional form can be utilized to extrapolate the flowing pressure. For simplicity, a hyperbolic model can be used to model the declining pressure and a constant value afterwards to represent the line pressure. Step 4 combines our extrapolated normalized rate and our extrapolated flowing pressure to obtain or back calculate the fluid rate. This is achieved by simply multiplication of our two streams, point by point. In the case of daily data, day by day. The next step involves deconvolving the individual phases from the total fluids rate forecast. Step 5 requires the computation and extrapolation of the fractional flow of water as a function of time. This model will be utilized to extract the water rate from the total fluids rate, simply by a multiplication point by point of the fractional flow of water with the total fluids rate. Once we have the water rate, step 6 requires a subtraction of the water from the total fluids. The result is a stream that combines the oil and gas together. We will call it BOE rate for simplicity. To separate the oil and gas phases, we will use a gas-oil ratio model. Steps 7 and 8 describe how we will achieve this. First, we need to model the gas-oil ratio and extrapolate the model to a final value. In future slides, we will describe an empirical approach to determine this final value. Once we have a gas-oil ratio model, we can separate the oil rate and gas rate phases from the total fluids rate using the appropriate unit conversions. In the following slides, the multi-phase decline curve analysis methodology is explained using diagrams to better exemplify the procedure. We start with the rate time data, oil, gas, and water daily rates. We combine these individual phases into a single total fluids rate. Then, with the use of the flowing pressure, in this case wellhead, we compute the pressure drop and proceed to normalize our total fluid rate. At this point, we have not extrapolated or forecasted any data stream. We have just obtained the data for diagnostic interpretation and subsequent decline curve analysis. The first graph in these slides represents the diagnostic interpretation of the V-value that will be utilized to forecast the total fluids rate pressure drop normalized. For simplicity, the graph depicts the power law approximation approach to determine late time V-value. However, we can use any of the previously discussed methodologies, namely the QDV plot and the beta derivative. Once we have performed our diagnostic work, then we can apply a decline curve model to our total fluids rate pressure drop normalized. This is represented by the green line in the graph. Also, we need to extrapolate our flowing pressure. In this diagram, a decline curve analysis model was utilized to forecast the pressure profile. This is represented by the blue line in the graph. The next step is to deconvolve the total fluids rate, and to achieve this, we multiply our previously obtained forecast total fluids rate pressure drop normalized by the pressure drop calculated from the extrapolated flowing pressures. And at this point, we have a prediction profile for all the phases, oil, gas, and water, combined into a single stream. The next steps involve extracting the individual phases from the total fluids rate. First, we need to extrapolate the fractional flow of water In reservoirs with low water production, an initial declining model followed by a flat profile is commonly found. Any functional form can be used to extrapolate the fractional flow of water. This is represented by the blue line in the graph. The water rate can easily be computed from the multiplication of the fractional flow of water and the total fluids rate. The next step is to subtract the calculated water rate from the total fluids rate to obtain a combined oil and gas rate streams. We will call this combined stream the BOE rate. The final step in the multi-phase decline curve analysis methodology is to model the gas-oil ratio. As we mentioned before, the gas-oil ratio needs to be extrapolated to a final value, and we will describe an empirical approach to determine this final point in the following slides. Once we have the gas-oil ratio model, we can utilize this profile to separate the combined oil and gas streams. Appropriate unit conversions should be applied, but in general terms, the phases are separated by multiplying the gas-oil ratio model by the BOE rate previously obtained. Here we have computed the gas rate first and then the oil rate, but there is no preference as to which one to deconvolve first. Finally, oil, gas, and water forecasts are obtained. We have not extrapolated them separately. We have fundamentally extrapolated the total fluids pressure drop normalized rate using decline curve analysis, and the individual phases are a byproduct of data analysis, ratios interpretation, and diagnostic-based work. In this validation example, we have selected a well with almost 3,500 days of production, but we will only use the first 450 to perform the analysis. The plot on the left-hand side shows the computed total fluid rate, and on the right-hand side we have included the diagnostic interpretation of lead time p-value. For this example, we have omitted the pressure drop normalization. Normalization is not a mandatory step, but rather an alternative diagnostic tool. If the flowing pressure profile is quite constant, the pressure drop normalization will not add significant diagnostic value. In this example, we are using the rate time data in our diagnostic plots, and the interpretation of the p-value is performed using the beta derivative and the straight line analysis. A decline curve analysis model is utilized to forecast the total fluids rate. A good history match is obtained from the start of production. Next, the ratios are modeled. The fractional flow of water is modeled using a flat profile based on the last production history. Gas-oil ratio is modeled with an inclining trend to a maximum value based on the last production history. This is not an ideal model since we would expect the gas-oil ratio to continue increasing. For the sake of this example, we will utilize this model and later observe what happens when the entire production history is revealed. The multi-phase decline curve analysis methodology is executed, and the final results are presented. Here we are presenting the individual phases, gas, oil, and water, with their respective projections. All phases have a reasonable history match, especially the oil rate, since the data is well behaved. Gas and water rates have some noise and periods of irregular production. Nevertheless, the forecasting model is doing a fair job in predicting the future performance of these phases. Now, all the available production data history is shown in our example, 3,500 days of production. First, we observe that the total fluids decline curve analysis model is slightly underestimated the last portion of the history. This could be related to changes in flowing pressure and other operational factors. Next, the fractional flow of water flat trend was not completely capturing the future water performance. But with the data available at the time of the evaluation, we could not forecast a more realistic trend. Overall, water production will be underestimated. Finally, the gas oil ratio historic behavior is erratic. This is quite common as pressure and other operation factors come into place in the life of the well. Our final gas oil ratio value is underestimating the gas production. Going back to the individual phases with all the production history revealed, the gas forecast is doing a fair job in predicting future performance. We can observe periods of mismatch, which is aligned with the gas oil ratio up and downs. Even if we try to calibrate better the oil and gas ratio model, we would not be able to fully capture all the erratic behavior. The oil forecast is still doing a good job in predicting future performance. The late time mismatch is mainly related to the deviation in the fractional flow of water from the flat trend. If we correct this fractional flow of water trend, the oil forecast will be just fine. The same rationale applies to the water forecast. Since we underpredicted the fractional flow of water, the individual phases will follow the same behavior. Now, we will start with a different example. For this example, we have selected a well that has only been in production for about 2 months. With such short production history, forecasting individual phases with decline curve analysis may overestimate the ultimate recovery. Here's when multi-phase decline curve analysis is more applicable. First, we start with our total fluid rate. In this case, we have also flowing pressure data, and then we computed the pressure drop normalized rate, which is shown in the left-hand side plot. The right-hand side graph shows the p-value obtained from our QDB plot utilizing the total fluid rate pressure drop normalized rate data. The plotting function suggests a p-value of 2. Here we need to stop and make a comment. If we forecast this well with a high p-value, we will overestimate its productivity. The p-value will certainly decrease over time as different flow regimes develop in a horizontal multi-fracture well. Another option would be to generate a model-based prediction. We can use analogy with older wells to determine appropriate late time p-value. We need to select the most appropriate one for forecasting. Recalling our step-by-step procedure, we start by forecasting the total fluids pressure drop normalized rate with our decline curve analysis model. In the graph, we can observe a good history match between the data and the model. The next step is to predict the flowing pressure profile, which for this example is still declining. We are using a declining hyperbolic trend to match the history and extrapolate the pressure to a known line pressure based on operation conditions. The next step is to deconvolve the total fluids rate prediction, and to achieve this we will simply multiply our 2 previous forecasts. The result is shown with the blue line. This is our total fluids rate forecast. Continuing with our methodology, now we will work our ratios. First, we model the fractional flow of water. A declining trend is followed by a flat profile. From analogy with other wells in the region, we do not expect an increase in water production. Next is our gas oil ratio model. In this example, we are modeling an increasing trend to an ultimate value determined from our empirical methodology. We will review this methodology in a few slides. Once our ratios have been modeled, then we can compute the individual phases. Here we are presenting the results of our multi-phase decline curve analysis. Starting with the gas rate, we can observe that the rate is showing an increased trend, which by utilizing traditional decline curve analysis will be impossible to forecast. But using the multi-phase decline curve analysis, we were able to model the increased historical trend, and also we are modeling the long-term declining trend. The oil shows a declining trend, which is history matched by the multi-phase decline curve analysis model. The forecasting model is doing a good job in extrapolating the trend. The water shows a sharp initial decline, followed by the second trend with a shallower decline behavior. The multi-phase decline curve analysis model is able to model these two periods and continue with the last trend in the future. Overall, in this example, we can observe the benefits of using the multi-phase decline curve analysis methodology. First, it allows us to perform a diagnostic-based prediction of the total fluids pressure drop normalized rate. Second, it can model short-term production history with better accuracy, where the traditional decline curve analysis would overestimate future performance or simply would not be able to be applied. Now we will move to our last topic, the gas-oil ratio extrapolation using an empirical data-driven methodology. We are going to use an example to illustrate the methodology to extrapolate the gas-oil ratio to a final value. This well has almost 3 years of production history. The plot on the left-hand side shows the oil rate versus time. The declining rate is well behaved and some outlier data points have been excluded. The plot on the right-hand side shows the gas-oil ratio versus time. It is clear to see that the gas-oil ratio has an increasing trend with no apparent stabilization. An increasing model can be fitted through the data. However, the question is, when would the gas-oil ratio stabilize? Multi-phase numerical reservoir models may be used to history match and forecast as well. A phase behavior model is needed. Something as sophisticated as an equation of state may be used. However, all these methodologies require time and effort, and at the end of the day, they would have some degree of uncertainty. To recap, the question here is, what is the final gas-oil ratio value? To determine the final gas-oil ratio value, we will utilize a plot of the oil rate versus the cumulative gas-oil ratio. The cumulative gas-oil ratio is based on the cumulative production of oil and the cumulative production of gas instead of using rates. The reason to use the ratio of the cumulative production is that it smooths the data and allows for better diagnostic signatures when extrapolating trends. We will plot the oil rate on the y-axis and the cumulative gas-oil ratio on the x-axis. The objective is to extrapolate the trend using a straight line. By changing the scale on the y-axis, we can obtain two different extrapolation values. This is useful to determine uncertainty in our prediction. In the first plot on the left-hand side, we are plotting the oil rate in the y-axis using a logarithmic scale. And in the plot in the middle, we are plotting the oil rate in the y-axis using a Cartesian scale. For both plots, the x-axis is the cumulative gas-oil ratio. You can see the difference in the trends. The straight line extrapolation on the logarithmic y plot will result in a higher ultimate gas-oil ratio. For this example, the extrapolation yields approximately 10,000 cubic feet per barrel. The extrapolation on the Cartesian y-axis plot will result in a lower ultimate gas-oil ratio. In this example, the straight line extrapolation yields approximately 6,000 cubic feet per barrel. In addition to the straight line extrapolation, we can perform a diagnostic analysis to validate the reasonableness of the final values. This is shown in the plot on the right-hand side. Here we have a graph of cumulative gas-oil ratio on the y-axis and the cumulative oil production on the x-axis. For this well, we know through the decline curve analysis that the ultimate recovery is approximately 550,000 barrels. So we can draw a vertical line at this point and extrapolate the data trend to our final gas oil ratio values obtained from the straight line analysis. The red line shows our high estimate, which was approximately 10,000, and the blue line shows our low estimate, which was approximately 6,000. If the trends are reasonable, we can move forward. Otherwise, we would need to revisit our straight line extrapolations one more time. Now that we have our ultimate gas oil ratio value, we can compute the ultimate gas recovery by simply multiplying by the ultimate oil recovery. To continue with our example, we will forecast the gas phase individually and observe the resulting gas oil ratio profile, and since we know our ultimate gas recovery, we can calibrate the decline curve analysis model. The plot on the right-hand side shows the gas rate versus the cumulative gas production. Observe that we have two predictions, a high estimate and a low estimate, which define our technical uncertainty range. The plot on the left-hand side shows the gas oil ratio versus time. As we said before, the gas oil ratio has an increasing behavior with no apparent stabilization. By knowing our ultimate gas oil ratio values, the resulting forecasts continue with increasing trend in a late time stabilization. Some notes on this methodology. We are forecasting oil and gas separately utilizing a decline curve analysis model. In this example, we use the modified hyperbolic model for both phases. For the gas oil ratio to follow an increasing trend, we need to calibrate the V value of the gas phase to be equal or greater than the V value of the oil phase. Finally, we can use the same terminal decline for oil and gas, which will result in a constant late-time gas oil ratio trend. This means that the final exponential segment for both phases will have the same decline, generating a flat gas oil ratio profile, which is what we see in the graph on the left-hand side. Finally, I would like to summarize the key points that were discussed throughout this presentation. We have presented diagnostic methodologies to assess decline curve analysis model parameters, the QDB plot and the beta derivative, and how we can use these methodologies to interpret the V value and the terminal decline of the modified hyperbolic model. We have presented considerations for production forecasting using ARCs and other decline models. This is based on the diagnostic analysis of rate, decline, and other data functions. We have presented techniques that include the incorporation of multi-phase flow and variable flowing pressure into decline curve analysis. And finally, we have presented a methodology to estimate ultimate recovery for the gas phase by assessing the final gas oil ratio value using a straight line analysis. Thank you for listening to my presentation. I encourage you to apply the methodologies we have discussed today and come up with new and better diagnostic tools of your own. Please feel free to reach out by email at any moment if you have any questions or would like to discuss more about this or other topics. Have a great rest of your day.
Thank you to Alvaro Betancourt for that incredible technical presentation.
We would like to thank D&M for years of partnership alongside PHDwin. We would also like to thank D&M for being a platinum partner of this year's PHDwin Week.
Coming up next, Dr. Marshall Wigway, PE, will conclude his short training course. After, we will replay a featured PHDwin Week session from a previous year. Make sure to tune back in this afternoon at 1 p.m. for Jonathan Smith. Jonathan will discuss details of data in PHDwin V2 and V3.
Right after Jonathan, Zach Warren joins us from Velocity Insight for a showstopper presentation. All stream replays will be available on YouTube the following day. We will also add dedicated replays for each session with post-production work within a week on our download site. We hope you're enjoying PHDwin Week. We will be taking a 20-minute break before our next session. Stay tuned for more.
Hello, everyone. Actually, we're not going to take a 20-minute break. We decided to add some additional commentary on that excellent presentation. In just a minute, I'm going to bring company president David Pacinda on, who has some additional insights he would like to add. So all stay tuned.
Good morning. My name is David Pacinda with TRC Consultants. This is Ifer Lee, and who has been a member of the TRC family for a very, very long time, and is now joined a associated company with us. And as you've seen over the course of this thing, we work with a lot of other companies, and he has gone off and he is now representing us and some other companies internationally for decline curve economic analysis and software analysis and engineering analysis. So, Ifer, you want to take a moment and tell us what you're doing today?
Sure. Thank you, Dave. And again, my name is Ifer Lee, and I am currently with Petroleum Tech Group, which we are representing PHDwin and TRC internationally in terms of software needs and training and optimization and other consulting services, such as report building and things like that. And we are currently having undergoing through negotiation and business proposal processes with various countries such as China, South American countries, Middle East, Middle Asia, and many more, right? And also including African countries. And wow, I just want to say that was incredible presentation done by Alvaro.
Okay, so what you may or may not know it, but if many of you guys who've known Ifer, he is a petroleum engineer. He graduated with a petroleum engineering degree. He's worked with us for many years, been very deep into the detail of it. I'll tell you what I was impressed with, okay? And with the rigorous analysis that he was doing. We see so much by the seat of your pants, full cycle curve projection, full cycle, can I do a curve fit on an ARPS? Oil and gas are independent of each other. Nobody's even talking about water. Alvarez brought a very disciplined engineering approach. I've got some questions for him at 3:30, because I'm excited about what he's doing, and I think there's some things that we could do that we could help him maybe even get some of those projections a little bit better. But I was super impressed with that, and I think that's something. It's great to see people doing that very sophisticated, very detailed, very deep engineering, as opposed to the seat of my pants. How quickly can I do something? The truth of the matter is, oil and gas and water do not flow in the reservoir independently. They interact, right? I mean, this as an engineer. How much time did you spend learning about, both the petrophysics and the petrochemistry that's going on there? Right.
Exactly. And this has been this is actually well known internally to TRC, right? Like you said, I've been here for years. This is something we preach. From my personal perspective, I think a lot of what our clients is going through is, especially when he was talking about that pressure transient stuff, and the water, a lot of times is that I remember yesterday John was talking about this dentist call, right?
Yeah.
More often than not, I think a lot of people who are involved in our industry just doesn't have the expertise or just lack of the knowledge, right? You're not afraid when you don't know. So a lot of times, we're here as a bridge, as that language.
Okay. You're being very nice and saying that we've got dentists who are using the product and don't know how to use it. I'm a little bit fearful that has been, that more people are doing that than just the dentists.
Well,
Okay, so let me ask you a question. PHDwin supports not only phase independent projections where oil, gas, and water are being done independently, and there's places where that's appropriate.
Yes.
Okay, but we also support minor phase variable ratio projections. We do. We do flow regime analysis. We do, we do cut versus cume or water oil ratio versus cume techniques for high water cut, where fractional flow is the driving factor. Okay, when you look at our clients' data sets, how many of them are using those, and how many are just putting ARPs? And I'm knocking our clients. That's not good. But I think the problem is this is industry wide, right? So how do we? Right. Yeah. So how often do we see people going down these other techniques?
That is a problem, and we're here every year to kind of preach this. I know Dave, when we did our presentation, and even from previously, Mr. Larry Connor out of Ryder Scott, he also did the MP versus WR method, right? That's a very good approach and advocate to the industry to kind of follow up on that process, right? Be diligent.
Larry presented that at PHDwin Week a couple of years ago. Dr. Wigwe presented that last year while, here in the US, while when I was in China with you, we presented it in China.
Exactly.
Okay. And the takeaway on that concept was that every time we presented it, people went, oh my God, this is new. This is amazing. This technology, these relationships, okay, existed when I was in school at A&M so many years ago. And they've either they've gotten forgotten, and maybe they're just forgotten, or people didn't realize they could be used in different ways. So we have a lot of these. We have a support for a lot of these things that Alvaro is doing, and I would like to see more of this getting used by our clients, because I think they'll have better outcomes.
Exactly. And this is exactly why we love to work with D&M, and they're a great partner, and they're preaching the right things, diligent engineering, and they're one of the top consulting firms in the world.
And Alvaro, I think, is one of the top engineers in the world right now. Okay, I mean, you look at what he's doing. My God, he's taken it. He's taken it from soup to nuts. Exactly. Okay, and we've seen a lot of people try to do it, but he walked it all the way through. Now, mind you, pressure data is really tricky to get hold of, but more people have it, and the more people. And if you have it, I think you're crazy not to use it in a disciplined approach like Alvaro's doing. So, yeah.
And from the international perspective, there are a lot of clients internationally, or potential clients internationally, that I have seen that has the data that may be just missing the know-how. And if you contact us or D&M, we'd love to sit down and talk about it, and hopefully help you guys get squared away and put you on the right path.
So just giving you a little plug here. How can people get hold of you?
Yeah, my email is still with TRC. My email is sli@phdwin.com. And you can always reach me, or if you email sales or sales@phdwin.com, support@phdwin.com. If you request international information, you can always get a hold of me. I'm working around the clock, so it's never too late or too early.
Yeah, you're working around the clock. That is an understatement. This man, I have seen him in this office, and now I'm sure you're doing it elsewhere. Early in the morning, late in the evening, whenever the clients need you, you've been going down that road. So no, it's very impressive. Anyway, all right. So I think we're running out of time right now. I'm looking over at John, and John's saying, "Get it done, Dave. You talk too much." But no, I'm really looking forward to talking to Alvaro at 3:30. I think this was a great presentation. I think that disciplined approach to engineering is really important. The oversimplification, I see too much oversimplification. I think we have opportunities in this environment that maybe we're not using, and I think we're doing a disservice. I think we'd be doing a disservice as a software company if we weren't giving people the best way to do their analysis. And it just isn't that much harder, and you're not going to overpredict. Now, maybe there's people who feel like they should overpredict, but I just don't think it's a good idea. Well, thank you very much for being with us, Eifer.
Thank you, Dave. It's always good to be back in the office.
It
feels like home.
It's always a pleasure to have you here. And though somebody took your office, you will always have an office. How's that?
No problem.
Maybe not your original office. Okay.
And guys,
All right.
remember, if you have any questions, send the emails to Alvaro at events@phdwin.com.
Yes, I forgot that part. Okay. Events@phdwin.com. We'll see you at 3:30.
Thank you, guys. See you at 3:30.
Thank you very much.
In about 4 minutes, we've got Dr. Wigley's final short course coming up. We just want to say thanks again to DeGore McNaughton for that excellent presentation. We look forward to Avro coming on at 3:30 to talk a little bit more and answer some questions. Also, after Dr. Wigley's presentation, we're going to have a replay from a previous PHDwin week. Crystal from D&M a few years ago did another amazing presentation. So we'll replay that during our lunch hour. And then I'm going to jump back on. This is Jonathan Smith. I'm going to jump back on at 1 o'clock and really get into the details and data in both versions of PHDwin. You don't want to miss it. But in 3 minutes, Dr. Wigley doing the final short course in version 3.
In this section, we're going to be talking about the non-economic group cases. In PHDwin, we have two types of group cases, the economic group cases and the non-economic group cases. As the name implies, if a group case is an economic group case, that means we can run cash flow for that group case and generate cash flow essentially. But if it's a non-economic group case, it means we can run cash flow and the group does not, they are not designed to generate cash flow. They are primarily designed to gather production volume from their child cases. So the group case is called the parent case, and the standard cases that are added to this group case, those are called the children or the child cases. So the non-economic group cases, they gather production data from their child cases. They can sum it up. So a summary plot is going to sum it up. A normalized curve is going to generate an average curve for that. So, but something important for those group cases is they do not generate cash flow. We're going to start with a summary plot. The summary plot is used to sum the production volume of selected cases, which are the children cases. You essentially have three options. You can gather just the historical volume, or you can gather the historical volume and the forecast up to the EUR. So without taking into account the economics of the child cases. And you can do also gather historical production, including the forecast up to the economic limit of the children. So three different ways you can gather the volume. And then you're going to be able to print the gathered production data on the graph to display monthly production of the sum of all the child cases. A summary plot is useful for looking at the total production for, let's say, a certain field, a given reservoir, or maybe if you are the engineer managing a certain asset, you want to look at the sum of the production of all the wells you're managing, pretty much under your management. Maybe you also want to view the total production of all the wells in the database for a company for reporting purposes. A summary plot could be also could be very useful for that kind of display. As we discussed earlier, it does not report economics. Even if you apply prices to this case, it was designed not to generate cash flow. We have two types of summary plots. The simple summary plot is the one we are seeing on the right side here that essentially gathers volume, does what a summary plot does. Now the second one is a stacked summary plot. Now in the stacked summary plot, it's an incremental of the simple summary plot. Now it's designed to show, the purpose of that is to show wedge volume, the incremental difference between two sets of cases. So you can create a simple summary plot for all your PDP wells. You can create an incremental summary plot for all the PDP wells, or maybe all their incremental wells. When you stack them together, you'll be able to see the incremental difference between those wells, right? Or you can create a simple summary plot for all your PDP wells, and then you create a second summary plot, an incremental summary plot for the PDP wells plus your undeveloped wells, right? Now, when you stack them together, you'll be able to see the wedge volume that is being contributed by those undeveloped wells. We are going to primarily discuss the simple summary plot. Somewhere down the line, we are going to mention when we have some undeveloped wells, we are going to go ahead and discuss the stacked summary plot. Let's go ahead and demonstrate this in PHDwin. We are going to look at the summary plot of all the cases in our database. Let's see, we already applied, the cases have historical volumes. We already applied forecast to all the cases. Let's essentially see what the summary of the volume for all 100 cases look like in this database. All right, so let's go ahead and switch back to PHDwin. All right, so this is my PHDwin database. We have 100 cases, and they are all in the middle backend formation. I think it's in McKenzie County in North Dakota, okay? Right now, the cases, they all only have projection information. They don't have prices, they don't have expenses, just raw historical volume. I want us to go ahead and generate a summary plot for all 100 cases. There are two ways you can generate a summary plot. The first is from the case list. If I select all the cases I wanted to add to my summary plot, as you can see, I clicked on the grand total page or on that summary. So if you had sort order that have the cases, let's say by field, by reservoir, and you want to show summary plot for a specific reservoir or a specific field, you can do the same selection at the group for that particular field or reservoir and add it to your summary plot. All right, so I'm going to grab 100 cases by selecting everything. You can select it by doing that, or you hit the top and you go all the way to the bottom, you hold your shift key and then you select it. But this is a much simpler way to select everything. Then I'll right click. You see we have economic group cases and non-economic group cases. Under the non-economic group cases, we do have the simple summary plot. So you can click this. It's going to create the non-economic group case, the summary plot, and add all these 100 cases into the case settings. Alternatively, you can go to the home ribbon. You see add or import. You hit the drop down, non-economic group cases, and then a simple summary plot. So either way you do this, it's going to create this non-economic, this summary plot. You can see it new case 1. And then it's going to add all the cases you selected to the case settings for the group case. So the case settings, it's a form that it's used essentially to customize group case settings. So it was really designed for group cases. All right, so if you did create a summary plot and you didn't add your cases, or maybe you added a subset of cases, or maybe it was just all 0, you can still come back to the case list and drag all the cases you want and add to the case list. So I do that. I drag all cases, it adds all 100 cases. If you notice, I dragged 101 cases, but you only added the cases and excluded the summary plot. That's a rule in PHDwin. You can't be a member of yourself as a group case. All right, so the settings, the case type is a simple summary plot. How do you want to gather the volume? This is where you customize the settings on the summary plot. Volume gathering, you have 2 options. You can gather gross volume or your net volume. So under gather volumes until, so by default we are gathering up to the economic limit, but these cases don't have economic limit right now. I mean, they do have, it's just non-economic, so it's going to gather historical. So you can gather up to the end of production, up to the EUR. So this is going to be your technical EUR. So up to the last forecast date, your Q final on the child cases. So economic limit, this will imply that the child cases have economics running on those, then we'll be able to gather the volume up to that point. So I'm going to, let's go ahead and gather up to the EUR of the cases. Select that. Once you're ready to go, you go ahead and hit compile. So once you hit compile, it goes through the process of gathering the volume, and it's going to display the result on the graph. Okay. So now you have all the cases, the volumes have been gathered. So what I can do is to go ahead and apply I would like to apply the 50-year graph model, but since this is a summary plot, I'm going to zoom in a little bit on the time. So I'm going to copy the properties of that just to add all the products and all the settings. Okay. Then I'm going to double click on the graph. I will go to the x-axis. I want to go ahead and start from the first production. Maybe how do I tell which one is the first production? If you go to the monthly form, you see that production is from 2010 to however into the future we did forecast. So this shows 2213. Okay. All right, so the important thing right now, I'm going to go ahead and go x-axis. I'm going to start from a fixed date of 2010. Or maybe 2009 to give us a buffer. I could have used the report date and do an offset that takes that 2010 into account. That works as well, right? Okay. Then the maximum, maybe I go ahead and do 100 years. Then I hit apply. So you see how it zooms out the data for us, and you can see the entire history. So that's oil production. Then that's NGL production from the forecast. So you can see the gas NGL. Most of the cases ended at this point, but there are some tail end cases. But the important thing here is that on the well count, you can see when this field or when the back-end reservoir started development for the set of wells that we have. Somewhere in 2010, and you can see this is well count of 1. So 1 well for a little bit, 2, 3, you can see production ramping up for the assets that we have in our database. So as well count is increasing, so is production until they all hit peak volume and then starts dropping. So of course, from the report date moving forward, these are pretty much forecast data being summed up for us, right? So if I wanted to see up to, let's keep it at 60 years or 50 years or even 70, that's fine, okay. And then you see the entire production without worrying about seeing the tail end. But on the graph title, because we added a graph title for this particular graph model we created, you can see the historical volume for gas, oil, and water, and then the technical EUR volumes as well. So this is a simple summary plot. I can go ahead and customize the header data. I'll call it a summary, or maybe I call it PDP summary plot of all cases. Okay. You can go ahead and fill out the details for county, state, country, and set that up correctly the way you want it, but this is all PDP wells, right? So. And then since they're all in different fields, we can't really select a specific field to lump it into. And there's no reservoir. So maybe you can create in an unknown field a reservoir for the backing. So you can do that for sure. All right, so I'm going to go ahead and save this. So that's how you generate your simple summary plot. Pretty simple. So the key is know the group of cases you wanted to add, how you want to gather volume, and how you want to gather volume, the endpoint you want to gather volume up to, and then you should be good. All right. So we're going to do the stacked summary plot when we have pod cases in our database. Right now, we just have producing cases. All right, so in this section, we're going to talk about a normalized curve. What are normalized curves and how do they function? So normalized curves, this is the case type designed to help us generate our type well profile. So a normalized curve gathers production data, is a group case type that gathers production data from the child cases. To gather this data, it brings the relative start of production or the peak date to a common starting point in time. So you can pick one option or the other, either the start of production or the peak date, or the child cases at their start of production or at their peak date. We grab that data, we grab that date, we shove everything back to a common starting point in time. And that time is January 1st, 1900. Once we gather that data back in time, we move all the data back in time, we start averaging the production. So we have 3 options. We can average by well count, we can average by the lateral length, or by the proppant mass. So we'll go from the first month, second month, we sum the production for the first month, we divide by how many wells that contributed to that production in that month. We do that on a month-to-month basis until we average out everything. Same thing with the lateral length. We sum out the production, we divide by the sum of the lateral length on the individual wells. Same thing with proppant mass, and then we average that out. Now for cases, if you normalize by lateral length or proppant mass, if a particular case doesn't have lateral length data or proppant mass data, we assume a value of 1. Now, the idea in that is once we plot the graph, you'll be able to see that particular case as an outlier. We'll talk more about that. All right, so once you normalize by your selected option, we're going to generate, present that data for you on a graph. So we're going to generate the average curve on the graph, which, as you can see, is the wiggly green line for oil. In addition, we're also going to plot the chart cases. We call this a spaghetti plot. So we're going to plot the production profile for all the chart cases and then the average production for the entire set of wells. So this is called a normalized curve, the wiggly line. Next, as the user, you go ahead and fit the client curve through each product. So we have a graph for each product, then plus the well count on each product. So we'll have a graph for oil, for gas, for water. And the reason why we have this differentiating graph is if you allow all three on one graph, they will come with their own spaghetti plots, and that will be a little bit messy. So we kind of split those into separate graphs. So you go ahead and fit the client curve through the average curve for both oil, gas, water. And if you have NGL or other products, you can do the same thing as well. And then you can go ahead and use this type curve. This is your type well now, or your type well profile. This is not a type curve, it's a type well profile. And you'll be able to use this to generate your drilling schedule, your prospect cases. Now, if you use this to generate your prospect cases, the prospect only inherits the forecast. It doesn't inherit the historical data or this average curve, just the forecast. So that's why when you're creating your normalized curve, you have to apply this forecast because that's what the prospect inherits. Now, in addition, if the normalized curve case has economic parameters applied, such as investments, ownership, prices, expenses, anything, even ID code, their general information with the exception of their case name, the prospect cases would inherit this property. Now remember, even if you apply these economic inputs, this case does not generate economics. It does not generate any cash flow. So the purpose of applying this economic input is so that once you start creating your prospect cases, they are ready to run right away. But you don't have to do that. You can just create your type curve, create your prospect, then on the prospect you apply your prices, expenses, their specific investments, and then you can run your cash flow. All right, so how does this work? Let's go ahead and demonstrate it in PHDwin. We're going to do two different type curves. The first one we're going to do is going to be normalized on well count. The second one is going to be normalized on lateral length. That's because I think the data set we have has lateral length data, so we'll normalize on lateral length. Then we're going to use both of them to generate our prospect cases. All right, so let's see how this works in PHDwin. All right, something we didn't discuss here is how you select the cases that you add to your normalized curve. So the reason why we're not discussing that is that this is a software, that's something for the engineer to decide how they make those selections. But of course, there are rules. You want to look at wells that are similar. How similar should they be? Maybe the same reservoir, the same completion technology, the same period, maybe. You don't want to look at wells in 1986 with wells in, let's say, 2015 or something like that. Looking at combining conventionals and unconventional production. So you want to think about how you pick those wells. But in this presentation, the assumption is you've picked those wells. In my own case, we have 100 cases in the middle back information. So all the wells are in the same reservoir. They kind of have similar completion technology. They're all unconventionals. But as you can see here, a lot of them some of them started producing in 2009. Some of them came online in maybe 2021. So we do, well, actually somewhere in 2016, 2017. So we're going to, it's good to have some variability, but you want to have as similar as possible well. So like I said, the assumption is we've already made the selection. How do we go ahead and create our normalized curve? If you watch the video on summary plot, how you create group cases, there are two ways to do that. You select the cases you want to add to your normalized curve. I'm going to exclude this last case that is a summary plot. So that way I only have 100 cases. You can right click on the case list and you see the option that says non-economic group case, and then you can pick the normalized curve. Or you can go to add or import non-economic group case, and then you do your normalized curve. Whichever one you do, you come to the same result. So I'm going to right click non-economic group case, then I'm going to do normalized curve. So once I do that, PHDwin adds the selected cases to the case settings of the normalized curve that we just created. Now, we also have the option to go ahead and customize the settings on the normalized curve. So the type is a normalized curve. We can change that. And for a normalized curve, we can only gather gross production, which makes sense. How do you want to gather the volumes? So we have two options, up to the end of production or up to the technical EUR. So if you already have forecasts on the cases, we're going to gather up to the maximum, the Q final for every case. Now, depending on the situation, the recommendation is always going to be to do up to the end of production. As long as you have enough case count, enough cases to do this, cases that are similar, the recommendation is always going to be to do end of production. Using EUR will be recommended if you have a very few set of cases, you don't have enough data, and maybe you have a very few wells that have the potential to pretty much dictate the performance of your prospect cases. So if you have 10 wells and you only have 2 wells that have been producing for a long time, then those 2 wells, there's a chance they will be the one to dictate the performance of the entire prospect profile. So in that situation, yeah, because you don't have a lot of cases, you can go ahead and forecast every single case and gather up to the technical EUR. That's completely fine. But that's because you don't have enough cases. But if you do have enough case with enough historical production, I'll always go for end of production. How do you want to begin normalization? You want to do based on peak production or based on the start of production? For most conventionals, people do start of production. For unconventionals these days, we've seen people do peak production a lot. So for every child case, we're going to look at that first peak production date, and we're going to make that the starting point. And then for all the cases, we're going to move the peak production back to a common starting point, which is January 1st, 1900, and then we'll start averaging from that point moving forward. All right, so for most conventional wells, that's what happens. They just do the peak production. A lot of people do this because that first month to second month, the unconventional wells, they are unloading the frac water. So they don't want to bother capturing that. But if you still want to capture that, because whatever prospect cases you're going to create is also most likely going to be unloading frac water. So you may probably want to capture that as well, but that's option. Of course, to capture that, in that case, you need to use start of production, and then maybe you incline your forecast for that period to hit the peak before it starts declining. All right, so we're going to do peak production. These wells are all unconventional wells. Normalize on, we're going to do two. The first one is going to be well count, total wells. So we're going to grab that, and then we hit compile. So once you hit compile, PHDwin does the process. It's going to move all the wells back to a common starting point in time, and then does the averaging for us. So you can see the average profile. So this is going to be the profile for the oil production, and then this is for gas production. And then you can see that for both products, we also have the well count. You can pull it up a little bit where you can see it somewhere on the top side. Maybe pull the oil down a little bit, and then you can see your well count. Okay. Now, before you really start applying your projection, you have to think about your phase configuration. Make sure you have the right phase configuration applied. Everything is oil production, so ideally this is going to be a major phase oil, right? And then the phase configuration, we're going to do phase independent oil. But if you wanted to pick minor phase variable ratio, time, other types of settings, you can pick those as well. So I'm going to use the phase independent oil. Let me name this backing type well. And since this is based on well count, I will say total wells. I plan to do something using lateral length as well. So I will put this, you can put this in a given field, but I think at this point, every single field is going to have the middle back information, depending on where you plan to drill this well, right? So county is Mackenzie, and state is North Dakota, country is the United States. Subcategories now, I'm going to move that to undeveloped. You can always change this later on the prospect cases if you forget to do this. Then that's primarily the change I plan to do. So the next step, I know my phase configuration is good, so go ahead and start applying the decline curve to all my cases. Before I do that, I like to pick my graph view. I like the graph view because it gives me 3 graphs displayed. Then for the third one, I can click here to add graph. If the graph is not here, you can also go to the graph flyout and do the plus sign to add the graph. Is going to bring you to the same point. So I want us to go ahead and add a graph for water. Okay. So it's going to add that graph for water production. Then you can take it up. Now, just know that in V3, you don't have to add a product to the graph to actually generate forecasts for it. But these are the 3 primary products. NGL, we're just going to do a flat projection for the NGL in this database. All right, so I'm going to go ahead and apply the decline curve to my oil production. So I select the product. Oil is selected. I'm going to pick the auto fit. Now I do have some auto fit options I set up. Maybe I haven't set it up for this database. Okay, so I'm going to set it up to 1.5 B factor to be the max. So we're going to go 0 to 1.5, 50 years to extend that projection past the end of production. Minimum decline, I will leave it as 5%. I save that. All right, so once I set that up, I'm going to use my call data. I do oil production. Okay, so if I hit the standard auto fit, so that's because gas was selected. It went to apply to gas, but I'm not going to worry about that. So let's go ahead and select oil production and hit the standard auto fit. You see how the standard auto fit actually gave us good decline through the data using a B factor of 1.31. I think this looks good. I don't even have to change anything on this decline. Again, at the end of this, the data. If the data is clean, AutoFit really does a good job to generate a clean forecast for us. And you see the beginning date started 1/1/1900. If it was a different date, I will always want to make sure this starts from 1/1/1900, right? Okay. and that's the initial rate, initial effective decline, tangent effective decline 99%, and I'm going to go ahead and hit save on that. Okay. So the other one I'm going to do is to go ahead and put a well count projection of 1. I'm going to select my well count. I'll do a well count projection, flat projection of 1. Okay. Since it's a normalized curve, I'm just gonna do 1. Now, if you notice, it started in 1/1/2024. So I'm going to go ahead and link that to segment 1 of the major phase as the starting point. Okay. That way, start from segment 1 of the major phase. I save that. Okay. So normally I'm supposed to be able to lock the endpoint to the major phase. Let me see if I can use Control M. That's going to be the lock endpoint. Doesn't work. If I move to a different product and come back, okay, now it lets me do that. So now you have the lock endpoint. Save this. Okay. So lock the endpoint to the major phase. So that's done. So I'm done with the forecast for oil and then my well count. I'll go over to my gas. My gas did generate a forecast for me. Let me delete that and restart that. I delete for my gas. I do call data. I could use standard auto feed as well. Okay. I right click. It gives me that clean decline. I like to make my Q final maybe 1,000. Let's see. Okay. You can grab that. You can increase the B factor if you need to. And honestly, I'm probably interested in the first 5 years of decline. And this also looks like I can use 2 segments, maybe something that is a little bit high B factor for this period. Then I kind of shallow it out a little bit. And I can add a second segment by hitting the plus sign. I say apps. It's gonna say add a new segment before or after segment 1. I'm gonna say after segment 1. Then it adds this, so I can probably maybe use a 0.5. Let's see what that looks like. You can do this to kind of do 2 segments to do that if you want, or you can go ahead and just delete that segment and extend this up to the ECL. I'm going to lock that to the endpoint. So you know that it's kind of after the 50 year or something like that, it's looking like it's a little bit low. But you can do that, do multiple segment, do single segment, that's fine. So I would like to link the starting date to the major phase. Okay. That way they all start at the same time with the major phase. Okay. So both the starting date and the end date of the minor phases, I want to tie those to the major phase. Let me save that. All right, so I'll do the same thing for water production. I grab my water. I'll do call data. Again, depending on how meticulous you want to go with this, you can go with that. Or you can fine tune this a little bit. Let's say 1,000. And then I'm going to go ahead and extend that to the major phase, link the starting date to segment 1 of the major phase. All right, finally, I'm going to go ahead and do an NGL forecast. It's just going to be a flat NGL yield. Now, if you notice, I haven't added it to the graph. I don't need to add it to the graph. I want to go ahead and forecast NGL for these cases. I'll do a 5 gallons per MCF flat segment for my NGL. So I'm going to do the plus sign. I do flat. I'll do 5. Okay. Then I'm going to link the start date to segment 1 of the major phase. And I hit save. Okay. All right, if you notice, it's showing unresolved because it's prompting us to recompile the group case. You can go to the case settings form to recompile it, or you can do it from this particular place. Just go ahead and say unresolved. It's going to recompile everything for us. Usually prompts for recompiling if it senses a change that's going to update your group case. Okay. All right, so essentially for this group case, I can take it off the graph view. I have my projections applied. This is what I'm going to use to generate my prospect. All right, next we will create a normalized curve for lateral length. It's just going to be the same process, the same. What we did is just how are we normalizing the cases. So I'll do the same thing, grab the 100 cases. I'm going to deselect the existing summary plot and see I put backing type well, so I should say type. Type well, and I save that. I'll put it in the same setup like this one exactly. All right. So I'm going to do something. I know we don't want this. I'm gonna grab those and go ahead and invert selection. Right click, I say non-economic group case, normalize curve. Okay, so we're doing exactly the same thing, end of production. I'll keep it at peak, then I'll normalize by lateral length. Okay. Now, one thing I didn't check is if all these cases have lateral length. So I think they do, but just to verify, I'll take this data to the grid editor. I look at the wellbore completions. Yes, please. Alrighty, so the column, there's a column for lateral length, so that's this column. So you see every case has some lateral length data. In fact, they all have lateral length data. So if I want to sort from high to low or low to high, I think I see a 4,000 lateral length. Did I see a 4,000? Yeah. You know, in a real situation, you know, the client will have to really check this to make sure it's not an error, right? So, well, most things are between 8,000 and 10,000 foot. So this is 4,000, or maybe one section. It could be a real data, but we're not gonna change it. All right. But they all have lateral length, with the exception of this that looks like an outlier. The data is fine. Okay. Now, if something was completely missing, like I mentioned, we're going to assume a value of 1. And hopefully when you see it on the graph, you can tell which one. All right, so let's go ahead and hit compile. Again, we're gonna grab the peak production rate and look for that peak date for every case, move them back to a common point in time. Then we start summing monthly production and monthly lateral length. We're pretty much going to sum the same lateral length for every case across the board, right? All right. So this is a spaghetti plot, and then that's the average curve, all right? So it's possible that this data that's up here as the outlier is the case that has the issue. I don't even know. I can select it. You see, once you select it, you can go to the graphic, probably be able to see the one that's been selected. Let me see if we can tell. All right, so that's this one that's been selected, and that's the Fox case. I don't think that was the one that had the lateral length. Weird. I can double check. Go to the monthly production, the wellbore completions form. Yeah, I don't think that's the one that has the lateral length. So maybe it just has very high production rates. So, all right. Okay. All right, again, I'll make sure I have the correct phase configuration set up. I'll put a subcategory as undeveloped. I'll save this. Okay. Now I can grab these two cases just to make sure they're exactly the same. I can push them to the grid editor. I'll grab these two cases. The other well count one, I'll just change the name. I'm gonna go to general information, edit that. I'll just grab exactly every data I have up to state and pull it down. They have exactly the same data, but instead of total wells for this, I'll say lateral length. So the grid editor, general information, is the only place you can really change the name of the case. In other grid editor tables, you can only change other information, not the case name. So essentially, anything in red you can't change in that specific table. All right, save that. See how that quick change just updated rather than typing everything one at a time. So, all right. So now we have the first configuration is set up. Data has been aggregated. I would like to go ahead and grab my graph view one more time. I will add the water production graph. I pull it up. Now, one thing you're going to notice is because we normalize by lateral length, the unit on the y-axis says barrels per 1,000 feet per well per month. So without the lateral length normalization for a regular well count is going to be barrels per well per month. Okay, so this is per 1,000 feet. If it was propane mass, it's going to be per 1,000 pounds of propane. We'll go from there. All right, so just like we did for the other one, I'm going to go ahead and apply. I still have my auto fit. B factor 0.0 to 1.5. You can increase that a little bit if you think it needs to be higher, but I think 1.5 is a good spot to be. I'm going to do the standard auto fit. Oh, I was selecting water. I'll just leave that. I always like to start with oil production or the major phase. So I'm going to do standard auto fit. Again, it gave me that fit. It's an average curve. It kind of follows the trend. I'll call it good 1900. So that's going to be 2,540 barrels per 1,000 feet per well per month. So that's the initial rate. Okay. All right, I saved that. I grab the minor phase. I grab water production. I see B factor is 1.5. You can zoom in to see how that fit looks. Maybe you can take it back a little bit. You double click just to zoom it back in. Somebody may want to use a different B factor to capture this early time period, and then you kind of flatten it out a little bit, maybe use a much lower B factor, maybe from the third year moving forward. I'll call this good for now. And something I like to do for the minor phases is to link the beginning date to segment 1 of the major phase, and then also link the end point to that of the major phase. All right, so done with that, I go for gas production. I do the standard auto fit. Again, that looks like a good fit for me. Maybe I need to bring that down a little bit. Okay. I double click on that. All right, I'm going to go ahead and link the beginning date to segment 1 of the major phase, and then lock the endpoint to the major phase as well. I save that. All right, I have 2 more products to forecast. The first is going to be the well count. I'll put a projection segment, a flat of 1. I'll link the beginning date to segment 1 of the major phase, and then also lock the endpoint. Something we noticed when we did the total wells normalized curve, the lock endpoint was grayed out. To reactivate it, I had to click on a different product, and then I came back. I was able to, see that released. Then I was able to edit it. All right, so finally we do for NGL yield. I'm gonna add a flat segment of 5 gallons an MCF. I'll grab the beginning date, link it to segment 1 of the major phase, and then the endpoint it's already linked. All right, I'll go ahead and save that. Okay. So right now, I'll go back to my home ribbon and I switch to the standard view. So the normalized curves have been created. I have 2 normalized curves, one for total wells and one for lateral length. Now the ideal next step after creating a normalized curve is to go ahead and build or create our prospect cases. It could be undeveloped wells, it could be behind pipe cases, whatever it is. So that will be the natural step. Now, in this particular presentation, we haven't converted the type curves to what we call type case profile, which is essentially, in addition to the type curve, adding investment data, adding prices, expenses, all that kind of information. We can do that for sure. One thing we can do for the investment is I can go ahead and add a drilling cost. The category is going to be drilling. I can link it to the eco start of the case or first production of the case, one of those two. So there's different preferences with no offset of the major phase. Tangible, you can split this between tangible and intangible. Let's say, just for simplicity, there's a $2 million investment on this well. So let's make it maybe 1,200 on the tangible and 800 on the intangible. We do completion cost. I'll put it on that completion. Again, I'll just link this to first production of the major phase. Completion, I will just make it simple, $1 million completion. So I can split it 500. Then I like to add artificial lift. This is a capital expense. So when we created this database, we were going through database settings. If you go watch the video on database settings, we had to add artificial lift just to show how you can create a different investment category. So, but I'm not going to add it as artificial lift. So naturally, the reason why I did that is to be able to do this. But let me go ahead and apply it as a capital expense. Okay. Let's say these wells are going to go on natural production for the first 90 days before we actually install our artificial lift system. So I'm going to put a 90-day offset on that investment. I'll put it as 200K tangible investment. Finally, I'm going to put an abandonment investment on abandonment. So I'm going to link this to the economic limit of the case with a 365-day offset. So abandonment cost is one of those costs that can happen after the economic limit of your case, right? I'll put it at 100,000 intangible cost. I save that, right? Okay. Maybe on the ownership side, I can leave it as a default ownership. No need to worry about that. Then on the taxes, I'm going to go ahead and apply the tax model for New Mexico. I think it's North Dakota. Yes. I apply that tax model. I'm not going to apply prices and expenses. I think there'll be a separate video where Jonathan Smith is going to go ahead and apply prices and expenses to not just the pod cases, but including the PDP wells. All right. So I've done all these changes for the lateral length well. I can do the same for the total wells case by using the grid editor. This is just a quick way. I think there's a global editor tool that can copy investments from one case to the other. We can do that. But that particular function will replace any existing investment on the current case. Okay, so I'm going to do the grid editor, do investments. All right, so you see how 104 has all these 4 investments. So I'm going to select those investments from the left side, select the entire row. I can copy it. Okay, then I'm going to select the total wells case. I'll right click and I'm going to say insert copied cell below. So this is going to preserve what we currently have, then insert the new ones below that. Okay, so if I do that, it did insert the drilling cost, the abandonment cost, and the very first cell that we had didn't really have any data. It was an empty cell, so it actually also replaced the information on that row. If it was an actual data, it wouldn't replace it, it would just insert below that. All right. So now both of them have exactly the same investment setup. And I can go ahead and say save. I go to the investment, I go back to the total wells case. It has the exact investment setup. I think the other thing we probably need to do is to go to the tax model and go ahead and check North Dakota. And then we save that. All right. Now, something Jonathan is likely going to do when applying prices expenses is also to apply shrinkage. That way you need to shrink the gas because of the NGL extraction, right? So, but that's going to be applied. That makes sense to apply. All right, so now we have two type wells, type well profiles. One of them was normalized based on total wells. The other was normalized based on lateral length. In the next video, we're going to apply these type well profiles for generating our prospect cases. In this section, I'm going to talk about drilling schedule. A lot of the time, when a user creates a tech, an engineer creates a type well profile in their database, the purpose of doing that is to be able to create a drilling schedule. So we're going to show how we can create our pods. If you want to manage your pods as a unique project, you want to add it to an existing project, that way you can track them together, we can show how to do that. So we create our drilling schedule using a tool we call the Prospect Case Creator. So we use that to create our drilling schedule based on cases already existing in your database. So these cases could be a type well profile, or it could be an existing PDP well. Now we do have two spots that you need to actually specify an existing case. One is going to be the success case template. So you can specify, the other is going to be the dry hole case template. So depending on what you want to drill, if you want to drill success and dry holes, you need to specify both templates. If you just want to drill only the success cases, your reservoir, your field, you don't think you're going to make dry holes, then don't worry about the dry hole aspect. The cases can be scheduled into the future at regular intervals. We have them in months or in days. Now, if you're going to specify dry hole cases, the dry hole case will also inherit the property of the dry hole case template. Now, the way you set up your dry hole case, it's really important. You want to create that dry hole case template with no projections, no prices, nothing. But it needs to have drilling and abandonment costs, because you need to drill it, of course, to classify it as a dry hole. And then once you're done with that hole, with that well, you go ahead and abandon it. So you need to pay for the drilling and abandonment cost. Success cases also inherit the properties of the success case template, not just the projection profile that you forecast on the well or on the type case, but expenses, prices, investment, ownership, ID code, we're able to inherit all those properties from the type case. And you can create these prospect cases and add them to a project, whether a new project or an existing project, or you can just create them to be a standalone cases. They don't have to be part of any project. Now, while you're drilling your cases in your project, if you want to go ahead and unlink them from the project after you're done, you can unlink them and they become standalone cases. Now, once you're done creating your prospect, you can go to your project manager to display a list of all your projects in the current database. As you select each project, you'll be able to see the particular project. So you can, as you're creating your prospect, you can add them to a new project, or you can just let them be standalone prospect cases. And you can have one drilling schedule at a time. You can have multiple. I've seen clients have 30 drilling schedule with different iterations, different setup. Maybe they want to create look at maybe 9,000 foot lateral, 10,000 foot, 15,000, 12,000 foot. They have those multiple laterals scheduled, and they create them as different drilling schedule. Or maybe you have multiple rigs that are drilling, and you just create different schedules and just track them together as a single project, or maybe not as a project. All right, so once you create your project, you can go to the project manager, and as you select each project, it's going to give you a list of the cases in that project. And if they are linked, usually if they're part of the project, they'll be linked by default. You see the linking. And then as you drill this well, you come here, you unlink it. It goes away from the project. And then maybe this is how you kind of track your cases as you're drilling them, right? And in time changes, maybe you don't do the project in November, in this particular date, you change the date. Because you've linked all those prospects to the date, they'll all move along just the way you've set it up, you know. And the offset is going to remain the same. Because of the linking, the dates are going to be moved out too. Okay. All right, so we're going to go to PHDwin and show how we can use the type curves we created, the type well profiles we created to generate our drilling schedule. Now, PHDwin V3 has one of the simplest drilling schedules you can think about. So it's really simple. To create a drilling schedule, we have a form called the prospect case creator. If you go to the form list, you have the prospect case creator. If you have add or import, you also have the prospect cases. Both of them should take you to the same location. All right. I will double click on this. It's going to add it to my view. All right, so the first one I'm going to create just for the well count. So I'm going to, first thing, I'm going to add this particular one to project. The second one I'm going to create, I won't add it to a project. So let's say there's no project now. Let me add it to a new project. Let me call it middle backing phase 2 development. Okay. So let's say we are starting this project in January 2025. We're just planning things now. So let me call this backing phase 2 well count number. Okay, so I'm just using well count WC just to show that I created it using the well count type curve. And then the pound sign, as you create this prospect, depending on how many prospects you're creating, PHDwin is going to append. The first one is going to be 1, 2, 3, 4, 5. So putting the pound sign just makes it easy for me to read number 1, number 2, number 3, and we go from there. So let's say we're going to create 10 prospects. Even if project starts in 1/1/2025, what happens if we delay the drilling of the first well? Maybe there are some things we need to take care of, but we actually start drilling in March of 25. And we're going to drill 1 well every month. Okay. This is an unconventional play. We typically don't expect dry hole. So I'm going to grab the well type. So this is where you put the success case template. You go to your case list, you drag the success case, which in this case is our well count normalized type curve. I put it right there. So we don't have dry holes, but if you had dry holes, you put it here. PHDwin is going to stagger the dry holes between the success holes. So if I have like 30%, I'm expecting 30% dry hole, I'm going to put in 3 in this case because I have 10 total cases. So PHDwin is going to drill the first 2, it does 1 dry hole. The next 2, it does another dry hole. So we're just going to evenly stagger the dry holes among the success holes. All right. Something you're going to notice towards the end of the drilling schedule is there's an option to specify the lateral length and the proppant mass, but I can't edit these 2 fields. The reason why I can't edit it is PHDwin knows that this normalized curve that I applied here was not normalized based on lateral length or proppant mass. When we do the next one that was normalized by lateral length is going to give us the option to be able to specify the lateral length for the prospect. And that's where we come up with the concept of denormalization. Because right now it is normalized, so multiplying it by the lateral length would denormalize that, pretty much bring it back to a barriers per month, volume per month basis. All right, if it was normalized by lateral length, it gives you the option to edit this. If it was by proppant mass, it gives you the option to edit this. If it's neither of those 2, it grays those out and you can do that. The well count is what it's used to, scale that information. All right, so this is really simplified. Once this is done, I'm going to go ahead and click finish. All right, so if you look at my case list on the bottom side, you see backing phase 2 well count, number 1, number 2, down to number 10. So as you click on each one, All right, so you can quickly see the projection for oil, gas, water. Right now, we don't have anything for well count. We don't have anything for NGL. So we can apply the model property for the 50-year oil gas, maybe just copy that and show that. So now you can see the NGL yield and then the NGL forecast. Creating your graph models is a really nice way to not have to redo this all the time. You know, you can easily reuse the graph model whenever you want. So no cum production, but that's a tech EUR. So this is this is a 450,000 barrel well, and gas is a 1 BCF EUR production. And then if you look at investment, the investment also is applied because the type well we used for generating this prospect already had investment. Now, using linked date, it's so good, makes it so easy. So as these different wells, they have different dates, the investment, they are all going to be associated to their own specific date. All right. All right, so we're going to create another set of type prospect cases using the lateral length type curve. To do that, I'm going to create a 9,000 foot well and an 11,000 foot well, right? Okay. Or maybe we'll just simplify, we'll do 8,000 and 10,000. Yeah, okay. I'm not going to add those to any, maybe I'm going to add them to the project. Let's go ahead and add them to the project. All right. So yes, go ahead and add it to the existing project. That's fine. Remember, the project starts 1/1/2022. I'm going to do 2 drilling schedules. One is going to be back in phase 2, lateral length. Let me call this 8K lateral length, okay? And then this is going to be back in phase 2, 10. Instead of 8K, that's going to be 10K lateral length, okay? So I'm going to do 5 wells for this one, and then 5 wells for that one. Again, both of them can start in March. Maybe this is going to start in March of 2025. And this can start 5 months later, which is somewhere around August of 2025. Okay. So I want to do 1 well every month. Okay. So they will be using the same success case. Now you see, once I put the lateral length type curve, now I can specify how many lateral length. So this is the 8,000, so I'll just put in 8,000. Whereas this is 10,000, I'll put in 10,000. So PHDwin is going to look at the type curve because they are in per 1,000 foot. It's going to be multiplying that initial rate and final rate by 8, right? 8 divided by 1,000, that's 8. This is going to multiply this by 10, right? So or maybe let me go ahead and add this, just have it as a separate project. Let me call it back in phase 2 lateral length. Also needs to start 2025, but that's January, that's fine. Okay. Now we can see how we can have a list of more than one project in the database. All right, so once I'm done, I click finish. So it's the same type well, different lateral length, different starting times. All right, so because of the way I timed the wells, we do have the 8K wells that are going to be drilled first, then we start the 10K wells. So once I'm done with my success, my prospect case creator, I can go ahead and close it. Then let's go ahead and open our project manager. If you go to your forms, if you go to case relationships, there's going to be a project manager. As you can see, you have two different projects. This is lateral length, so I can get rid of that. So you can edit the name of the project, yes. And you can put a project note if you want, wells in this project where, let's say, used the lateral length type well for denormalization. Okay. Yes, please. For this one, I do the same thing, but this used the total well type well for denormalization. Yeah. So as you select each, I'm gonna say save that. As you select each case, I can open this up. As you select each project, you can see the wells that are all linked to those cases. See? And then as you're drilling, you can start on linking wells if you want. If the project date changes, I'm just gonna come here, change the date, and it's just gonna move. So let's say if we move everything to 2026, we couldn't do the second one in 2025. You see, everything, because of the linking, everything just changed to 2026. So it just helps you to manage the dates very easily, rather than going case by case to make these changes. You're doing it at the project level. All right. And because you change those dates, there are specific investments, everything is going to be lined up just because you've set this stuff to be automated, right? Okay, so I save that. Okay. Now, if you go to the one that says lateral length, you see the volume is in MCF per month, is being denormalized, is being scaled based on the specified lateral length case. Whereas for this one is going to be 10,000 foot. See how this is around, the QI is around 20,318. If I go to the phase 2 8K, it's a little bit high, it's 25,000. So that scaling was a little bit like we added 2 more times the original type well QI. All right, is there something I'm missing in this presentation? One more thing. One thing I would like to do is to go ahead and use the global editor to apply the graph, the 50-year graph to slot number 1. So that's my global editor. I add everything here, all 20 cases. I go to my graph by number. I would say link graph model. I'll link it twice. I'm going to the first one, I'm going to apply it to slot number. I want to put it on this spot. I'll apply it to slot number 2. So linking is going to make sure the name of this slot changes to 50-year oil, gas, water, NGL, okay? But because I link it, it's going to be very difficult to, I can't edit the graph properties. So I also want to bring it local once I do that linking. So in slot number 2. Once I bring it local, I'll be able to edit all that information. So let's go ahead and hit apply. Okay. All right, so we have the graph name is associated and I can double click. If I didn't bring the model local, I won't be able to double click on it this way. So And you have the EURs, you have the product, you have everything set up for this case. All right, so now we know how to use the prospect case creator to generate our prospects. When you're creating the prospect, you can add them to an existing project, or you can create a brand new project for your prospect. And the other thing we saw is the ability to automatically move our prospects that's in a project just by changing the project date. So we changed the date of this particular project. I thought we changed it to 2020. Did I reverse that? This was 2026. Let's see. Yep. Then I saved that. Okay. Okay. So everything moved accordingly. Perfect. So now that I have my prospect, the ones that use well count, I'm going to create we call the stacked summary plot. Let me see the incremental benefit of bringing this, the incremental volume that we're going to be bringing online by drilling these 10 prospects. So to do that, I'm going to create an incremental summary plot from the existing one. Then I'll go ahead and add these 10 wells to that. All right, so this is going to be talking about stacked summary plot. To do that, I'll right click on the PDP summary plot. I'm going to say create incremental. All right, so this creates an incremental of the PDP summary plot. If I double click to that case, I'll close the project manager. If you go to the case settings, we do have the 100 wells that were there initially. We'll make sure those wells are still there, right? Then I'm going to go ahead and add my 10 prospects from the well count to the list. So now I'm going to be having 110 wells. So I'm going to be gathering gross volumes up to the EUR. Okay. All right, so on the incremental properties that we see on the right side, this is how we can link different information on the base case. So anything you link, it's going to be linked to the base case, and you won't be able to change it on the incremental case. Anything you want link, you'll be able to change on any of those independently. You can change on the base case and then on the incremental case. All right, so I'm going to go ahead and not link anything. That way you can change it from both right now. But the only thing that is changing across the board will be just the volume that we are gathering, okay? All right, so let's go ahead and compile this. Okay. All right, so after the compiling, this is sometime in 2025 because these prospect cases, they started coming online in 2025. So it declines, and then from 2025, you see the well count starts jumping. Where is the well count? Probably don't see it a little bit, but somewhere here, it went up a little bit, and that's where we get this jump. All right. So where the stacked summary plot really comes to play is you can double click on this graph. If you go to related cases, Now you have the option to enable related cases. So on the incremental case, on the graph of the incremental case, the base case is the related case. So if I check this and say enable related cases, that's the related cases. You can have more than one related cases for sure. If you do a second incremental on this incremental and you come to that second one, you'll be able to see two related cases, and then you can see those three wedges. All right, something I like to do for the base case is to make it a little bit lighter. We call that opacity. It's just transparency, that's what it is. So I can make it maybe 60%, that way it's 40% less dark. I apply and close this. Okay. So my graph is a little bit busy. Okay. So I can get rid of my NGL yield. I don't really need it to be on the graph. I can leave the well count. You can see the well count wedge that you're seeing here. That's 100 cases, and then 110, that's just that little bit of wedge. So NGL didn't change because both the yield, NGL yield didn't really change because I used the same yield for both of them. But what you can see here is that for the gas production, for example, if I push my NGL down, okay, maybe push the water production off the chart. So for the gas production, this is what happens if you don't drill the prospect cases. And then when you drill the prospect case, you get that additional. So this is that delta volume that the 10 prospect cases are contributing. So this is what we call a stacked summary plot. And you can have another layer. Like I said, this could have been a situation where all the PDP wells, you actually have an incremental on them, have probable cases for those, and then you forecast them a little bit to have that wedge, that probable volume to that, you still be able to accomplish the same thing. So, but in that case, for the incremental summary plot, you're only going to be adding the incremental of those PDPs. You're not going to do the PDP themselves and then the incremental. You just add only the incremental. Excellent. So this is how you create a summary, a stacked summary plot in PHDwin. I can maybe increase how many log cycles. That way I have every product in a different log cycle. Okay, so I can have my water production a little bit high, have my gas production. I can have my well count to come down a little bit, or maybe to go high for me. There you go. So this is how we create stacked summary plot in PHDwin. So this brings us to the end of this presentations. If you have any question, always don't forget. If you have questions, don't forget to reach out to either myself or Jonathan Smith, or you can reach out directly to training@phdwin.com or to support@phdwin.com. But I'm always going to recommend you reach out to training and to support. Mostly support is your first call. Then for any training related question, reach out to training. Any PHDwin week related content, reach out to Jonathan Smith for any question. And if you do reach out to either Jonathan or myself, make sure you CC these two. That way somebody else can get back to you if both of us are busy. Perfect. Thank you very much. We will see you in a different video.
Thank you very much, Marshall, for that wonderful training segment. We really appreciate y'all joining us for that today. Up next is a replay from an earlier PHDwin week from DeGoyer McNaughton. And then after the replay, or if it might not get done, in case it does, if we don't get through it all, you can always watch the full thing on our client portal, because at 1 p.m. sharp, Jonathan Smith, aka me, is going to sit down and go through the details of data. If you're using version 2, you're using version 3, you're maybe wanting to move from 2 to 3, don't miss that session, 1 o'clock. All right, next up is a replay, so hope you all enjoy.
Hello, everyone. I'm Crystal Cao. I'm Senior Economist from DeGoller and McNaughton. It's my great pleasure to join as a guest speaker of TRC's second PHDwin week. I would like to thank TRC's invitation and DNM's support to provide me the time and resources to prepare for this speak. The topic I will bring today is physical system and reserves economic evaluation. Disclaimer: the material and opinions expressed here are based on my personal study and experience. Some data are from public domain. They are not DNM's opinions. If you have any question regarding your specific project, you are welcome to contact DNM for professional service. With 85 years history, DNM is a leading independent consulting firm focused on the petroleum industry, provides unbiased and informed answers to clients worldwide. DNM skillfully blends energy economics, engineering, and the earth science to help clients in more than 100 countries make the smartest decisions regarding exploration, recovery, and management of oil and gas resources. DNM holds the leading position on resource evaluations, serving government, oil and gas companies, and financial institutes around the world. DNM currently have 8 local offices around the world in oil and gas rich regions, with headquarters in Dallas, United States. As a senior economist, I have been with DNM for over 3 years. Before joining DNM, I worked as an independent consultant for 5 years, helped my clients on reserves evaluation, field study, acquisition project evaluation, and future development plan. I worked with Ryder Scott for 7 years and the China Offshore Oil Company for 6 years as economist and cost engineer in China. I have master's degree on resources and applied economics with the University of Alaska and a major in management for undergraduate study in China. This is just a brief example of the country's type of physical works and clients I have been working on over my career in past 25 years. My practice covers crude oil, natural gas, shale oil and gas, oil sand, and cobalt-methane. I worked on offshore oil fields, shallow water and deep water, onshore fields, and gas pipeline system for price determination. I have worked on projects in more than 30 countries with all kinds of fiscal terms involved. My topic today will focus on oil and gas physical system and its important position in reserves economic evaluation. I will cover the purpose of economic evaluation in reserves, the base and workflow of economic work for reserves and evaluation purpose. I will also introduce briefly on the oil and gas physical system, the royalty system and PSC system, give summaries on how reserves entitlement determined in different physical systems. After that, I will also share why I think PHDwin will help improve the efficiency and accuracy on reserves work. What is economic evaluation for oil and gas industry? The fundamental of economic evaluation is a project economic evaluation. A cash flow model is used to measure the cost and returns on oil and gas development project and its ongoing operations. The economic evaluation will be conducted at all stages of a field development, as early as even before our exploration activities start and end with field abandonment. The net present value, NPV, is calculated to measure the project's profitability and, most importantly, the oil and gas properties value at a different time point. There are internal reasons and external reasons for energy company to run economic evaluation. For the internal management purpose, economic evaluation is used to determine the profitability of a project. This is the base of decision whether to invest or not. The sensitivities will be run to identify key future risks, such as prices, costs, production. And it is a very important tool for asset management, as well as property ranking and reserves management. For external reasons, the reserves evaluation result and company's value will have to be disclosed in the financial report to inform investors of the company's current financial status. Also, in different markets, there are different regulatory filing requirements for the public traded company. Requirements for the public traded company, the regulations are different by market and by country. At the country level, government needed to keep tracking on national level oil and gas reserves and potentials. Those are key factors for country's energy safety. There is more on project economic evaluation. The base of a project evaluation is single project feasibility study. This is a method on company commonly used for project investment decision making. The economic evaluation method used for company level project evaluation is very close to what's in PRMS guideline. PRMS guideline is constructed based on industry's best practice For project evaluation, multiple production scenarios will be run with the base case close to 2P reserves, sometimes referred to the best practice. A reserves economic evaluation will normally run with the financial assumptions based on the rules in the different market. In US market, the public companies are running the evaluation based on SMART, which stand for Standardized Measure of Discounted Future Net Cash Flow relating to proved oil and gas reserves quantities. It's required by SEC, the US Security Exchange Committee. The method used is a cash flow-based economic limit test. We all know that the economic limit test for reserves purpose is to determine the quantities, the volumes, not the value. However, for PSC oil and gas fields, we will need to run full value evaluation to determine the contractor's net entitlement quantities. Many years ago, we see a lot of reserves reports only report working interest reserves. In many cases, it is not the same as the net reserves. And we should know the net reserves can be equal, lower, or even higher than the working interest reserves, depending on the fiscal terms and the project's specific financial situation. This is the reserves evaluation workflow. It's normally started with geologists working on oil and gas in place volumes estimation. And then reservoir engineer will estimate recoverable resources and provide production profiles by reserves category to economists. The economist will conduct physical terms to build an economic model, collect prices and cost data together with the production forecasts to run economic limit tests to determine net reserves. In some situations, the economic test can be done with help on reserves evaluation software like PHDwin. It has built-in standard economic evaluation functions to guide through the whole process of forecasts, cost, price, and tax inputs. But as I have mentioned in the previous slides, the physical calculations sometimes can be very complicated to work directly by an engineer. This is when the economist has to be involved. I will talk a little bit on how complicated the financial calculations can go. Do you know there are more than petroleum physical systems in the world than there are countries? Some countries use more than one system. And since the terms are negotiable, the physical terms are varying project by project. But it does not mean the economist has to build models for all different projects. There are three major oil and gas physical systems: the concession system, the production sharing system, and the risk service system. The concession agreement, or so-called royalty contract, like what we have in US, is relatively simple, and most commercial reserves evaluation softwares already have built-in functions for royalty type of physical terms. The most difficult part of the physical system is the PSC system. This chart just to show briefly that how the physical systems in the current world looks like. There are about 50% of them are royalty type. We see it in Europe, North America, Latin America, Australia, and old Middle East contracts. And there are 55 are PSCs. We see those in Asia country, Mexico, Africa, and new Middle East countries. Also, there are a small part are service contracts we normally see in Latin America and Middle East. We see the trend of increasing the use of PSCs when the country reforms the fiscal system. The PSCs have advantage to keep the benefit of the windfall profit to the country from strong oil price or larger oil gas discovery, and still can provide incentives to the marginal projects. And due to the market downturn or some difficult to develop areas, like some deep water and unconventional projects, fiscal system plays a very important role on reserves recognition. What the percentage of a field production can be recognized as reserves are fundamentally determined by the project's physical terms. For properties with the same profitability, it will make big difference on net reserves if it is in royalty system or in PSC system. For royalty system, about 85% to 100% of the working interest reserves can be the company's net reserves. But in the PSC system, the net reserves will be a lot less than the royalty system. And it has to be calculated using the specific model built for that contract. The risk service contract, like what we see in Iraq, will have a lot less reserves when compared with PSC system. This chart is just to give us a general idea on how much net reserves we can expect from different fiscal terms. It is very important to know that in different systems, contractors' revenue is calculated differently, which is based on the terms defined in the contract or the agreement. For concession or royalty type of fiscal terms, contractors' revenue is straightforward. It starts with the sales price and sales volume of the oil and gas. The royalty will need to be deducted from the total sales revenue if it's taken in kind. If the royalty is taken in cash, we treat it as a tax. It will not be deducted from contractors' net revenue or reserves entitlement calculation. Note that the taken in cash royalty will be shown as a cash outflow in the cash flow report. For production sharing contract, the contractor's revenue are calculated from cost recovery and profit sharing, normally calculated based on actual sales revenue. The specific terms vary from countries or fields, so it's important to read through the contract and verify the terms for formulas. The financial statement shows the cost recovery and profit sharing calculation in the joint committee report. That should be a very good source to use to verify formulas. The risk service contract can be very simple or very complicated. It can be the combination of the simple service fee calculation and cost recovery and profit sharing. It sometimes uses the concept from PSC contracts, but need to check carefully on what price to be used for the cost recovery. It most likely different than the real market price, as would normally used in the royalty and the PSC system. This is a flow chart to show the royalty or the concession contract workflow. It's pretty straightforward. Let's start with what may be said is a gross revenue, just the real sale production and sale price. Then for the contractor's cash flow, the deduction are from two parts. One is as shown in the yellow, is a cost part. We normally see the operating cost, exploration cost, and the capital investment. And another part of the cash outflow for contractor is a royalty and some other taxes, and also the income tax. Those taxes are the government income, so it shows as a government cash flow. This is the PSC workflow. We can say it's much more complicated than the royalty type of workflow. So it's also start with the gross revenue, but the cost recovery and profit sharing part will need to be calculated based on the fiscal terms. We can see the contractor's share are from the cost recovery and profit sharing. Then the deducted by the regular operating costs, CapEx, exploration, and any other taxes, it should be included. Then government share is going to be not just come from the taxes, it's also profit sharing part goes to government. This is the physical terms we will normally see in the PSC terms. First, the cost recovery. We will see the cost recovery limit. The capital uplift means the CapEx can be recovered more than it's actually spent as incentive. And cost recovery in certain order, like we have to recover the operating costs first, then recover the exploration costs and capital investment. It's the cost recovery order matters because in some PSC, the operating costs, exploration costs, and capital investment has a different ratio. So we will all see all kinds of this type of terms in a PSC. And sometimes we also see the oil and gas cost has to be separated for cost recovery purpose. So like what we have in Indonesia. The cash flow model has to have two separate streams, one for oil and one for gas. So oil revenue, gas revenue, and the related cost has to be separated. Then for the profit sharing part, the terms we'll normally say is we can have the fixed rate profit sharing, which is much easy. And we also have some terms is the sliding scale based on production or based on production and price. This is the kind of terms government use to get more from production when production is higher and when the price are higher. And we also have profit sharing terms based on project profitability. Then we will say the R factor and the equity investment ratio, the cum income versus cum expense, or simply IRR. So those factors or index are all the factors evaluate the project's profitability. So this, when you see this type of profit sharing terms, you will know the cash formula or the model will be more complicated than any other else. There are some special terms we will also see in PSC, like pay on behalf. In some cases, and the tax are not paid by the contractor, it's carried by their state company. So it's kind of tricky, very tricky when we have this type of terms and some contractors ask to get the reserves benefit from those terms. This can be a very complicated and tricky topic. And also we know in Indonesia, there's a domestic oil obligation. So 30% of the production has to sell to government with a very low price. And this is also cause some difficulties when you calculate the reserve. This is the flow chart for the risk service contract. Actually, this is a very simple chart. So the thing I want to emphasize here is that we pay attention to the contractor's revenue part, because in this case, for risk service contract, Sometimes contractors' revenue is not calculated directly from the market sale price. It's based on the contract price. Then the difference between the market price and contract price, the profit, the benefit goes to the government directly. So in this case, government may sometimes also have different resource of the revenue, except the tax. The government also have the revenue directly from the production sale. This workflow chart is from the real example of the work I did before. You can see the complication of the work can go without integrated tool. In this case, client production database were provided in OFM and Excel. My engineer was using ARIS database for production forecast and the economic data input on well-by-well basis. It was a PSC field. So client provides PSC model in PEEP at the field level. On top of that, my company was using an in-house software to generate reserves report. And I also had an Excel PSC model to check and verify the PEEP results. So I end up have to run 4 sets of evaluation with the same data at a different level, using different software, and all of them has to match. The work at least tripled here. For years, I was constantly searching and testing other solutions. I started testing on PHDwin in 2008 when I involved in a project to check on the PHDwin cash formula models for a client for its all offshore properties around the world. Most of them are PSC contracts. It was my first time get to know the physical modeling part of PHDwin software. Before that, the PSC models I handled are all in Excel. My clients using PHDwin as a sole database for wild or reserve level production history database, create production forecast, run economic for very complex PSCs, and create reserves report directly in PHDwin at well level. My client was worried about PSC calculation and think it was a black box. Nobody can easily check and verify on the economic results. With the help from TRC consultant, I learned how to create cash formula review to check on PSC wrong, and even help TRC clean up some bugs in the model. So I know the cash formula functions in the PHDwin is not a black box. All the formula modeled are easy to track and check. PHDwin become my main tools for reserves evaluation, especially at the time I worked as an independent consultant. I use PHDwin for our client for their long-term strategic planning on their shale properties in US. It's also handy and powerful for the individual consultant to run an integrated project with minimum technical support required on data loading and reporting. It's also very consistent and reliable with multiple people, engineers, technicians, and economists working together in the same system for a job involve a large team. It delivers the detailed and well-structured economic results, which will fit all kinds of reporting needs and will fit very well with any in-house reporting system any company may have. And of course, my favorite part of PHDwin is the open interface of the physical terms modeling function. I can build my economic model directly in the PHDwin system. Once the model is done, engineers can run and create the updates report right after they make changes on forecasts and costs. They don't have to wait hours and even days on economics and technicians to export forecast, rerun economic models, recreate summary tables, and check again. It significantly reduced the human errors and free me from repeat my work again and again. So I can use my time on most important things like verify economic inputs, communicate with clients and engineers to better understand the project. I run all type of economic jobs in PhDwin, especially for reserves jobs. But please don't take me wrong. I never see we should get rid of Excel-based models. The Excel model still have many benefits. It is very flexible. It is naturally the first choice for any type of economic evaluation needs, and you will still need to have an Excel model to routinely verify the PHDwin PSC results for model maintenance. Whatever I get chance, I will create a simplified version of my new Excel model, make it ready to use as an instruction file to convert it to PHDwin cache formula. I know the new V3 version of PHDwin is more powerful, and I am still learning and have great expectation on that. After I make the transition to V3, I wish I can share with you again. Here's my contact. Please feel free to contact me if you have any economic related questions. And please also keep in mind that DNM's expert team is here to serve you on oil and gas reserves and much more. Thank you.
Thank you to Gory McNaughton for that session from 2021. That actually is our most popular and most replayed PhDwin session of all time. So I hope y'all enjoyed it. I, Jonathan Smith, am going to be on at 1 o'clock. And so, run to the bathroom or something. I'm going to come back on at 1 o'clock and I'm going to do my final session for the week. I'm going to warn y'all ahead of time. I have a lot of information to cover. With apologies to Zach Warren, he's set to start at 2 o'clock, but I might run a little bit long. So we will start his session the moment that mine is done. I'll do everything I can to get it done in an hour. But quite frankly, this is the most complex session I've done for PhDwin Week. But I really appreciate y'all watching, and I hope that y'all get something out of it. Whether you're in version 2, you're in version 3, you're looking to move from version 2 to 3, no matter where you are in our ecosystem, I did everything I can to make sure this next presentation is going to give you something to make you more effective at using our software. And so be sure to catch me in 2 minutes at 1 p.m. For my session about the details of data and the 2 versions of PhDwin. And then whenever I get done, as I said, I'll try to get done in an hour, but whenever I get done, the moment I get done, or if I get done early, which I don't probably see happening, we'll see, Zach Warren will be following up right behind me with his excellent presentation that I think actually might be one of the more popular ones this year. And so y'all stay tuned. We've got more exciting things for you this PhDwin week. Hello, everyone. I hope that you're having a good PhDwin week. Hope that you're enjoying the content so far this year. I've really been enjoying it this year. I think it's been a great year. And we got more left to do. Today, I want to talk a little bit in this session about something that throughout the year just kept coming up for me. Every time we do a PhDwin week, every single year we do this, and every time we do one, I always come in and I say, I need to cover this topic this year. I need to make sure I get this topic explained this year. And this was definitely the topic for me this year. Recently I taught the version 2 and the version 3 training classes in Houston. And as I talked in those classes, it became clear to me that connecting some concepts in here in a way that you can't do in, individual classes is something that would, I hope, provide a lot of value for you, the person who's watching this stream. So who am I? My name is Jonathan Smith, and I'm the Director of Sales at TRC Consultants. I'm also the Director of PHDwin Week. But as I said, also I've been doing some training classes recently, which really inspired me to get into doing this session. So in this session, I want to talk about data in version 2 and version 3. So it's going to be a little bit of something for everyone, but let's go ahead and start with version 2. And so where I want to start with version 2 is that there's 3 different levels of data in version 2. There's archives, there's partners, and then there's database level data. And so what we call this qualified data. You might not know it. You might have heard that term before, like qualified data. And you might not know that you're using qualified data in version 2. There's not any particular part in the program that says this was qualified data. But whenever you break it down, you look at it, using the archives feature, using the partners feature, and then just at a database level, there's 3 different levels that things are qualified in the program. Now, before I break this down and get into it, I want to point something out. That on my infographic here, the archives line and the partner line are the same length. That's because they're qualifying completely different data, and I wouldn't put one over the other. They're not like nested into each other. In fact, the 2 features really have no relation to each other in version 2, but both of them are within the database, which is why that has the longer arrow, because everything gets qualified at that database level, and then within that, then it gets qualified by partners or archives, or maybe not at all. Maybe it's just qualified at the database level. So we're going to start off with archives and talk a little bit about this. So what is archive qualified data? So in an archive in version 2, we store 2 different things. The projections of products. So, what is your forecast for oil, gas, water, so on. And then the actual product configuration. For NGLs, how does that product work? For something like sales gas, what's the formula that goes into it? Whenever you're just talking about oil, is it using ARPs? Is it using just a linear forecast type? Is it using scheduled data? That sort of thing. That is all defined within the archive in something called a product tree. That's the version 2 word for all that product definition. In version 2, only one archive can be active at a time, though. So if you're looking at a report, you're only seeing the active archive. Or if you're actually editing the forecast on a graph, the only forecast you can edit is the one that's active. Now you can see 5 other archives on the same graph. So maybe if you have an archive that's like a high forecast versus a low one, you can only edit one of those 2 at one time, but you can see on one graph the high versus the low. And so the program, the idea here is that the program is archiving off those different forecast sets, those different product definitions. And probably the most appropriate example is the concept of a reserve group that's just working in the program, and then year over year, as they update production, they have new sets of forecasts. They want to archive off last year's forecasts, and so they save last year's forecasts in a different archive than the one for this year that they have active this year, so that way they can edit and build it for this year. And so that's where the term kind of came from, but you need to know what goes into it, which again is projections of products and actual product configuration. Next up is partner qualified data. So in PHDwin version 2, a partner can vary 3 different things. So there's 3 different types of data that can change whenever you load different partners. First of all, every single partner can have different ownership on the cases. Now they don't have to, but they could. So, a very common example here that I like to use is in the same company, maybe there's some wells that the company has royalty interest in, maybe there's other wells that the company has working interest in, and they want to separate being able to report out, because they might be the same set of wells in some cases, maybe not, but maybe there are some wells that they have both a working interest in and a royalty interest in, and they want to be able to separate those 2 different revenue streams out for reports. So they would have one partner that's the working interest partner, one partner that's the royalty partner, and then as they go back and forth, then they're going between a partner that has 100% working interest and most of the revenue interest versus a partner that has 0 working interest and just has a little bit of revenue interest to be the stand-in for that royalty.
So that's the common example, but there's many different, ways to use partners. The name really comes from the concept of like three guys owning a company. They own a third of the company. They all want to see it like their report, what they own of the company. So that way, if you totaled them up, it'd be 100%, but each partner only has a third or something like that. But that's not the only thing we can vary with partners. Ownership is the most obvious thing to vary with partners. So what's in that ownership tab itself, basically, when you're in the case editor. But also investments can vary by partner. You can either have the same investments between partners, you can have different investments between partners, or you can have one partner that has the same case, but in one partner it does not have that investment, and one it does. And so that's very useful for situations where contractually maybe only one entity has to pay for certain things. Like back to my example, the royalty holders are not going to be paying for any kind of uplifts or compressors or any kind of those extra expenses, that CapEx, as we sometimes call it, that can be required to keep wells running properly. That's only going to be on the working interest partner side. And so it will only be loaded in that partner's setup. It'll only be qualified to that partner, to make this clear. And then the last thing is case selection. So as you go back and forth between partners, if you set it up this way, it can work like a filter. So maybe you have royalties in a lot of wells that you don't actually have working interest in. So when you load the royalty partner in the same database, it has more cases in the case list than the working interest partner. So that's one example. But the idea here is whenever you build a partner, you tie cases to that partner. And then whenever you load that partner, all the other cases are filtered out of that case list. They're still in the database, but you can't report them out or edit them until you go back to a different partner, or maybe the all cases main partner. And so I keep talking about reporting. One thing to note is that you can report out partners separately. You can load a partner, stand on a partner, and just load out that partner's interest or that partner's perspective is what I often say. But there is a feature in the program where you can have multi-partner reports. So if I need to glue together the working interest side of the company and the royalty side of the company to make a whole total company level report to see what all of the revenue for the company is going to be, you can do that using multi-partner reports. That's different from the archive, where again, only the active archive can be edited or reported out. You can't report out more than one archive. You can report out more than one partner. So that makes partners pretty flexible. Also, there'll always be an all cases partner. No matter if you don't have any partners, you have one. You have the all cases partner. That partner is meant to be the catch-all. It's the one that has all of the cases in it. So again, case selection is qualified to a partner. And what we don't want is you delete the partner. So let's say you delete the royalty interest partner and you lose those cases from the database. Instead, all the cases will always be in the all cases partner. And then later on, so at the very end of this session, I'm going to give some tips about how to best manage data in version 2 and version 3. And so, I'm going to talk a little bit about a tip I have about this all cases partner. But for now, just know it exists, know that there'll always be that partner, and know that it's meant to be kind of the catch-all. It's meant to be the one that has, according to the name, all of the cases in it. So this is an example of the partner window. In here, I have the example I was talking about earlier. There's a royalty interest partner and a working interest partner. And if you select one or the other, then you'd see those ownership changes, you'd see those investment changes. On the right of the screen, I have the actual window where you create a new partner. Notice you can put in a purchase price for a partner, which would show up on the reports on the eco indicators. You can make it so a partner has a percentage of the ownership of some other partner or of all cases. Or you can leave that at 100, load the partner, and then go case by case, or maybe an edit date in Excel, and apply ownership to the individual cases, and then it will be saved to that partner. And then as far as ownership is concerned, you have two different options there. You can either just copy over the ownership that, say, the all cases partner has to this. So whatever the default partnership is, whatever that says default ownership line, 100% of all cases, you can either copy from that partner all the investments, and then it's just a copy. Then you can change them on this new partner you're creating. Or you can link investments from the all main cases partnership, in which case you can't change any of the investment values or the investments themselves in the individual partner that you're creating. You can only change it whenever you have the all cases partner loaded. Or you can leave both the boxes unchecked, and the new partner will have no investments in there, and then you can either go build in investments, or like in my royalty partner example, maybe I don't want any investments, and so I'd leave both boxes unchecked. and then I would just build the partner. So that's the first tab. Second tab is case selection. That's where you drag over from the case list the cases that are in the partner. And then whenever you do that, that's how it sets up that case filter, basically, that's built into the partner tool. So that's the partner. And the partner, again, is fundamentally different from the archive. They don't overlap. The partner is not touching projections or products, and the archive is not touching ownership or investments. And so they're just completely different in version 2. The streams don't cross. So let's talk a little bit about database qualified data. Pretty much everything else in version 2 is database qualified data. And in version 2, we call the databases a project. So you have project properties. Everything that's in project property is basically everything in the database. So what's in there? Like all the case names, the ID codes, the historical productions, what templates you're using on the graph, the expenses, the taxes, the prices, the eco options, the memos, the conventions. There's a lot more, quite frankly. I couldn't just list everything, because just think about it this way. Anything I just did not cover with archives and partners, all the rest of it's saved to the database, qualified to the database. Now, I say it's database qualified data, but actually version 2 has 2 different databases that go together that make that version 2 file. One of them is a PhD file that has the case data in it, the lease data in it, and then one of them is the .mod file that has the models in it. So like your expense models, your price models, your tax models. Now, even though both of those are database, what I'm saying as far as database qualified data, everything that we're talking about is saved within those 2 files. And really what you're thinking about is maybe the PHZ file. So a PHZ file is the zip file of both those put together. That's what you send to someone. You send someone the PHZ file. So if you send them the PHZ file, they get everything. They not only get your archives, they not only get your partners, but they also get all this other data that might be varied between, different projects in PHDwin. Very little is saved to the local machine. As far as I know, the BOE calculation is the only thing that can change economics that's actually saved to the local machine. There's some settings. You can save type curves and your favorite sorts and all that to the local machine. Your favorite graph templates can be saved to the local machine. But as far as changing the economic models, changing the output in the program, everything that's except for BOE calculations is included with the PHZ file. And that's how you get the data from one machine to the other. So in the version 2 era, because so much is database qualified data, I know a lot of clients, they keep multiple versions of basically the same database just to qualify different parts of that database. So if they want to have, for example, 2 different expense setups for the same group of cases, they kind of sort of have to have 2 different databases, especially if it's hard code expenses and you can't easily switch between them using models in the global editor. Then you have 2 different databases that have 2 different expenses in them. And then every time you update the price, you have to update 2 different databases. Every single time you want to update pretty much any of that information, like production information, you have to import them to 2 different databases. And so this is a bit of a juggle. I know some of y'all are nodding y'all's head right now. This is your life, right? And so this is something we kind of wanted to get away from. That's why we're trying to qualify more data going into the version 3 era. And so let's talk about that. Let's talk about how the data comes from version 2 to version 3. And so before I get into this, I just want to say again, version 2 people, I'm going to have some tips at the end. So make sure y'all are paying attention, because I'll have some good stuff for you at the end of this session. If you're planning on staying in version 2 for a bit, that's okay. I still got some stuff for you. But I know a lot of y'all, especially this year, there's been a lot of questions because we have had a lot of uptick in people wanting to move from version 2 to version 3 this year. So I want to talk about this. What happens to your data whenever you import the data from version 2 to version 3? So version 3 treats the version 2 PHZ file like it does a DRI file, like it does a CSV file. It imports the data. It's not a transfer at that point, it's an import. And why it's an import? Because it changes the data sum to fit into this new paradigm that we have in version 3. And so I want to try to explain this new paradigm for you and how things shift over, so that way you can get an idea of where your data is and maybe understand a little bit more what's going on in the new version of our program. First of all, in version 3, there's this new concept called scenarios. So in a little bit, I'm going to talk about all the different types of data and how they're qualified in version 3. But for now, version 2 people, let me try to translate it for you. The way I like to explain it in the classes is that a version 3 scenario is like a super partner. So imagine this. So we talked about the partner concept earlier. And in version 2, it can only vary the ownership, the investments, and then the case selection. Imagine a partner that could vary the projections, can vary the expenses, Could vary the prices, the classes and categories, the shrinkage, and or maybe eventually the taxes, right? Alongside ownership and investments. I say taxes soon on there because we're going to do that in a future build. But just think about that. Think if you go between partners and the forecast change. Well, that's a lot like what an archive is doing in version 2, but now it can be done as part of the scenario. And so actually, whenever you go from version 2 to version 3, those partners get imported in as scenarios. Scenarios get built for every single partner you have. So if I import that file I showed you earlier, it'd have a royalty scenario and a working interest scenario. And then it would build new qualifiers for ownership and investments, because those are the two things that can be varied by qualified by, in version 2 with a partner, which is ownerships and investments. And so by default, though, that scenario is going to have the same case list as the version 2 partner. So if you had a partner that didn't have all the cases in it in version 2 that were in the database, whenever you import that file to version 3, the scenario that gets set up is going to have the same case selection as that partner. So if you select that scenario, you'd have that limited partner list. That limited case list, just like the partner does. Now, there is a concept here I'm throwing at you, which is a qualifier, that new qualifiers are built for ownership and or investment. So what's a qualifier? I'm going to get into it in detail whenever I talk more about version 3, but just kind of a bit of a translation for the version 2 folks out there that are needing a translation. The way I like to think about it is that a V3 qualifier is like a super archive. Okay, the super stuff. It's like Superman, right? You get a super partner, you get a super archive. What do I mean by this? So in version 2, an archive can just vary the projections and the product definition. But imagine an archive that you could save to it prices or expenses, or your shrinkage, or your ownerships and your investments even. Imagine if you could go between archives and that would change your price without having to go through like a global edit or something. Just by switching them, it would just change what your price is. Or by switching them, you could change from one hard-coded set of expenses to another hard-coded set of expenses. Well, that would get rid of you needing to have two different databases to have two different sets of hard-coded expenses, right? So that's already showing that in version 3, we have more ways to qualify data than we had in version 2. And whenever you do that import, it automatically sets up and builds these qualifiers for you. And so one thing to think about, though, is that the product configuration is not part of this new thing. It's not part of this qualifier or the super archive, as I've labeled it. Why? Because now in version 3, product configuration got moved to being a database level piece of qualified data. Quite frankly, the concept that every single case could have a different product configuration based upon archive than every other case in the database created problems in the version 2 era. As we've been moving clients forward from version 2 to version 3, we keep noticing within companies with like large data sets, there's multiple engineers working on them, and it's come up a couple times where one engineer was doing water flood this way and one was doing it another way. And then when we imported the file to 3, we're like, wait a minute, why do we have this conflict here? And they, we've kind of forced some meetings at some companies where it's like, hey, what's the right answer? Well, I'm right. And they both point at each other. No, I'm right, right? Who's right? There had to be a meeting. You'll have to sit down and talk about it. In version 2, the meeting didn't have to be had because it could all be separate. But is that right? Is that right to have the same type of well-modeled 2 different ways in the same database? Probably not. Or I'll give you another example I see a lot of. In version 2, people try to do unit conversions in the formula, in the product formula itself. And so, I'll have 1,000 cases and maybe they did it right on like 800 of them or even like 950 of them, right? But 50 of them, they missed up. They mistyped when they built that formula. And instead divide by 1,000 to do a unit conversion, they divided by 100. Well, that's 50 cases that are just fundamentally wrong. How do you find that? Well, whenever every case can be different with a product configuration, I'll just say it's kind of difficult. So we've moved in version 3, we've moved product configuration to a higher level. Now it's being database qualified instead of it being qualified by the super archive, aka the qualifier, because that allows for consistency, what we call data discipline between the cases. That's us we always talk internally about trying to put that horse back in the barn. That's us trying to put a horse back in the barn that we probably should never have done. We did kind of create some problems, having it so it was a little too flexible with product configuration. And so now it's kind of more like a V2 model, not quite, but you build a phase configuration at a database level, and then you apply that configuration to what products you can use and how those products behave at a case level. But at the case level, you can only select what you built at the database level. You just can't add in a hard-coded one at the case level. It's going to be a pick list defined at the database level. So that's a little different. And that's something that when you import that V2 file, if you have a bunch of different product trees, each one of them comes in at the database level as a new phase configuration. And then they just stack up in your list of phase configurations. And if there's any of them that have a problem, like there's a logic loop, because you have a formula where, gas is being times oil or something is a product, and then there's a different product that's like divide by oil or something, and there's just a logic loop going on. In version 3, it actually notifies you that there is some sort of circular logic, and then you can go and fix it after the import is done, which we've caught on a couple V2 files, because V2 didn't have any kind of warning for that circular logic. It just wouldn't calculate properly. And so this is something we feel like we fixed up, but this might not make sense yet. I mean, me using shortcuts like Super Partner, Super Archive, I know that clicks for some people, but it doesn't click for everyone. So let's actually get into the detail of it. Before I get there, the last thing I want to talk about is just that database qualified data. And that is, what were project settings, right, in version 2, that has now been turned into scenario settings. And for the most part, they're the same, like how many units, cash accrual time, how many units you're discounting by, so how, N per year or whatever, right, or 1 or 12 or whatever you set there, what your discount factor is, or when you're, what the actual name of the scenario is, just like you could name projects in version 2. A lot of this is the same, except for one thing. In version 2, we had something called an as of date. I used to call it the everything date. What was the as of date in version 2? It actually did 3 things. It was whenever cases started running their economics, is when everything was discounted back to, and it was whenever everything was reported from. And so in version 3, we actually broke those 3 functions of the as of date into 3 different dates. And whenever you import a version 2 file to version 3, all these dates stay aligned initially to the same date, but then you can vary them. So now in version 3, there is a report date, which you're reporting from. That can be different than the discount date, which you're discounting back to, which can be different from whenever the cases start running economics. So in this gives a higher level of control. For years, clients asked us to discount to different dates than they're reporting from. So we broke these into these different dates, so we have a more flexible economic engine that was possible in the version 2 era. Another consideration I just want to bring up is there's no files anymore in version 2. In version 3, everything's in SQL Server. You don't have to worry about the mod files and the PHD files. And so the mod file is gone. The PHD file is gone too. They're just part of that SQL Server database. Then you're not managing files anymore. Instead, there's a form within the interface in version 3, and you just do all your models in that form. That's how you manage them or create new ones. You can move models between databases, but you don't use a model file. There's a report that we built called Models Audit. You save that report as a CSV, and then it can pretty much automatically import into another database. And that's how you can move models between databases. If you're curious about this, earlier in the week, Garrett did a whole session about the new reports in version 3. And so he can show you a little bit in that one about how it works. But just know that the model file is gone. Now, you can still use model files that can import into version 3. And I do that a lot. Someone sends me a model file with updated pricing. I just imported it into my current version 3 file. But there's no way for version 3 to then make a model file. At that point, you're just going to be making a CSV file using this model audit report. So that's just a small consideration, a bit of a sidebar. Let's get back to the main conversation, though, which is qualified data and what levels are data qualified at. So here are the 3 levels that we have in version 3. And we already kind of hinted on this earlier. I kind of alluded to this earlier, but let's get into details of it. First, there's the qualifier level, there's the scenario level, and then there's the database level. So again, the qualifier level, that's the super archive. The scenario level, that's the super partner. And then the database level is exactly like we had in version 2, which is basically everything else. Notice something though, there's a key difference here. Notice that my qualifier line here is shorter than my scenario line, which is shorter than my database line. Why? Because all the qualified data is actually nested into the scenario level. And then all the scenario data, of course, is nested into the total database. So where archives and partners were completely separate from each other in version 2, in version 3, there's actually this kind of hierarchy going on where you have a scenario that has certain qualifiers in it, and then your database has certain scenarios in it. And there is a situation where data that is qualified at the scenario level cannot be qualified at the qualifier level unless it's qualifier qualified data. Ooh, it's a mouthful, right? So let me get into the details of it. Let's actually break this down. It'll make a lot more sense. So what is qualifier qualified data? I love this one. This one's easy, actually. This one's the easiest one to understand out of the 3 levels because there are very defined categories that can be qualified by qualifiers in version 3. Here's what they are. Projections, just like the archive version 2. Expenses, prices, your classes and categories. So, maybe in one qualifier, a well is producing, but in another one, it hasn't been drilled yet because the timing is different. So that one's still undeveloped, a PUD, right? And so that can actually vary between qualifiers. Your shrinkage can vary between qualifiers. Your ownership and investments can vary between qualifiers, which was the partner feature. Now they get brought in as different qualifiers. And then, as I said, we're working on having taxes, what we call fiscal models in version 3. We plan on having that also being a qualifier as well. So a lot of y'all are used to other products that already have qualifiers in them. So y'all are probably used to this list. But if not, this is new to you, just know that this is the list. If it's not on this list, you cannot qualify it by a qualifier. But there's a lot here. So if you want to have a qualifier that has a high price and another that has a low price, you can vary between them and go between a high price and a low price. Or a high forecast versus a low forecast qualifier. Or one qualifier that's the royalty interest versus one qualifier that has the working interest, right? So a lot of these concepts start to come together. So it's actually pretty easy to understand what's in a V3 qualifier because it's this defined list. And here it is in the actual program. Here it is in the GUI. So in my default scenario, for each one of these, I just have a default qualifier. You always have a default. Like version 2, we always had all cases main. In version 3, you're always going to have a default scenario, and you're always going to minimally have a default qualifier. Now, you might have more, but if not, if I just have the default here, then I'm not varying anything by qualifier. I'm not varying anything by scenario. I can go in here and I can change the price, but then that's just going to be saved over on top of that same last price. I go and I apply a new model with the global editor, then that's just going to save over the last thing I did. In version 2, that's all you could do. Because something like what price you ran on a case was a database qualified piece of data. You had to go between whole different projects to vary that. In version 3, though, that's kind of how it works by default. Whenever all you have is the default. But as you build out new qualifiers, as I said, you can have ones that are the high versus the low. You can have ones that are maybe what my price was last year, last quarter. Or one thing that came up a lot in the version 2 era is clients would want to archive off expenses. They want to have basically an idea of what their expense were in previous periods for lookbacks. But other than saving off the whole database, there was no easy way to do that. And here I can actually have qualifiers for maybe each year, each quarter that then vary. So that way, if I need to do a look back, I just load that old qualifier and then I run the report and then boom, I can see those different expense setups over time. So that's why we went in this direction. It's a lot more flexible. But all these qualifiers together, again, are going into that default scenario. So let's talk about that. Let's talk about scenario qualified data. So what is in a V3 scenario? Again, super partner, right? So remember when I said earlier the super partner could vary all the things I showed you on the previous screen? Well, they can. So the first thing that a scenario has is what qualifiers are in it. So you basically take a bundle of the qualifiers like we saw on the previous screen, and you put those together, and that is the basic of what a scenario is. So what qualifier are you running for price or expense or projection? That can be changed by scenario. You can have one scenario where all the qualifiers are the same except the NYMEX price. You could have another scenario where all the qualifiers are the same except you have it set up with a flat price qualifier. And then by going between the two scenarios, you're actually going between a flat price and a NYMEX price. That's the first thing you could do. But there's more to it. There's more saved at the scenario level than just the arrangement of qualifiers. There's the actual scenario settings themselves, which for a lot of these were basically project settings in version 2, such as the name, the report date, the discount date. Remember, those are broken out now, not one as of date. Those are two different dates that together used to make the as of date. The start of the period, so when are you reporting from? Max Echo Life, how long will it run for? Default 50. The discount date, the discount factor, PV10 or whatever. The discount method, the discounting periods, the cash accrual time. If there's any inflation being applied to that scenario, just like version 2 could apply inflation, we can now do that at the scenario level. And then if there's any kind of scenario notes or if there's like a report title block, then that's done at the scenario level. There used to be project notes. Now in version 2, now we have scenario notes in version 3 that can vary between scenario. That's one thing. Then that one makes sense, honestly. These things, whenever you set up a scenario, you see each one of these. And so you can look in the window, and I'll show you all just a second a screenshot of the GUI. It's very clear what is the scenario qualified data whenever we're talking about the settings, because they're literally right there. When you build the scenario, you have to fill all these in, right? But there's more going on. And I was talking to a particular client, and this was what inspired me to do this whole presentation, this whole session, is I was trying to talk to him about, qualified data versus scenario qualified data. And he goes, no, John, I get it completely. Look, I open up the scenario window and it's just these settings right here, right? That's all the scenario qualified data. And I went, no, actually, it's a deeper well than you think. And there's some stuff that we're not showing blatantly in that first window where you build the scenario. That's still scenario qualified data. As you go between scenarios, these can change. A big one that catches people all the time is case relationships. So even back in the version 2 era, we had incremental cases, recompletion cases, group cases, right? Allocation cases and unit cases and all that, right? Platforms and all that. In version 3, we still have all those. Yay, it's a great feature. But in version 3, they can actually vary by scenario. What do I mean by that? Well, back in version 2, if you wanted to have 2 different incremental trees, how'd you have to do it? You'd have to have a whole 2 different databases. You couldn't have within one database 2 different incremental trees. You couldn't have one case be an incremental of this case, and then in a different scenario or situation be an incremental of a different case. You'd have to have a different database to do that. In version 3, those linkages, the incremental tree and all the links between the cases in that tree is saved to the scenario level. So you can literally have a scenario where it has a completely different incremental tree than another scenario, which can create problems. If you don't know that that's being saved at the scenario level and you have a scenario in there, you just go and create a blank new scenario, you might not know it, but you might be losing a bunch of case relationships that you don't want to lose. So I've got some good tips at the end of the session for both V2 and V3 people to kind of get around some of this. But know right now, this is the shocker for a lot of people, case relationships are saved at a scenario level. And there's a new one too. In version 3, we have this whole thing called a project manager. So what that is, in version 2, people always used to ask us, whenever you do a prospect case wizard, right, and you build all these prospect cases, people would want to go back in and change the timing. They'd be like, all right, I built all these cases. Now where do I go and change the timing for the cases? In version 2, we go, no, you built the cases. They're cases. Go edit the cases, the end, right? They weren't tied together after you built the prospect cases. We fixed that. In version 3, well, I'm not going to say we fixed it. We improved that. In version 3, we made it so that now all those prospect cases are tied together in something called a project. And you can actually go and just change the project start date, and then all the timing on all those prospect cases automatically shift whenever you change that one single date. But that setup, that all the links between that project and all those prospect cases are a scenario qualified data. You switch scenario and you can have different, and that's on purpose, because maybe one scenario is your drilling scenario, or maybe one scenario is the same drilling setup but just different timings. And you want to have a sensitivity about, what if I shift my drill schedule 6 months and I want to compare that to not shifting it 6 months? You could copy that scenario that you built the original schedule in, do the shift, and then compare them on reports easily and see, what that difference in values might be. And it might be significant given your obligations. There's a presentation tomorrow that talks a little bit about how this might surprise you. So, this is something that can come up, and that's why I wanted to have this session. Another thing that can be qualified by scenario is just like the partner. The partners could have a case selection. Scenarios have case selection. You load a scenario, and suddenly you might not be looking at all the cases in that database. You might only be looking at the cases that the royalty scenario actually has in it, or that the working interest scenario actually has in it. Or like, again, the partner example, like 3 people own a company, maybe they don't own everything of that company. When you load that partner scenario, you'd only see the cases that they have in it. This trips people up that come from other systems, because in other systems, like the RAM system, all the cases are in all the scenarios. And so that is something that we inherited from the partner concept in version 2 and kind of blends together different concepts there. So the last thing that comes up is, again, we talked about how the as of date in version 2 got split into 3 dates. There is the report date, the discount date, and the eco start date for the case. Well, the report date and the discount date are blatantly there in the scenario window. You can't miss them. So they're scenario qualified. But the eco start date is also scenario qualified. So any of the eco options, actually, like what can be excluded and that, like what cases are excluded from reports, that's set up at a scenario level. And if you go between scenarios, you might have different economic start dates for your cases between the scenarios. So basically every single part of what was the as of date is now scenario qualified data, one way or the other. So if you're used to the as of date and that concept, just know that all the parts of it that matter are all at the scenario level, not the qualifier level, and no longer at the database level, at what we used to call the project level in version 3. So, that's something that we shifted, we think is an improvement. So here's the actual window for scenarios, and then you can just blatantly see the name, the report date, the period, how long it's running, what the discount date is. So that's 2 of the dates right there. The discount factor, the method, all this. So this is blatantly in the window. But all the settings that are in this window are not everything that's scenario qualified. In fact, if you go to a different tab in the scenario window, it talks about linkages. And in that tab, you can actually link together the different parts of the scenario. And I think that that's why I have a screenshot of it. It shows all the other things that are scenario qualified. Not only the settings in a scenario, but its incremental tree, its recompletion tree, how its group cases are set up. What are the children of each group case? That is scenario qualified data. And so the linkage feature is kind of useful. I will say that it's kind of limited too. So what it allows you to do is link 2 scenarios together. And then if you link them together, they can have the same settings or incremental trees or recompletion cases or group cases. Problem is that you can only link scenarios with the exact same cases in them, which quite frankly doesn't happen a lot. Like our situation earlier, the royalty interest partner versus the working interest partner, that 2 sides of the company, maybe they're going to have different cases in them, in which case you cannot link their recompletion trees together. So how do you get around that? Again, I've got tips at the end. I'm going to have really important tips at the end. But I just want to kind of talk through this before we get into the tips, because I think that this window does a really good job of showing, what is this extra scenario qualified data. And then last line is the database qualified data. Everything else that I've not talked about that's qualified at the qualifier level or at the scenario level is at the database level. So the names of the cases and the ID codes that the values of the ID codes and what the ID codes are, the historical production, the templates on the graphs, and what the graph setup, the case memos, the conventions that you're using on the cases, the settings of the cases, user settings such as what view you're looking at in that database, all that's saved at the database level. Now, in version 3, nothing is tied to the local machine. There are some things that are what's called instance level data, such as your personal preferences and your favorite graphs and all that. But for the most part, like as far as what can change the numbers, which is what really matters in this industry, right? Like what can change the value of a lease, none of that data is is beyond the database level. So if you send someone a PHD3 file, they will be able to reproduce your numbers to the dime. There's nothing that can change the calculation that doesn't go into the PHD3 file. So that's really comfortable. Not even the BOE. We stuck that in the PHD3 file this time around. So everything's in the PHD3 file. So you send someone a PHD3 file, they get everything. So that's how you can then have a database qualifier. And I do have this one client where they still have multiple databases. So if you're working through this with me, I talked earlier about situations where in version 2, clients would have multiple databases because maybe they wanted to compare 2 different expense setups that would require 2 different databases, right? Or maybe they just wanted to have it set up where, one database had a different set of hard-coded prices than another one that would require 2 different databases. In this version 3 era, you could just use qualifiers and then stack that in scenarios to vary between these 2 different sets of data, right? Between this expense, that one, this price, that one. But in version 3, as you can see, some things are still database qualified. One of them is historical production. So I was talking to a client, they want to be able to do a look back. They want to have it set up so that at the end of the year, they can have something that they can go back into years from then. And then when they go back into it, they can run that year's reports with that year's historical production, that year's case names, nothing else changed. Well, historical production changes. As you update the historical production in a database, it's updated for all scenarios, all qualifiers. And so the only way that they can do that is they at the end of the year, they create a PHZ file, that's final year, PHZ3. They transfer it out and then transfer it back into their program and rename it when they transfer it back in 2023 final. And then they know that that's their final database that they go back into if they want to do a look back and have a perfect snapshot of all this type of data at that point in time. So I'm not saying you can completely get away with having multiple databases. You still might need to do that, especially for lookbacks. But that whole thing where my gosh, clients were doing crazy things like building models to have like different hard-coded expense data in there, and they had like hundreds of models just so they could archive off expenses. Doesn't need to happen anymore, right? Or 2 different databases to go between expense setups. You don't have to do that anymore. Now you can just have 2 different scenarios, 2 different qualifiers within those scenarios, and you're off to the races. Hopefully this is coming together. Hopefully I've enlightened you some. I know I talk fast. Everyone always says every time I do these presentations, I talk fast. I got a lot of data to get through. There's a lot to talk about here. So I'm trying to get it done within a reasonable amount of time. But if you signed up for PHDwin Week, you registered on our website, you'll be able to have access to replays after each of these sessions are over. We'll be notifying everyone when the replays are available. And then you can come back and you can watch this again, and you can watch it until it makes sense. You slow it down if you have to, because this is really critical. What is qualified at what level allows you, once you know that, allows you to be a really effective user of both versions of PHDwin. And especially if you're someone that's going to be responsible moving from version 2 to version 3, knowing how that data is structured and set up is going to make you really successful moving into that era. So this is a screenshot actually of the merge window in version 3. And I think it does a great job of breaking down what these different levels of qualified data are. So I just want to run through it real quick. So whenever you merge together in version 3, in version 2 you are merging projects together, cases basically. You take cases from this project and you merge them into this project. In version 3, we're merging over a scenario. So as we talked about earlier, scenarios can have case selection in them, so you're pulling those cases over, but they can also have the scenario settings and the groups of qualifiers. All those things I talked about as scenario qualified data can then come over in a merge. This really lays it out though. So first of all, what do you want to bring over? Notice that in the merge function, you can really fine tune what you want to merge in. It has a lot of customizability. I'm pretty sure we spent more time on the merge function than almost any other part of the program. It's very difficult to do, but we're really proud of the version 3 merge. What can you merge in? Well, first of all, you can merge in the unqualified case data, AKA everything that's just database qualified. So anything that says unqualified is qualified. It's just qualified at a database level. So you want to bring over, the historical production, the daily production, the graph notes, the case memos, the ID codes, you keep those boxes checked. But that's database level, okay? Next up is the qualified case data. So as we said, both are, this is just the labeling here, right? So first of all, we have the actual qualifiers that are in the system that we showed earlier. The projections, the ownership, the investments, the prices, the expenses, and the shrinkage. Eventually taxes will be added to that list. But also notice that you can merge over eco options, fiscal modeling. So that's right now, taxes, fiscal models are at the scenario level. Eventually they'll move up to the qualifier level, but right now they're at the scenario level. The incremental links, the recompletion links in the group case settings. Those 5 things at the bottom are all scenario qualified. The 6 things above that are all qualifier qualified. All the things at the top that say unqualified are everything that's database qualified. So I think this window does a really good job of breaking this down. And, maybe you want to play with the merge function some. If you're having trouble understanding this concept, go get 2 play databases. Go play with the merge function some, and that'll give you a better understanding of what's happening with this different data in PHDwin version 3. All right, let's go ahead and pivot a little bit and talk about an extra feature in version 3 that, version 2 couldn't do at all. So in version 2, as I said, you were either on an active archive or you weren't. You could either edit the forecast because that was the active archive, or you couldn't. You could see other forecasts on the graph. You could see those other archives on the graph, but if they were not the active archive, you could not edit them. Okay, you couldn't do anything with them until you made them the active archive. In version 3, we have something new. It's called a hierarchy. And what it allows you to do is to pass through data from these qualifiers. So that way you can do more than just what in this version of the program is called the primary qualifier. And so look at my screen here. In my screen, I have for prices 2 different qualifiers, NYMEX and default. So I'm assuming that the NYMEX one has a NYMEX price saved to it. Maybe it doesn't. Until I actually load that qualifier, I don't know what's there. It might just be a label, right? So that's something to take note of. But now look at my projection one down there. So I have 4 qualifiers in there. Q3 24, Q2 24, Q1 24, and default. So this is where we kind of imagine this hierarchy will be most effective. Imagine a situation where there's engineers that are working on reserves, and every quarter, they put forth what the forecasts are for that quarter. And then the next quarter, they import the production data and they kind of start over. They don't start over, they use the existing forecast, but they change it, they tweak it, and it's changing over time. Well, what if you want to go back to an old forecast, last quarters or 2 quarters ago? That's where the archive function came in version 2. You'd archive it off every quarter, and then you could go back to it. Well, think about that start of the new quarter, though. Let's say we started in Q3 24. What am I saving in Q3 24? In version 2, you just have to basically copy, with a global editor, the last archive to the newest one you built, or otherwise it would be blank. You just have no forecast in there. You'd have to start from scratch, which most people don't want, right? It wouldn't allow for an iterative process very easily. It was just kind of grab from here and shove over there and move forward. In version 3, we have something with this hierarchy that allows there to be a real iterative process. So what you do is you build the new qualifier, Q324, and then once you build it, it's blank. There's no data saved to it. It's completely blank. But then as you start to go through the individual cases, and as you start to change the forecast on the individual cases, every single case that you change and that you update a forecast on and then save that will save to Q324. But you'll see a forecast there. Even though Q324 is blank, why? Because of the hierarchy. It will pass through what we call the effective qualifier. So until you actually make an edit on that case, the effective qualifier is Q224. That's the last time maybe you updated the forecast for that particular case. So then you load this new qualifier, you go to that case. Until you make a change to the forecast, you're still seeing Q224. The moment that you make a change to that forecast, it saves the change to Q324. So unlike archives where there's no pass through, you're either active or not. It's binary, 0 or 1. This allows the data to blend some. This allows this data to pass through this hierarchy. And maybe for particular cases, maybe you didn't actually change anything in Q224. Maybe you haven't actually edited the forecast on that case since Q124. Well, then that's going to pass all the way to the front. And then the moment that you actually update production and then change that forecast and save it, then it's going to save to Q324. So this hierarchy concept allows you to have an iterative process over time and allows you to easily, make it so that you can change some cases, but not all the cases once you build a new qualifier. Pretty slick. And it can work for more than projections. That's just, for me, the clearest example of why you would want to use the hierarchy. And no, you don't have to. You could just have a single qualifier for each, just the primary qualifier, because the primary is the one that we're saving to. So in the old program, the active was the only one you could edit report out of. In this one, I might be reporting out Q224 if the Q324 is blank for a case. It'll go find that data in the hierarchy, right? Also, whenever you set up a hierarchy like this, then I can see on one graph all of each one of these qualifiers had a different projection saved to it. I can see on one graph Q224 versus Q124 versus Q324. So just like I could see different archives, when this is set up like this, I can see different qualifiers for the projections on the same graph. But you don't have to. You, again, as I showed you, you could just have defaults for everything, but then you can't have an iterative process. Every single time you save, you're replacing what you had previously. So it's up to you. You need to figure out what's the most effective way to use these tools for your organization. Do you just want everything in the default qualifier, in the default scenario, and you just vary everything with a global editor? And if you want to change it back, you just change it back with a global editor? Fine, do it. V3 won't prevent you from doing that. But if you are going to be changing things often and you do want to be able to go back to previous setups, suddenly scenarios and qualifiers become a really useful way to manage this data inside the program. So the hierarchy itself, as I said, it's very useful for incrementing over time. And the idea here is that it's blank. When you first create a qualifier, it's blank. And it's blank until you put it in the primary slot. And then once it's in the primary slot, and then you do something that's related to that qualifier and save it, it saves that qualifier. Now, if I put the Q324 qualifier on projections, and I go change the ownership, it's not saving to that qualifier. It's saving to whatever the ownership primary qualifier is. So be careful about that. Each one of those different buckets, each one of those different categories can have a different qualifier. And they can all share the same name. I could have them all be called 2024, but depending on which one is the primary, that's what I'm saving to. Also, notice you can reorder the hierarchy. So if you want to go in there and make Q224 the top one, you can just go in there and X out the Q324, and then the hierarchy will just shift over. So it makes it easy for you to go in there and change what forecasts you can see on the graph. And then again, an iterative work process as you move forward in the program. And so again, that's the hierarchy. So there's that screenshot again. That's a good example of the hierarchy. Another thing that's new for version 3 that's at the scenario level. So at the scenario level is something called hurdles. So hurdles are the concept that we added in because we had people ask us for years why investments were not counting in an economic limit. And if you're used to, PHDwin, you're used to this kind of program, you probably already know the answer, which is we're calculating the economic limit based upon the OPEX, not the CAPEX. The CAPEX always went in version 2's economic indicators on reports, but there wasn't any calculation being done as far as against the cases. Cases weren't being turned on or off or anything like that based upon the investment values. But people wanted that. And so we added in a new feature called hurdles to account for that. So this is a screenshot of the hurdle window, but let's get into it a little bit. It's called, what we call it is commerciality testing. So there's economic limit calculation. And then after that's done, another calculation on top to do commerciality testing. There is 3 different ways you can set up these hurdles. One is positive discounted cash flow with investments. One is positive non-discounted cash flow with investments. And one is the ROI is greater than blank. And notice that we're doing the ROI as an integer, not a percent. I know some of y'all go back and forth on that. So like 1.2 is 120%. You can do the conversion. I know some of y'all think one way is appropriate than the other, but I'm telling you the way it is, which is we're doing it as integer. So if you do put in like 2, then it needs to be 200% ROI, or that case will be non-commercial. So here's the whole trick. Instead of it being like the whole project's non-commercial, the cases themselves are set up as non-commercial. When you go to those pages, they might be economic, but if you have a hurdle set in and they do not clear that hurdle, then on that individual page for that case, it'll say non-commercial. And again, this is all set at the scenario level. You pick the hurdle at the scenario level, you do the case selection at the scenario level, and then whenever you run the report for that scenario, then you're able to see on the reports which ones are non-commercial. And so, this is a really cool feature. By default, we're only applying hurdles to behind pipe and undeveloped cases. You can change that in the database settings. That's a database setting to change what they apply to. But kind of the whole idea here is that you're drilling new wells. Which ones are going to make you the money back? You're drilling 20 wells. How many of those are actually going to give you that ROI your company's wanting out of that 150%, 1.5 ROI that the company wants? Well, you put in a hurdle, it runs the economics for the wells, and then goes back and then applies this commerciality test. And then out of those 20, maybe 2 of them aren't commercial. Maybe 2 of them don't get above that threshold. When you look at those cases reports, then you're able to see non-commercial. So that makes it really easy. I mean, the old days, you just have to go and look at the report for each case and then manually compare them to the standard. You were doing that extra round. You were doing the commerciality test manually. Now the program will do it for you if you build in a hurdle. So it's a cool feature, but again, if you don't want to use it, you don't have to. Just leave that tab blank in the scenario setup window. So let's take a breath. I've now explained to you how data is qualified in version 2 and version 3. I've talked about how the data converts over. Now let's talk about what to watch for in each version of the program. So version 2 people, come back. Let's talk about how we can make you more effective in each version of the program and kind of where some of the got-yous are with this different qualified data. So first of all, in general, for both versions of the program, use date-based names whenever possible. So notice that I would call my qualifier Q124, Q224, Q324. That is so much more effective than like your company's initials. Because what happens, you come back in a quarter and you do that again. Which one's the new one? I don't know, right? So whenever you're in either version of the program and you're building archives, you're building qualifiers, maybe even when you're building scenarios, put in the year, put in the quarter, make it date specific. So then whenever you go back to it months from now, you can remember, oh, okay, that's that qualifier for that quarter. And so that way it's easy to unwind. Or if you send the file to someone else, they can figure it out. I can't tell you how many times I've opened up files and they just use like the company abbreviations all over the place with no dates. And it's like, how old is this one? My gosh, that projection might be from 2021. Is it still valid today? Should I just start over? I don't know because they didn't put a date on it. So put dates on all of your names. Next up, leave notes if possible. So there's case notes and memos in both versions of the program. There's project and scenario notes in both versions of the program. If you're going to do tricky things, just put those in those different note and memo fields. And then that way, whoever gets that database from you next, gets that PhD from you next, they can go in there and they can see, oh, okay, this person applied this shrinkage qualifier for this reason. This person has 2 different tax qualifiers for this reason. This person in version 2 named their archive this for that reason. Please, please, please use notes when possible, and then use dates when possible. It'll make it so much easier for the next person in line. Now, specifically in version 2, here's some things to watch for. First of all, I talked about it earlier. Each product tree can be saved to a different archive. A lot of people don't realize that. So not only are product trees case specific, but they're archive specific. So let's say you have 4 archives in a project. Well, that means each case can have 4 different product configurations. You have 400 cases, you have 1,600 product configurations. That gets insane to manage. And I've seen it before where basically engineers change over time, right? Like, oh, I'll import a file from 2 to 3. And as I said, whenever you import a file from 2 to 3, it takes all the old product trees, even the ones in the old archives, and it rolls them all up and sticks them at the database level. And there's been a couple times I've been like, hey, it built this product configuration over here when I imported the file. Where did this come from? Why was it set up this way? Oh, that was Bob, but Bob hadn't been at the company in about 5 years, and so... is that useful? No. It gets really difficult. I personally think you should not be carrying archives longer than necessary. I know some clients that go archives back like 10 years. My understanding, even publicly traded companies, you only need 5. Don't listen to me on that. Use your internal standards. But my gosh, prune archives, first of all. And second of all, just know that as you go between archives, you can literally change product configuration. And I've seen people get tripped up by that. They had one archive that didn't add MGLs, another one that did. They thought all of them did because they added it to one. And then by changing their forecast, that's all they thought they were doing, they were actually blowing NGLs away or bringing it back or changing how it was configured fundamentally. And then they're sitting there playing on the graph all day, not knowing underneath the hood, they basically changed the way that the engine runs. Very difficult to manage, so make sure you pay attention. And that's why we tried to move away from that in version 3. But in version 2, it's up to you to manage, so be careful with that. Make sure every time you load an archive, you go and you look, how are those products set up in that archive? What is the phase configuration? You can actually have one archive where all the products are independently projected versus one where the phases and the products are tied together. And then by switching archives for the same case, you're fundamentally changing how those things can be projected. You'd think it would be easy to catch, but look, you got different people work on these projects over time, work on these databases over time. Things get lost over time. And so just make sure you're managing that. Another thing to note is that on the partner side, partners might not use the full feature. Some partners might copy investments. Some might not touch investments. Some might not have any investments. Some partners might only vary the investments. That's why they built the partner, was to have 2 different investment setups, maybe like, worst case investments versus best case or something, and they want the ownership on all the cases to be the same. Be careful of that. Or just know partners exist. I can't tell you how many times I've sat down and I've been doing a demo with someone, because again, sales is my main job. Someone sends me a file and they're like, I'm thinking about getting PHDwin, and I did your trial, but I can't find any of their ownership information in this file that they sent me. And I'm like, hold on a second. I go load the partner and boom, there it all is. And I've seen people go, yeah, this file's great. I'm getting 50 million. And then I go load the actual interest and they're like, oh, I guess it's getting 5 million. Because it's only 10% working interest or something like that, right? And so be careful. No partners exist. Make sure you know how to load them. Last piece of advice for version 2, don't touch the all cases main partner. So I was the project manager for 2.11, and I tried to get this fixed, but it would have affected a lot of other things. So I couldn't get this done. So I'm going to tell you right now, you can edit the name of the all cases main partner in version 2. Do not do it. I see y'all do it. You only have one partner, which is all cases main. So you're like, I'll just rename that the company name, because that's all it is, right? The company, because it's always at the top of the report. So you just want your company name at the top of the report. The problem is you rename all cases main and you merge together data sets. You can actually dump this qualified data. It can screw up a merge between 2 different files in version 2. So if you want a partner that is basically the all cases main, that's your company name, just copy all cases main. Don't rename all cases main. I say don't touch it here. You can just use it if you want. You can save, you don't need multiple partners. You can just save everything to all cases main, all your investments, all your ownership, and you're fine. But do not rename that thing, or you will probably eventually lose your ownership or investment data whenever you do a merge or a pack or some other function in the program. You right now, there's some of y'all watching this, I know it. Y'all renamed all cases main, your V2 file. Please go change it right now. Like, pause the stream, go change it, come back. Because that is a critical problem in that program, that version of the program, if you've renamed all cases main. Be careful with that. All right, version 3, what to watch for. So as we talked about earlier, there's a lot of data that's qualified at the scenario level that's not intuitive. Things like the eco start or the case linkages. For that reason, don't start new scenarios from scratch. In the scenario window, there's a plus button to start scenarios from scratch. And then there's a copy button if you right click on any scenario, you can right click and then there'll be a copy button to copy an existing scenario. Always copy existing scenarios unless you have a really, really good reason not to. What would be a good reason? Maybe the two scenarios have completely different sets of cases in them. Maybe one scenario, like we have clients that, they'll have like different regions of the world they're working in. And one scenario is their US cases versus one scenario is all the stuff in Angola, right? And they don't overlap at all. In which case they can start over in Angola, okay? But you're just domestic US, and you're just, you have basically the same cases in multiple scenarios, but you want to change the prices or the forecast or something else, don't start from scratch. Copy the scenarios that are there. So you copy all of those scenario settings that aren't intuitive, like your recompletion tree, your incremental tree. Otherwise, you start over with those and it can fundamentally change economics. Well, right now, in the current version of 3, you don't copy scenarios, you start from scratch, you just blew away your taxes. You just started over, your taxes are zero until you go globally apply new ones. Avoid that. Copy the scenario in place, right click, copy scenario. That's what you need to do. And next up, note that a primary qualifier might be blank. So we talked about that earlier where there's this hierarchy and they're passing through the data in the hierarchy. So just because it is the primary qualifier does not mean that it actually has data tied to it. There's 2 ways to figure that out. First of all, there's a report called the scenario report. Garrett talks about it in his session. Garrett Hoover had a whole session earlier in the week about reporting, and he talked about this report. It was actually requested in our user group meeting earlier this year to add in this report. And in it, it tells you exactly what qualifiers are completely blank. So that's useful. But another way that I think is very useful is in the sorts themselves, there's this whole section called effective qualifier. Let me show you. So in the sorts, so right here in the sorts, notice on the left here, there's the eco options, economic inputs, economic outputs, and so forth. There is the effective qualifier sorts. You drag those over, and then in the case list, if, for example, in my hierarchy example earlier, maybe the forecast data is saved in the 2Q, the second quarter, 23 qualifier, not the third one, because I haven't actually done anything in that one for that case, then in the case list, it'll show you 2Q 23 for that projection qualifier, because that's the effective one. That's the one outputting on reports. So use these sorts to make sense of your data if you have a hierarchy of qualified data. So that's a nice little trick. That's something a lot of people don't know about that's in that version, in the new version of the program. Last little note I want to make on version 3 is in the global editor itself, there's all these global edits that allow you to copy qualifiers and copy effective qualifiers. So if you don't like this hierarchy thing, and I get it, a lot of you all that are used to the version 2 and it's either active or it's not, maybe you don't want the complexity of this whole hierarchy. Maybe you do not want to have to find out what the effective qualifier is and know where that data is being stored at that moment in time. We have a global edit. I'm gonna have it open for ownership, but for almost any one of these things that's qualified data, the investments, the forecasts themselves, there is copy qualifier where you can just copy the data from one to another. Very useful if you need to make a new qualifier that's a perfect copy of an existing one for that data, or copy effective qualifier. Then if you have a hierarchy and you don't want to undo it, you don't want to figure out where data is stored in that hierarchy, someone just sends you that file, build a new qualifier, put it in the primary, use this copy effective qualifier, and it'll just copy. It'll figure out where the data is stored in that hierarchy, and it'll just copy it to whatever one you pick. And then you run in kind of V2 mode with archives, where it's either on or off, binary, 1 or 0. So if you would prefer to live that way, that's why we added those global editor edits in, and that can kind of simplify things for you and make your life easier. Now, this might be a lot. So first, I want to say thank you very much for riding along with me. But also I want to say, if you have questions about this, please reach out to us. On the stream, if you're watching on our website, there's the form to ask questions. Ask me questions. I'll be on the Q&A session later today. I'll be happy to answer those questions. Or call in our support staff. That's part of the reason why we try to make sure we have really good support and maintenance included with our program. And so many of y'all, pay for those services every year. Get the support team to help you figure this out for your data set. Help them, maybe you want to import a V2 file, and then, if there's any issues, send them over that PhD so they can help you unwind it. Reach out to us, and we'll be happy to help you get a better understanding of what's happening with your data. But for now, thank you very much for your time. I hope you enjoy the rest of your PhDwin week. All right.
I apologize, Zach. I ran a little long, but I'll go ahead and turn it over to you. Everyone, now time up for the next session. Zach Warren. I appreciate y'all's patience, and thank you, Zach. Sorry I ran a little long.
Thank you for joining us for PhDwin Week 2024. Next up, we are featuring Zach Warren from Velocity Insight. After a successful career in reservoir engineering within the oil and gas sector, Zach shifted gears to focus on data analytics. He founded Velocity Insight with the mission of simplifying decision-making using cutting-edge data techniques. With experience ranging from industry giants to niche firms, Zach has honed his skills in crafting data-driven solutions that boost workflows and deliver rapid business insights. He previously led an analytics team at an E&P company where he focused on improving operational efficiency and providing strategic decision-making support. Please welcome Zach Warren, who will present Clean Your Kitchens, Not Your Basements, Data Quality and Reducing Corporate Strife.
Welcome, I'm Zach Warren with Velocity Insight, and this is my presentation for PhDwin Week 2024. Thanks so much for the invitation. I hope this is an interesting presentation for the audience. I'm what I would call a recovering reservoir engineer. I spent many years as a practicing reservoir engineer at E&P companies, but now I run a data analytics consulting firm. So my perspective, I hope, is useful. Somebody who goes really, really deep into data for a living now, but has a background trying to get quarterly reserve reports out the door and trying to finish the engineering underwriting for the latest acquisition. So I hope you enjoy this presentation. If not, please don't tell me. I don't want to know. So here's the title of the talk: Clean Your Kitchens, Not Your Basements. Data Quality and Reducing Corporate Strife. Trying to find some ways that data quality could make people's lives a little bit better. It's kind of a crazy idea, but I think it's worthwhile. Some hard objectives here. We're going to give some concrete ideas about improving oil and gas data quality. These are things that I've used in my career, both as a practicing engineer and then now doing data analytics for a living. Second, advice on what not to work on. I think it's easy to say, well, we need to work on everything. There's a bunch of stuff that you should not work on. And very often, I think that advice is more useful than what to work on. So we'll talk about what you should not waste your time on. And then finally, help justify investing in data quality to your boss. I think those of us that are down in the weeds, getting the work done, have an intuitive understanding that data quality is going to make our lives better. It's going to make it easier for us to get home by 5 o'clock so that we can go to the Little League game or whatever. But it can often be difficult to explain that up the food chain. So hopefully we've got some ways of thinking about that that are going to be useful to you. So outline of the talk: return on investment for data quality. Where should we look for it? How do we know it when we see it? Second, this clean your kitchens, not your basements concept. Our countertops matter. That dusty old closet in the basement does not. And how do we take that metaphor, push it to its absolute limit, and hopefully find a way for it to be useful in your work? Next, I wrote this really nerdy blog post about how API numbers make the worst corporate well IDs, and you should not use them as corporate well IDs. The folks at PHDwin read it and enjoyed it, and I think that's why they asked me to give this talk. So we'll dig into why that is, and then also talk about some ways in which I think API numbers are very useful. And then finally, how to get sort of 80% of the value of a big data quality effort for a fraction of the cost. There's no reason to spend months and millions of dollars cleaning up your data, because if you focus on the right things, you should be able to make a lot of progress pretty quickly. Why do we care about data quality anyways? This data pyramid is a graphic that I find really useful, thinking about how you've got a huge amount of work that needs to be done around data gathering, right? Getting data from the field or from vendors or from your partners into some kind of system. Once it's there, I need to do cleaning and straightening. I need to make sure it's delivered to the right people at the right time. That bottom stuff on the pyramid is a huge amount of work. And that's the foundation for the stuff that comes above it. So descriptive analytics, like how much did I spend last month or how much did I produce yesterday, those kinds of analytics I think are often shockingly difficult to produce at most companies, but are extremely valuable. And then at the top, the more predictive things like AI and machine learning, they often don't require a huge amount of effort if I've done the stuff on the bottom successfully. So today we're going to talk about the boring stuff on the bottom. Our focus here is data gathering, data management, putting ourselves in a position where we can make good decisions higher up on the pyramid down the road. I really like this book by a guy named Tony Fisher called The Data Asset. It's out of print now, but you can find it on the Amazon or the web or whatever. But he talks about 3 value propositions to data quality. And if you don't know which of these 3 you're aiming for on a data quality project, you need to stop and ask, right? Pause, figure out what the heck it is you're doing. But those 3 propositions, those 3 value drivers are increasing revenue, decreasing costs, or reducing risk. Those are the 3. If you're not doing one of those 3, then why are you here? You know, we think about increasing revenue. Well, I could increase production. I can't really change the price that I'm going to get for my barrels. Decreasing costs, that's often something that we do have a lot of control in. Can I, drop that compressor that I don't need anymore? Can I, optimize my chemical program to spend less money? Reducing risk, things like reducing the chances that I have a sidetrack or a dry hole or that I have a safety incident out in the field. Those are the 3 drivers that we need to be focusing on for oil and gas data projects. And in particular, I really like to focus on the last 2. Again, increasing revenue, there are a few knobs that you can turn, but they're often very difficult to turn, or you simply don't have control over the inputs. But decreasing costs and reducing risk, those are often pretty useful places to spend your time and energy. Clean your kitchens, not your basements. In my house, our kitchen countertops are a high traffic zone. The groceries get dumped there when we come in. There's mail there. My kids do homework on that surface. I'm, prepping dinner or what have you. That's a place that a lot of people are using all day, every day. Our basement is not the same way. We live in Denver, so we actually have basements. I apologize to those of you in Texas who do not. A basement is a lovely thing. It's a wonderful thing, but it's not a great place to worry about how clean things are. So what do we mean by the kitchens in an oil and gas company, the high value targets that are worth your time? It needs to be manageable volumes, right? So you don't want terabytes and terabytes that need to be cleaned. They need to be the kind of data sets that are frequently getting accessed, not once a year, but once a day or multiple times per day, and hopefully by a diverse range of consumers. Not just the drilling tech, but accounting and land and reserves and production. The data sets that are accessed by a lot of different people frequently are going to have a whole lot more value if we can get them clean. Far and away, the best example of this is well headers. Good quality well headers at an E&P company make a difference. They make people's lives better. But there's others that go on this list too, like the list of vendors. Do you have a consistent understanding of who your vendors are, from your accounting system over to your daily well lifecycle system, like WellView or Open Wells or what have you? Daily and monthly production volumes. Lots of people care about what those numbers are. The drilling and completion reports for that well that got drilled last week. There's a lot of people in an oil and gas company that care about what that data looks like. And so it's much more likely to be worth spending your time to focus on data quality. What are the basements? Those are high volume, right? The really big data sets that are infrequently accessed by a small number of people. So drilling completion reports from a play concept that you were drilling 10 years ago, don't care about those. Invoices and field tickets that are no longer in scope for an audit period. I don't care about those. This might even include some of your well header data. Maybe you have 20 columns of well header data and there's only 5 or 10 that people actually care about. Don't spend too much time on the other ones, right? Just focus your time and attention on the things that matter. We've got a closet in our basement that holds Christmas decorations. And on 2 and no more days per year, I go into that closet first to haul all of the crap out of there to set up the tree and the outdoor lights and all that stuff. And then a couple months later hopefully not a couple months later, a month later, to jam it all back in there after the season's over. Nobody else goes into that closet. Nobody else touches those things. I'm the only one who does it. I don't care if they look that nice. As long as I can find my wife's favorite, stockings, it doesn't matter. Don't spend a lot of time cleaning those basement closets that don't matter. So for both corporate and I would say maybe marital happiness, focus on those high traffic, high visibility data sets that have a lot of consumers and ignore the other stuff. I say this kind of to provoke conversation, but if all of your data is clean at an oil and gas company, you have wasted time. You have wasted money. There is no reason to clean everything. You have got to be thoughtful about where you prioritize your time, focus your energy, and be sure to clean the things that actually matter to you. Next, why API numbers make truly, truly terrible well IDs. I will start with my favorite API number joke, which means that I have more than one. If you don't like this joke, I'm sorry, but I could have told you an even worse one. So API 10 and API 14 run into each other on the 16th Street Mall. Again, I live in Denver. After catching up for a little bit, API 14 steps back and says, "My goodness, API 10, that output is really dashing on you." Yeah, get it? You get it? It's not that good of a joke, I'm sorry, but it's the best that I have. So API numbers are really frustrating. There's 3 big reasons: formatting, inconsistent availability, and shifting meanings by discipline. What I mean by an API number may not be the thing that another discipline cares about. So formatting issues are a big problem. Computers are real smart, but also they're real dumb. And if I don't have consistent formatting in my API numbers, then lookups and SQL joins and all that kind of stuff are not going to go well. Do I have a text or a number data type? Do I have 10 or 14 digits, dashes, leading zeros at the beginning of the alphabet? All these kinds of things just drive me crazy. These are a few examples of what I have seen API numbers look like, and I'm sure a lot of you are shaking your head in pain and trembling and fear. This is really my favorite, is when Excel interprets an API number as something that needs commas and trailing zeros, or scientific notation, 4.2 e to the 13th. This kind of stuff is a real problem. You can deal with it with really, really good, SQL programming and all that kind of stuff, but it's a big problem, and not all systems do a great job of enforcing consistent formats. Even inside of a system, often I'll see 2 or 3 variations on dash or no dash, with or without, the trailing 4. These are big problems for the actual use of API number at an E&P company. Availability is also a problem. Pam Kosinski, I cannot recommend highly enough her blog series. It's on the Well Database website, where she talks about a lot of these issues of pre-1967 wells that simply don't have one. The IHS data set has some UWIs for those, but those are proprietary. You may or may not have rights to use them. There's laggard states that didn't adopt the API standard until pretty late. There's weird states. Alaska does some crazy stuff. Oklahoma slaps a letter on API numbers. And then there's the famous Kern County debacle, famous to a very small list of people. But Kern County has over 100,000 wells. So they ran out of 5-digit well identifiers. And they had to add a second county code that is also Kern County. So just a lot of problems with availability and consistency from state to state, jurisdiction to jurisdiction, depending on what you're looking at. And then finally, inconsistent meaning. This is sort of taking that hierarchy of API 10, 12, 14, and thinking about what that means in different departments. In my experience, most reserves and reservoir engineers focus primarily on API 10, But sometimes you might have different working interests and revenue interests between an upper zone and a lower zone, between the the Sprayberry and the Wolfcamp, or the Nio Codell versus the J and D sands in the DJ Basin. And you need to be able to capture that below the API 10 level. Sometimes you want to aggregate a whole bunch of wells together because it's a water flood or an offshore platform, and do my forecasting at a higher level. And then as you move across to other disciplines, they have dramatically different ideas about what counts as a well. Daily well lifecycle systems are largely API 10 based, but they also have tables in them to handle data down at a 12 or 14 level, sometimes even sub 14 if I've got a multi-stage fracked well. There's data being recorded at a lot of different levels in these different systems, and I don't always have a good way to tie across on just API 10 or just API 14. APIs are really useful though, just usually not as a corporate well ID. The vast majority of public state data really leans on API numbers, and if you're looking at modern wells on something like Frac Focus, API 10 is going to get you really far. If you have sub API 10 data, oftentimes aggregating up to the API 10 level will make your life a lot better. Your wellheader data is going to be cleaner and easier to understand. There's just a lot of benefits. If I've got production data at API 14, aggregating that up to API 10 is going to make things better. Intercompany data exchange is an area that I think API numbers are useful now and should be used even more. If I'm receiving data from a frac vendor or wireline logging company, I want to make sure that they've got an API number on there. That really helps me be confident that the data they sent me is attached to the well that I expected it to be. If I'm an operator and I'm sending data to a non-op or royalty interest partner, if I include the API number on it, I'm going to get fewer questions back. That conversation is going to go better if I'm including APIs. And it's also really useful for building your corporate well ID. So even if I don't want to use corporate well ID in the long run, if I'm just trying to figure out how systems match, starting with API number is a way to start to build those relationships is, I think, usually the best place to start. It's a heck of a lot better than well name, in my opinion, but yeah, API 10 is a great way to sort of begin that conversation between departments about what corporate well IDs should be. Next, MDM, what I consider the shortest four-letter word in data. Get it? Because it's only 3 letters long, so it's short. You get it. MDM stands for Master Data Management, and it's the IT terminology for how I get my well list to match. And we did a project a couple of years ago for an operator doing some research into this area. We got a lot of negative feedback. I love this line. We built our own MDM system in-house, but the guy left, and so now it broke and it doesn't work anymore. Overall, you saw a lot of movement towards these big, robust systems in the 2000s, and I'd say up until the oil price crash in 2014. And then with all the layoffs and mergers and consolidation, a lot of those things just took our eye off of that ball. We refocused on other problems like, minus $37 oil or what have you. And then over the last few years, I've seen a renewal of interest in how do I get my well list to match and things like that. It's kind of where we are in the maturity timeline right now. The major MDM tools don't do a great job of solving oil and gas problems. They were built for Walmart or Target or whomever to match up millions of customers to each other. So they have all these tools like fuzzy matching on names, like Zach versus Zachary and Junior versus the second. All those kinds of things are handled really well in those systems. But oil and gas MDM problems aren't the same. We're not working with millions or hundreds of millions of customers. We're working with maybe a few thousand wells. The hierarchy is really complex in oil and gas data sets. And then we have a lot, it's not just wells that matter for master data management. We have a lot of other things that might need to get mastered as well. I drew this ridiculous diagram talking about API 10, 12, 14, sub 14. You're all familiar with these. Those are probably related to a fenced area or a pad or a battery. These are some of the other business objects in a company that might matter, that somebody might care about. There's a lot of land and legal concepts like leases and DSUs, site permits, drilling permits that could be attached at any of several levels of that API hierarchy. And then we've got physical things like downhole equipment and frac jobs and recompletions. And then there's accounting concepts like invoices and field tickets. And clearly I got tired of doing this slide, and so I stopped building arrows. But there's so many business objects at an oil and gas company that are potentially useful to keep track of and make sure that they're consistent across companies. So I would propose that most oil and gas companies actually do something called MDM Lite. This is a very common alternative to like Informatica or some of those big systems. And instead of a big fancy piece of software, we just declare one system, one discipline to be the owner of the well list. And then all of the other systems are supposed to match to them. Or if you don't like what was in the well list owner system, you go convince them to make a change. Pair this up with some data quality dashboards and you can get good visibility into mismatches. Far and away, I see that reserves is the most common owner of this process. And that's why I'm talking about this here to this audience. You can do this with an accounting system or even a spreadsheet, God forbid, but this is a good approach. I will say, if you do decide to use this approach at your company, I insist that it be spelled L-I-T-E, like Spam Light and those godforsaken devil's food cookies that my mom used to buy. So this is traditional MDM on the left. You've got a master data management data warehouse in the middle, and then there's two directional communication to SCADA, to daily well lifecycle, the ERP, which is the accounting system, etc. And building those blending and source of truth rules, that's really expensive. And in particular, it's hard to maintain. Even once you've done it once, you've got to keep it running, and that's a real pain in the neck. I generally find that people don't do a great job of that. What I would propose for sort of this MDM-like concept is instead you declare one system to be the truth. In this model, it's reserves, and I think there's good reasons why it should be reserves. But reserves then makes their data set available to everybody else. Everybody else should be able to see what API number I have, what cost center I have, what field I've assigned it to, state, county, lat long, all that kind of stuff. Reserves ends up acting as that golden record, the source of truth, visible by all of the other disciplines. And then if somebody in one of those other disciplines sees something in the reserves data set that they don't like, their job is to pick up the dang phone and give them a call, right? Walk down the hall, have a conversation, and say, hey, I think the well name should be this. Why do you have that? And try to find a way to come to an agreement. I believe this is how most, in particular, small and mid-sized oil and gas companies operate. Large caps, I think there's a little more logic behind using a big fancy MDM system. But if you're a small company and you're a reserves engineer that's spending a lot of time making sure that his well list is clean and accurate, let other people see it. Give them a chance to consume that data so that they don't do the exact same cleanup work you just did, that they can benefit from all of the effort necessary to reconcile PUDs and have a clean set of PDPs and keep track of your P&A wells. Just do that once and let everybody else leverage the work that's been done. All right, a path forward. MDM Lite, I guess, is kind of a path forward. But in particular, here are some approaches that I've seen be really successful at a lot of our clients and for me earlier in my career. Let's start with reserves QC. In my experience, reserves is always coming up to the last minute. We're making a few changes. We got feedback from our auditors. Time's getting short, right? I need to get that final reserves run out the door. How do I do a QC of that as quickly and efficiently as possible? Very often, I think a great solution for that is to use a business intelligence tool like Spotfire, Power BI, or what have you, to look for violations of business rules, right? I don't want my well lives to be too long. I don't want to violate the 5-year PUD limit, other kinds of business rules that we could all spend time on a whiteboard and come up with 100 of them. So what we've done here, this is a Power BI dashboard, but you could do it in whatever your preferred technology is, where I've seen, hey, I've got a well that was drilled more than 5 years after the PUD add date. And I can go look over at that raw data. In this case, it looks like it was probably just a typo, but to surface that kind of information really quickly, especially if I'm doing something like running a lot of drilling rig sensitivities, how do I know quickly and efficiently which wells went in and out of the 5-year window? Similarly, I want to look at the ratio between NRI and working interest and sort of understand if I have any big outliers. This is a Bakken data set. Generally, Bakken's going to sit around a 0.8 NRI to working interest ratio. I can just cross plot those and pretty quickly look for any outliers and maybe drill a little bit deeper and then go call the land department and say, hey, why is this well at only a 0.7 instead of a 0.8? To give yourself the ability to see that stuff really quickly. It might be typos, it might be real. We just need to get to the bottom of that as efficiently as possible because the bid sheet is due at 5 o'clock, or I've got to send the reserves database to the auditor by, the first of business tomorrow morning. That kind of time pressure paired up with data quality tools like this makes your reserves and BD processes go better. Second example is well as QC. We talked a lot about API numbers and how much I hate them. This is actually an example of using API numbers to match across systems, which I did my best to persuade them not to. But this is real data from a client where you can see the list of wells in the reserve systems that maybe don't match to production or the other way. And the goal here is that all of these numbers should be 0, right? All of my reserves wells do match to the cost center on accounting, right? All of my reserves wells do have a cost center loaded. However, my accounting system has 25 wells that don't match over to the reserve system. My production system has 18 sites that don't match over to reserves. So then, do the thing and make a little button that you can click and get to some more detail to say, hey, here's the list of wells that are in my production system that aren't matching over to the reserve system. In this case, I have anonymized the data. I've hidden the identity of the guilty party. I guarantee you, if you build something like this at your company and you haven't intentionally solved these problems, you will see a shocking number of cases where these systems do not match. Next is tie-out graphs. This is something I have done too many hours of VLOOKUPs and spreadsheets to deal with, but I want to QC my reserve runs up against the accounting actuals. In a lot of cases, you're going to go to the accounting department, request access to a lease operating statement or what have you, and then do a giant VLOOKUP against my reserves run to make sure that my operating expenses, historical was $8 a barrel, my forecast is $8 a barrel, cool, I'm good. My experience is these take a ton of time, but we have access nowadays at most companies to the underlying system. And if you don't have access to the underlying system, you need to pick up the phone and call somebody. But there's probably a SQL server, an Oracle server, a Snowflake instance. There's some way to get your hands on the underlying data. So here I've got actual LOS volumes coming out of an accounting system. And in this case, they're being run through a Power BI report. And then I've got forecasted data coming out of a reserves run. And these two ought to tie out, right? I can look at OpEx, I can look at gross production or net production, I can look at capital expenditures, and compare historical versus actuals. That's the kind of thing that will help me find data quality problems that are the oil and gas equivalent of a kitchen counter. How do I find the stuff that really matters for me to go solve so that I don't spend a bunch of time on something that matters, but I also don't print a reserves report that I end up regretting. So in summary, think about your return on investment before proposing projects. Are you increasing revenue? Are you decreasing costs? Are you reducing the risk, the variability of outcomes? If you're not doing one of those, stop and ask a few more questions. Because a more focused data quality effort is much more likely to make your boss happy, quite honestly. Clean your kitchens. Focus on those high traffic data sets that are used by a whole lot of people and ignore your basements. De-emphasize the data sets that not a lot of people are seeing or they're not using very often. Consider MDM Lite. I think a lot of oil and gas companies are already using that. They just have never named it. And I think giving it a name, creating sort of some documentation and a process around what is expected will really help give it more credibility, give it more support. If you are that reserves engineer, that analyst or technician that is the owner of that well list in reserves, and you're doing a whole bunch of work that other people in other departments are constantly duplicating, boy, go talk to him, right? Talk to him about, hey, would you like to just receive a copy of my lat longs? Would you like to just be able to see all of my interest factors so that you can compare what you have to what I have, and then we can fix it? I think that's a really good way to address those kinds of problems at most companies. Finally, shine a light on data quality. Sunshine is the best disinfectant. A clean view of the data quality problems that you have, whether it's dashboards or whatever your method of seeing that data is, shine a light on it, show people where the data quality problems are, and there's a really good chance that you will find that they clean themselves. I hope this has been an interesting presentation to people. Velocity Insight is a data analytics team for hire. Basically, we work for E&P companies. We're kind of designed to be like what you would see at a large E&P company, but we mostly work for smaller ones. We're big nerds. Hopefully we're pretty fun to work with to help solve these kinds of problems. If you enjoyed this presentation, if you like this kind of thing, we publish what I think is an incredibly niche and incredibly specific newsletter on oil and gas data analytics. Come to our website to subscribe. There's like 1,500 people on that list now, which is really, it makes me feel good. We also run an E&P software survey on an annual basis to measure market share for major oil and gas applications. We publish stuff to LinkedIn, all that kind of thing. Please do reach out. I hope you enjoyed this presentation, and I look forward to all the questions and conversation in the Q&A. If you come to the Q&A and you don't have any questions, then I have questions for you, and would love to hear your feedback on some of these ideas. Thanks so much. Have a great day.
Thank you to Zach Warren for his informative presentation. We have a quick start coming up next. Frankie Delgado will talk about importing non-PHDwin databases into PHDwin v3. Stay tuned to the stream.
Your stream will update soon.
Thank you, Zach, for that excellent presentation. Definitely something near and dear to my heart. I'm very happy to have this presentation now and that we have a copy of it, because I feel like this is one I'm going to be forwarding to clients very often who get caught up in the maze of API numbers and how to glue together their well-in data sets. So thank you very much, Zach. That was very informative. So at 3 p.m. is going to be the next quick start from QED. So you got a little break here. If you want to go grab a coffee or go to the bathroom real quick, go for it. So we will do that quick start at 3 p.m. And then at 3:30, we're going to bring back Zach. We're going to bring back Josh. We're going to bring back Alvaro. We're going to bring back the presenters from today. And we're going to sit down and talk with them about your questions. So do you have any questions for Zach? Do you have any questions for me, Jonathan Smith? Do you have any questions for any presentations that you've seen today? Please just send your questions to events@phdwin.com. And I'll make sure they get asked during that Q&A session at 3:30. We really appreciate everyone for participating in PHDwin Week. And in particular, we really appreciate anyone asking any questions and engaging with us. It really means a lot to know that you're out there and watching and that you're enjoying this content and these presentations. Thank you all very much. We'll be back on with a quick start at 3 p.m. Just a few announcements as we're waiting for the next session. So again, at 3 p.m., we're going to do the quick start session, the next quick start section. Frankie Delgado is going to be showing us in some more amazing QED tricks inside of version 3. We've been having a lot of questions roll in about PE hours. After the conference is complete, we will have a form for everyone to fill out to claim the PE hours, where you just go in there and you'll tell us how many hours you watched, and then we'll be able to get you certificates for those PE hours. We appreciate that is part of the reason why you're here for PHDwin Week, and we'll be sure to take care of you. Also, we're getting a lot of questions about the replays. The replays currently are on our YouTube channel at the end of every day. So there's one monolithic replay of the whole session that's on the YouTube channel at the end of every day on the stream. What we're going to do next week and the following weeks is we're going to take the individual sessions for PHDwin Week, cut them back up, and then upload the individual sessions to our client portal and probably a couple back to YouTube. And so for now, if you want to catch any replays, you can go to our YouTube channel and you can see the whole replay of any previous day, or we'll be sure to email everyone when the individual replays are available in our client portal. Last question that's been coming up is if you have any questions or if you have any issues with PHDwin Week, please sure to email events@phdwin.com and we will reach out to you and we'll help you. One thing that came in through the email, apparently there was some sort of issues with our LinkedIn stream. We found out that there's a limit to how long LinkedIn will let you stream. And so if you're following along on LinkedIn, I recommend for the final day, switch to our website stream, the client portal stream, or the YouTube stream. Everyone seems to be having a lot of success on the YouTube stream. And any comments made on the YouTube stream, we can actually see here and answer alongside in our Q&A sessions. Or again, you can email events@phdwin.com. So 10 more minutes until our final presentation session for today by Frankie Delgado. And then once Frankie is done at 3:30, we are going to get into the Q&A for today's PHDwin Week. I just want to give another thank you to Goyer McNaughton and Zach Warren for some excellent presentations today, and also to QED Energy Associates for their fantastic quick starts. We're really looking forward to getting everyone back on and having that discussion at 3:30 today. And thank you to you for spending your time with us and watching PHDwin Week. We really appreciate it.
Hi, everyone. My name is Frankie Delgado with QED Energy Associates, and I'm going to show you real quick how to do an import into PHDwin v3 of an Aries database. So I have my Aries database in this folder right here, PHDwin v3, and it's in the folder in here called Aries import. The database is titled Project Hello. So that's what I'm going to call my database in v3 as well. So first thing we need to do is go ahead and open up PHDwin v3 and make a new blank database with nothing else in it for us to import the Aries database into. So I've got my PHDwin one right here. I'm going to drop down the database drop down. I see a couple other databases in there, but right now I'm just going to click this Create New Database. And I'm going to name it Project Hello, just to keep it the same. Create. Now, once that creates, there won't be anything in it. It'll just be a blank database. And then I'm just going to toss my Aries database in there. And we should be good to go from there. Okay, here's our blank v3 database. So now I want to import a database into this. So I'm going to go up here to the top left on the home ribbon where it says add/import. I'm going to click on that guy. And when it opens up, I'm just going to go down to the bottom where it says import and click on that. Now that opens up our import window. What we need to do first is find our database, which I already have in my selected right here. But if you don't have it selected already, what you need to do is just check from my computer and then click on these three ellipses to the right and then just browse for it. Mine was on the desktop. I have my v3 folder, Aries import, projecthello.mdb. Click open. And then down here in the options section, we have a few options. First one is ID code to match on ID code to match primary ID code, sorry. That's set on retrieval code. That really doesn't matter in this case because I'm importing a database into a blank database, so nothing should match. Now the next one is important to look at. The first time I did this, it was set to skip unmatched cases. And this is if no matching ID is found, skip unmatched cases. What that's going to mean is if it doesn't find any ID in the incoming database that matches an ID in the current database, which is blank, then it's not going to add any new cases. That's not what we want when we're importing a database. So if no matching ID is found, I want to change that to add new cases because all I want to do is add a bunch of new cases right now from our Aries database. So other than that, display error logs. Our formats are English, United States, and everything like that. If you wanted to, you could also check this button right here, autofit monthly history on newly added producing cases. And that's going to give you a few options on how you want to autofit the history on incoming cases based on most recent trend or all data. Should the projection overlap, and then certain parameters you would like the auto projections to follow. My database already has projections in it, so I'm not going to check that guy because I'm just going to leave the forecasts in that come in. The main thing I want to check on here is make sure if no matching ID is found, add new cases. Okay. Now, I can't just click the import button. That is grayed out. What I need to do now is click this map data button so that I can tell PHDwin what columns in this database are going to go where in the v3 database. Map data. That opens up my import mapping window. It's going to automatically go to a kind of default new layout right here, new layout mapping. And the source table in the top right is going to be just your tables in your incoming access file, which in this case is an Aries database. So I could make my own mapping. I could, scroll here and go to the property table. Let's find that. AC property. And right now in this new mapping, there's no PHDwin fields to map these Aries fields. I could take the time and expand, for example, the case titles, case API code. I could drag that over here to API. And I can see the API column in my incoming database will go to the API column in my v3 database. I could take the time and go through that, set that up myself if I'm extra picky. But to tell you the truth, the Aries layout that PHDwin already has in it works very well. So I'm just going to drop down my layout menu and select Aries, and it's going to reload. And if I want to, I can go in here and look at my specific tables that are coming in to the property table. And I can see where it's going to put all these columns. So the lease is going to go in the case name, obviously, and things like field, operator. It just makes sense. This is everything you need. If I wanted to, I could spend extra time trying to go through here and matching other things in here. but really this works great for me. This works great for every database I've seen come in. So it should work pretty good for you too. Now I can click this import button. So I've, changed my layout to Aries, made sure it's what I'm happy with, and I'm gonna go ahead and click import. What that's gonna do is that's gonna give you a little progress bar to show you the status of your cases being imported from your Aries or MDB database into your PHDwin v3 database. There you go. Mine should be done, and it should load up here in a second. There we go. So my database had 27 cases in it. So now this database has 27 cases in it also. So real quick, what I am going to do is I'm going to change my view up here. Change it to standard because I like the standard view. I'm going to edit mine ever so slightly real quick. I'm going to get rid of this graph down here. Just close it out with the X. And then I'm going to move this graph over here to this set of tabs up here at the top. So I now have that up here with my general info and everything. Now I can see in my scenario dropdown that I now have 3 new scenarios. Beforehand, I only had the default scenario, which just comes with every PHDwin v3 database. I'm having Aries default, a QED, and a QEDB. Now the one that I was working on in the Aries database is this QED one right here. So I can notice right here I have no prices in my default scenario, but when I switch to my QED scenario, it's going to load up some prices for me. There we go. Now, the cool thing about this is that these are the side files that were in Aries. So what PHDwin does is it sees side files and it goes ahead and makes models in the v3 database. So these are the side files that were in Aries, how they were in Aries. So I don't really have to do anything with prices or edit anything else like that because PHDwin recognizes side files, lookup tables, and at macros too, and applies those values where it should in v3. It's very nice. Speeds up what I'm doing in here a whole lot because I don't have to redo prices or anything like that. From here on out, I can go to my forecast and say, okay, these are the forecasts I had in Aries. Look through here, I've got my expenses set up how they were in Aries, and now I'm ready to go. I could change things as I need to. I could send this off to a colleague that uses v3, or I could just take it myself and run with it from here. Okay, that is a quick overview of importing Aries database into PHDwin v3.
Wow. Big thanks to Frankie Delgado of QED Energy Associates. Thanks for that amazing quick help. At QED Energy Associates, we make the world's best reservoir engineering technicians. Call on us today to find out more about our database conversion services. We offer reservoir engineering techs on demand for a 15-minute project or for 5 hours. Whatever you need, we've got techs available today that can help you get it done. You can have a QED technician dedicated to your account if you want to reserve somebody full-time at your office. And the terms could go from 1 week, 1 month, 1 year. We're happy to cover whatever kind of term you want for a dedicated reservoir engineering technician consultant to be on site there with you. You can attempt to hire our technicians. We want all of the QED trained technicians to be hired by you, our clients, so you can hire them directly at any time. We offer some custom classroom training services on topics specifically requested by our clients. We have some nice one-on-one training that can be facilitated at your office. At QED Energy Associates, we believe that competency is not necessarily tied to years of experience. Therefore, for everyone on our staff, we go through and rate their competency level right now, today, through project work, quizzes, tests. We make sure when you call in and need a QED service, we're getting you somebody that has the skills to be able to get that work done for you today. It's my job at QED to make sure that every purchase you make is one that you're happy with. If ever you have a problem with a QED service, please contact me directly. I'm Courtney Stevens, and I can be reached at our office. You can call us at 832-581-3758. The quickest way to get a hold of us anytime is to email us at dreamteam@qedea.com. Big thanks to John Smith and the whole team at TRC Consultants for putting on this fabulous PHDwin Week. What a great service. We truly appreciate you letting QED be a part this year and every year.
Welcome, welcome. So we've got a little bit of time to kill before the Q&A session. So I figured I'd just sit here with Ifer real quick, if y'all don't mind, and just do a little chat. So, you know, this has been a great day for PHDwin Week so far. It's been a great year so far. I really appreciate you coming and seeing us, Ifer. You know, it's been a big part of my career to be able to mentor you and work for you so long. I love you moving on and chasing opportunities across the globe. And so thank you for coming back. It really means a lot.
Of course. TRC always feels like home, you know. I've been the sales representative starting here and moved through training. Now that I've done V2 and V3 training, if you guys need it, TRC has got a great program. Dr. Wigwe was teaching it, and we have trainings. I think I have 2 more trainings coming up this year. So if you guys are in need of version 3 training, please let us know. We'll be happy to get you trained up on all of the V3 tactics, on the basic fundamentals, although we're moving through some of the advanced stuff. Again, thank you all for staying with us and for sticking around and enjoy the great contents that all of the PHDwin ecosystem has put out. Right, we have a lot of incredible users and supports.
And actually, I've got an announcement related to that I've been saving until we got through all of his mini sessions. But I'm sure he's watching right now. So I want to say a big shout out to Dr. Marshall Wigwe. We really appreciate you doing the mini course during PHDwin Week this year. We really appreciate all your efforts with TRC to educate our clients and help us clean up and put together training classes for version 3 and move forward. But I've got some news I'm going to break right now. Whoever is watching in between, you get a little bit of news. I don't know if you know. You probably know this one because you talk to him a lot too. Dr. Wiggly is actually moving on from TRC Consultants. He got hired by one of our clients. I'm actually giving permission to say this. He got hired by Oxy. So congratulations, Dr. Wiggly. We will miss you. Thank you so much for everything that you've done for us and for everything that you've done for the PHDwin ecosystem, right? I mean, he's really left a mark. I have to admit, I've learned a lot from Marshall. I know you've learned a lot from him.
Definitely.
He's had a huge effort to make our features better, to make our documentation better, to make our training classes better. And it's very special that he was willing before he left to do this very long session for PHDwin Week, to do this mini course for everyone. And of course, we will still have training available. I've been doing some classes. You'll be doing some classes, right? Yep. Josh, who was on the Tuesday stream, he's going to be doing some classes, and so. We'll take it care of, but we definitely cannot replace Marshall. He's a one of a kind dude, right?
Yeah.
So
and Marshall's legacy here is that one, in the entire version 3 documentation is pretty much revamped and redesigned and rebuilt by Dr. Wiggly. And on top of that, he also designed and basically implemented the first versions of version 3 training, and even till today, right? The last training he did, it was still earlier this year. So I think that's a lot of value to the entire ecosystem, and we'll carry that flag, right? We'll carry that legacy and make it better.
We'll make you proud, Dr. Wiggly. We'll make you proud, Marshall, to continue that legacy forward. Make sure that your high standard remains. And thank you very much for being part of the PHDwin Week this year. If you ever want to come back, I know you're watching. If you ever want to come back, you're more than welcome. But I know how it is whenever you get a new opportunity. It's one of those things where you got to jump in wholeheartedly. So good luck. We wish you the best. And I feel like you're moving into a really good situation. One thing throughout my career, so I've been here for a long time at TRC, is again and again, we see a lot of our talented people move on to clients. I mean, it's just kind of this natural progression that often happens. You know, you bring in someone like Marshall to train the class, and then the client sits there and goes, well, why don't I just hire that guy to do it? Right? And
That does happen a lot. We have lost so many, even the 5 year that I'm here. Actually, this is my 6 years actually. Uh, we've had actually a handful of people already that's leaving to a client, or that's going to working for clients. So I think those are great opportunities for all involved. But you leave the company, but you never really leave the family, right? This is the PHDwin family. This is why we have our PHDwin week every once a year, and this is to everyone's benefit here. And we would love to have more and more of y'all contribute. Just like you've seen Josh, that's with Zach, Aaron, Courtney, and all of these contributor, right?
Frankie, right?
Yes,
You're right.
Frankie
Contributing
Yeah.
and being part of it. That's just part of that legacy, right?
Yeah.
Well, and also, as you said, I really like the way you put it. They're still part of the family. Like, I have a lot of y'all ask me about Neil Minochi. He's still around. I still talk to him. He's actually the sales director of South by Southwest. If any of y'all knew Neil, that's what he's been doing the last couple of years. So if you've heard of that big show here in Austin, he's the guy that actually lines up who's in the booths and all that. And so, some people move to clients, some people move to different opportunities in town, but anytime I see him, he's always like, how's PHDwin going? How's version 3 coming? Like, you're still invested in that. He's not even in the industry anymore, and he's still invested in the ecosystem. So we always appreciate it whenever we have people that work with us. Y'all know how it is. A lot of times, small companies like us, it's like a family. And so we always appreciate hearing from them, right? So
Yeah, now that you mentioned Neil, actually, what my first PHDwin training was actually taught by Neil in Houston. So this is, and I was back in college. So I got one of those free spots for students, and this is the thing, a lot of things that TRC does for the industry kind of, if we don't mention it, it kind of goes it doesn't go in unnoticed, but a lot of things we're quietly trying to support the industry. As you guys have probably heard earlier today, a lot of things that we're striving for is the diligence, are we doing right by our clients, right? Are we doing right by our family? So, with a lot of those experiences, and one of the other thing is that I've had a lot of time processing down was, if you're unemployed, during your downtime, TRC supports unemployed users too, right? And then that's a lot of things huge thing we do for a client.
That's a great point. I tell people that all the time. On our side, we're interested in investing in people. I mean, companies matter, and obviously our relationship with companies pay our bills. I'll just say it that way. But we're really invested in people. And a lot of times, especially in the current last couple of years of the industry, there's been a lot of changes. People changing hands, moving companies. I would constantly talk to people that maybe worked for a previous client, then they're starting their own new business. They're trying to go off on their own. Come to us, come talk to us. I'm always willing to work with people that'll give me a good plan, give me a good story, to tell me how they're going to continue to contribute to our industry. Me and you have given countless of extended trials to people that were previous PHDwin users at a particular company and then went off on their own and needed that little bit of wiggle room, needed that leeway to get into a new career path. And we're really proud about that. Any students? So we did the numbers earlier this year. We've given out over $28 million worth of software to universities across the country. So any students that, have been part of that and have experience from PHDwin from their university days, when you get out in the professional world, reach out to us. We'll be happy to get you set up with a trial. We'll point you in the direction of, maybe where some opportunities are. We're all about making sure that everyone around is successful. I have this really corny line, and I feel bad about it. Okay. So just real sidebar before I say my line. I really enjoyed Zach's jokes on his presentation. Zach's my kind of guy. He's got my kind of humor. I was laughing about that API joke. I'm gonna steal it, Zach. Like, that's not even a question. I'm just telling you right now. Question session hasn't started yet, so I'm just gonna tell you I'm stealing that joke. That's a good joke. But I'm a kind of corny guy. And I always tell people, like, if you can't get paid, how are we supposed to expect to get paid? And I just feel like that's the reality of the situation. We're here as a vendor, yes, but we also want to be seen as a partner. And one thing that's come up a lot this year, I find it really interesting, is that we've had people call us that haven't used PHDwin in years. Maybe they went to another shop where that wasn't what they were doing. Maybe they went in a different direction, and then they come to me and they go, how's PHDwin going? What are y'all doing? And I go, oh, you want to see the software and all that? And they go, no, actually, I'm sure y'all are doing good on the software. I just remember y'all are really consistent partners. And I just want to work with a company that's consistent again. So, that's what we're all about. We're about consistency. We're about, no matter who's here, who's not, about, making sure we take care of our clients and making sure that we do what we can in things like PhDwin Week to kind of raise that bar and to be part of the conversation in the industry, because it's all of our responsibility. I really believe that, and
I think I think what you're saying is, to sum up, I think it's the trust between us and our clients, right?
It's true.
Clients trust us whenever they're in need, and we're there to help them. And when the tables turn, when somebody who was unemployed, who was a student, for one couldn't be where I am today without taking some of the advantages the TRC offered for students, right? Back in the days, I attended trainings for free because if there are available spots left, student gets it, and that's a lot of that is people TRC does for the industry. And I for one is a beneficiary of that. I wouldn't be where I am today without that. And then we have a lot of clients who took the training, who took some of the unemployment benefits that we provide for our clients, and whenever they land a job or whenever they land in a new company, a new position, a new venture, they think of us, right? And
Right.
we're their primary choice, and a lot of that is a give and take. And I think we build a lot of goodwills with our client base, with our family, right, over the years, and I think that's really important.
I hope so. I hope that people do have faith in us to do the right thing. Sometimes it can be hard whenever there's a lot of different moving parts in this industry, and I get it. You have to provide value, and a lot of times people are looking and trying to understand where that value is for their company. And maybe for some companies, they don't care about a PhDwin week. They're not going to join something like this. This isn't important for them. For some companies, they don't, maybe they don't want to jump on the newest build or whatever, right? They want everyone else to get out there in front. Like every company has a different corporate structure, has a different internal, culture. And that is going to really determine, how you interact with a vendor like us. And I hope that we're flexible. I hope that we're able to work with a lot of different structures and companies. But more than else, I hope that y'all feel that whenever we do things like PhDwin Week and we offer this for free, and we put on this year, it's going to be something like 30 something hours worth of content for free, that is building that goodwill, or at least it's seen as an offering of goodwill to the greater industry, because you can get real cynical. You can get really cynical. Trust me, as a sales guy, the last thing I like is a fast talking sales guy. I know I'm pretty bad about it, but I get one of those guys on the phone and they just want to throw as many big words as they've got at me. You get real suspicious, right? Or you get on the call with someone and they're deflecting. They're not listening to you. They're just deflecting anything you're putting at them, and they're trying to shove down to you what their talking points are, what their benefits are or whatever. There's this whole sales culture that's about controlling the sales process and blah blah blah, and I find it's much more effective to talk to people about what the real problems are, talk about what their aspirations are, and we get opportunities. I've helped people put together what their value is for the first time, just small operators, and here's what your company's worth, and go get that loan. Just know that you can pay for your college kids education, and that really means a lot. And so just to be clear, this is not the Q&A session. Just we had a little time to burn, so me and Ifer decided to grab the camera real quick. We're actually going to turn it off for a bit. I'm going to go grab our company president, David Pasenda, because he was so excited about the sessions today that he wanted to be part of the Q&A. I think he has some questions to ask our speakers today. So I'm going to go grab him real quick, and I'm going to go bring him in. And then at 3:30, we are going to start the actual Q&A session. But again, whoever's been watching, thank you all very much for being part of PHDwin. We'll be back in a bit. I'll have Dave right here in the middle. We'll stick him in the middle. How about that?
Sounds good.
And then
Yep.
we'll ask questions. We'll bring all the different speakers on for today, and then we'll ask them your good questions. All right. Thank you all very much. We'll talk to you all. Okay, time for the Q&A. I've got with us here Ifer Lee, welcome Ifer. And then
Thank you,
David Pasenda, president of TRC Consultants. And then I'm Jonathan Smith, the guy who keeps talking over all the other videos. So we're happy here with you. I'm going to go ahead and bring in some of the presenters today. First of all is going to be Zach Warren. What's up, Zach? Welcome.
Hey, thanks for having me.
Oh, thank you for coming. Great presentation. We really appreciate it. And then we're going to bring in Josh Groves from this morning. Hey, Josh, how you doing?
Hey, how's it going?
Doing good, doing good.
Good to see you, man.
And so we're going to go back and forth a little bit. Okay, I've got questions for you, Zach. And then Josh, you just jump on any question that you want, okay? Like, you just part of the conversation. Welcome to the party. Before I get questions for you, though, Zach, if you don't mind, whenever my 1 o'clock session had some questions roll in, and I just want to answer those program questions real quick, because then we can get into more fun to like industry discussion style questions, right? And so just real quick, because I promised I'd answer them on this, Dan Wells asked, so when I import a V2 PHZ file, will the archives be placed in the hierarchy list? So just a quick review from my 1 o'clock session. When you import a V2 PHZ, all of your projection archives are built out as qualifiers in version 3. Now, there's no hierarchy in version 2. You just either have an active qualifier or you don't. So what it does is it builds out the archives and then adds them to the qualifier list. And then if after the fact you want to go and build it into a hierarchy, you can. But by default, what it does is it takes whatever your active qualifier is, not your active archive is, and rolls it into a qualifier named active. And then that gets put in the primary slot for your projection qualifier. So I hope that answers your question, Dan. You've been asking great questions throughout the week, and keep hitting me with them. You can reach out to me after PHDwin if you have more. And then Stephen Hudson had a question. Basically, he wants to know if he can change the folder setting for storing a V3 database to any folder, because he works on many consulting projects and likes to have, he has really good, what I call a good folder game, where he has all the different client information in different folders, and he has that being backed up with OneDrive. So I just want to refer, Stephen, to the presentation that I did on Monday. Definitely catch a review of that if you get a chance, a replay of that, and it's going to answer this question in a little bit more detail. But basically, the concept here is that no, you can change where the backup is.
You could even change where those directories are, but it's a SQL Server setup issue, and you're getting very deep into SQL Server because you're working through SQL Server. You got to kind of pick up some of their, if you want to make it easy.
Well,
the backup, but the PHZs can go anywhere.
So the PHZs you can put in your OneDrive, the backup files you can change. In that session, I show how to change where the backup location is in SQL. And there's a backup manager in version 3. You can hit the backup button, and all those get swept into your OneDrive. But I just want to make the point here clear. Version 2 was basically a local file database system. I always make the comparison having like the desktop system, right? The desktop database, like just having an access file on your machine. But version 3, we are using Microsoft SQL Server. So SQL Server is managing your data, and you don't have the folders inside of folders with what your active database is. That's saved inside your SQL instance. But your backups and your PHZs, you can pick where those go. And that's what you're going to want to have in your OneDrive to back up your work day to day. So you can set up that backup, and that's very easy to do in SQL Server. But just to be clear about it, the way that you're used to working with PHDwin, where you're just going through files and folders, that workflow is going to change. And I talk about how that workflow changes on that Monday session. Okay, that's enough housekeeping. That's enough. Let's go ahead and bring the guys back. Let's make this a split view real quick. And let's start with you, Zach. So I love the presentation, Zach. Really was near and dear to my heart. I feel like here at TRC, we're talking data with clients all the time. I feel like I talk more about data with clients sometimes than I talk about decline curves with clients. And so we have some audience questions, but I have a question for you, Zach. So one big part of your presentation was putting together a client corporate ID, what we call internally like a corporate ID for an entire corporation. And we think that that's really essential to keep different data sets together. So let me go ahead and ask you, do you feel like, so I've seen a method on this where programs like ours generate like a unique ID There's another piece of software out there creates this thing called the prop num and all that. Do you feel like it's appropriate to use vendor IDs as the corporate ID, or should you branch off and do something different?
I think it mostly depends on the size and complexity of the E&P company. So if you're smaller and simpler, then I think using the primary key from a vendor system like your reserves or accounting software is a really good idea. And it can be very durable and easy to maintain and straightforward. As you get to be larger companies, I think a lot of times it makes sense to have some kind of corporate ID process that is outside of any one piece of software. So if you're in, 5 different basins, or you have 10,000 wells, then using, a system like PHDwin as the vendor ID number for the whole corporation can kind of start to break down. So typical consultant answer, right? It depends, but it's really all about the size and complexity of the business.
So one of the things that's become very important to us, and this was in version 2 and exists in version 3, is we use these pretty sophisticated GUIDs, which are unique. And a lot of people don't see them, but they use them intuitively. When you start merging databases, these GUIDs live in the background, and you can say that no matter what data you change between two databases or two different data sets, or you give to somebody and they give it back to you like your consultant, that GUID becomes a primary key for merging that kind of overshadows everything else.
Mm-hmm.
The problem, it's worked well for us for what, 30 years? And I think a lot of people break databases up and put them back together and don't even think about that this magic happened, right? But what we find is that when we do explain it, we do talk to people, there is kind of a little bit of a pushback, because those GUIDs are significant in size. They have to be. I mean, the point is that when we make that GUID, it's unique.
Long, right?
Well, it's long and it's cryptic, and it's across it's across all databases and all places. It has to be unique, right? Its uniqueness is what makes it, is what's important.
Mm-hmm.
And you do get a little pushback on that. Do you see a similar problem when a large company goes to these? Yeah. Okay. And then the trick is, how do you hide the GUID but give the client the information they need?
Yeah. So in our consulting work, we've seen the back end of probably well over 100 different pieces of oil and gas software. And so we'll often run across, a 64-bit GUID or a 128-bit GUID, and it's this big giant thing, and it takes up a lot of space. And, as opposed to like a nice short 10-digit ID number where I can look at it and say, oh yeah, it started with an X and it ended with a 74Z. And I can go look at another system and I can retain that in my memory. And so I can move between systems and play with spreadsheets and stuff like that more efficiently. And I think a lot of reservoir engineers spend a fair bit of time doing that sort of thing. And so they enjoy having a nice, tight, easy to wrap their head around primary key. So it's a tension, right? Like the perfect solution for an application is not the same as the right solution for somebody who's trying to use their brain to solve a problem, before bids are due at 5 o'clock or whatever that is.
Yeah. So we end up doing both, right? The PHDwin ID, which is short, and then then that hidden unique ID or GUID that is, So I think, unfortunately, as software vendors, that's always been we have to do both, right? Got to do it all, depending upon what you're trying to do.
That's why we take a lot of ID codes. Actually, I have a follow-up question on that, Zach, but I want to bring in our last person for the Q&A today. So I'm going to bring in Alvaro from DeGoria McNaughton. He had a great presentation today. Let me go ahead and welcome him real quick. Hey, welcome to the stream. Hi, Alvaro. How you doing?
Hi.
Welcome. So I've got questions for you, Alvaro. Actually, Dave here has questions for you. He slapped my desk whenever you were presenting and said, "This is my favorite one this year." So you've got some good questions coming from the audience and from here. But real quick to you, Zach, as a follow-up question. And again, the reason why we're doing this on a Q&A, Josh, Alvaro, if y'all want to jump in at any point on any question, feel free to jump in. But a follow-up question for you, Zach. So I've worked with companies to try to put together a corporate ID. And one thing that comes up is, they'll assign a corporate ID to wells. And then maybe that particular well that they're planning a drill or something like that, something changes and that plan changes. And so they end up reusing these corporate IDs, and that ends up causing problems. Do you have an opinion about reusing corporate IDs versus just making a new one for every what if situation? Do they need to actually tie to a real well, or is it useful to recycle them, in your opinion?
It usually causes a lot of trouble if you recycle them. I think my experience on that is once you have a concept of a well, if it's a probable or a PUD or what have you, if anything materially changes about that, you should consider whether or not you should be creating a new primary key for that well. So if it goes from a 1 miler in section 1 to a 2 miler that crosses over into section 2, I would say generally I'm going to recommend that somebody starts over with a new well number. That can get a little bit fuzzy when you're trying to do things like SEC reserves compliance and tracking the life of a PUD. So there's some complexities there that are a little bit subtle. But when you're talking about system integration and trying to get your job done between reserves and accounting and geoscience and drilling and completions and production, all those different departments that are trying to share a consistent, coherent well list, my vote would be to start over with a new one.
I think the other thing we have to be really, really careful about is we're using the word well, okay?
Yeah.
And so much of this is not a well. I mean, it could be an expense center like a compressor. It could be a pad site as opposed to a unique well bore. And we were talking about the API thing, and we've had this conversation a couple of times. A problem I see in the making, okay, and I'm old enough to be a big conventional guy, right? We would never have tolerated mixing volumes from 3 different zones, in the same engineering work, okay? Because one may be a gas well, one may be an oil well. You'll see it offshore. People don't do that. But what I'm seeing right now, because there's such a dominance there's such a focus right now on resource plays, people haven't started getting the plug backs. They will come. Those things penetrated reservoirs, and somebody's going to come back and do a conventional somewhere on some of these somewhere, right? So that will come, but we're not building out those API numbers. We're not paying attention to those API wells well enough. So I think the fact that some of this data is kept at a lease level, production data in Texas is done at a lease level, not at a well level, right? We don't tolerate allocating production data to or reporting at the lease level. We want to allocate it to the well level, but we're happy to have an API number that doesn't distinguish between reservoirs. Yeah. Have you seen that? I know you have because we talked about it, but I mean, is that something you could help underline?
Yeah, right. Like the aggregation that matters changes depending on your discipline. I talk about this in the presentation that the aggregation that matters for accounting is different than the aggregation that matters for a production engineer, a reservoir engineer, a drilling engineer, a geoscientist, whatever. And that's a nerdy way of saying that, once again, API 10 is a really crappy corporate well ID. So yeah, I think there's some good strategies out there to deploy, and probably at the bottom of all of this is to just talk. I think so often what we've seen, I know Matt Harriman, who's Josh's partner over there at Pod 2, he and I have talked a lot about how so many of the problems that we see out there, that I've seen over the course of my career and that I see in my consulting practice, is at root a lack of conversation. It's the accounting department not spending enough time with the reservoir engineer. It's the drilling engineer and the geologist not really being on the same page. And it's time consuming, but you got to get out of your office, apparently get out of your home office, although that's where I am today, obviously, and go talk to your coworkers in order to get some of these kinds of problems solved.
Though, when you do see people do it right, and we've got a client in Dallas, you're talking about this, where they're using a data visualization program between PHDwin and their accounting and some other products. And literally they can QC their engineering reserve work by graphing in a continuous function their historical expenses. Now, getting that unique identifier to be in both places is tricky. And sometimes they're doing it at different levels, but it's magical. It is absolutely magical. And you talk about efficient, it makes them very, very efficient to walk through those data sets. And I suspect they could share that data with their reserve consultant pretty easily and would make everybody's life a lot easier. Right? But anyway, no, it really, and then that's better data quality. That's better output quality, right?
But
Yeah.
David, also you need to understand the differences between a conventional versus an unconventional well, right? Because the unconventional is a horizontal fracture, right? So you are drilling your horizontal. You can go through different reservoirs for sure, but mostly you are targeting single one.
Yep.
Whereas in a conventional well bore, you can have different completions to different reservoirs. So therefore you can have different unique IDs for the different completions in the same wellbore. But
yeah, that's the 14 digit. Yeah, that's the 14 digit.
You have your geosteering through that reservoir. You may, with your fracture, you may contact other reservoirs as well, but you cannot really have a distinction on where those volumes or where that production is coming if you are just targeting your landing zone, right, in a reservoir. So you don't have like that distinction of different intervals or different reservoirs in your horizontal well.
I think that that's a really good point. And, that's something that a lot of times when we are having those conversations, not only with clients, but also with other vendors, is we want to have that conversation and see where they are and see if they have an understanding of what's going on with this. Part of the job that I have with this company is that we get the new data providers popping up all the time that, repackage state well data and all that. And they'll talk to us. And the first question I ask them, I go, so what's your primary identifier underneath all your well data that ties it all together? And they go, API number. And I go, all right, call me back whenever you've got that fixed. Thank you very much for your time. We appreciate chatting with you, and we'll be happy to work with you the moment that you've got a better answer there.
I think I don't think it's I don't, to Zach's point, I don't think it's a bad thing.
Yeah.
Okay. I think it has to be used appropriately. And if you look at the way it was designed by API, if it was used fully, I think it would be a much better thing to do. But the states aren't assigning the last 4 digits to the APIs. And if the states aren't assigning it, then it's hard to move data between people under certain conditions. But I think it's like a lot of things. I think Zach will bounce off this one too. You got to understand the data. Okay. You got to understand the limits of the data. I mean, we saw it with some international oil companies where they call it condensate in one place and they call it NGLs somewhere else. I mean, trying to make these equivalents, which are not always equivalent, but have to be understood, is really tricky. And I think API number is one that for us comes up a lot, but there's a lot of other ones. I mean, where's that production data? If the production data is being reported at the lease level, and then somebody is doing an allocation back to individual wells, you are imbibing an interpretation into that. That data is not the original data. And you have to realize that you have offered some interpretation into it. It might be great. You're going off of test data, and maybe you got a lot of test data, it's good, but maybe you don't. Where water data comes from, state of Texas doesn't collect water data. It's contrived, but how many people know that, right? Anyway, no, I think it's all about you got to understand your data. But Alvaro, man, I was good engineering, man. I really enjoyed your presentation.
Thank you.
Thank you very much. You're making all the rest of us know what we need to, are giving us something to strive for. So that was really good stuff. Yeah.
You want to ask him some of the audience questions that came up, Dave?
Oh, no, I got to remember them. I feel like we're leaving Josh out a little bit.
I'm about to say, Josh, do you have any comments? I'm sorry, Josh. Do you have any
back
comments on this? Maybe he wants to get in the engineering side. Unless you have a comment about data, Josh.
No, it's all good. Yeah, I think just to follow on to Zach's point, I think trying to figure out exactly what the right point at the well life cycle is to create an ID, like that's probably the biggest thing for the operators that we work with. So for future wells, they might be 10 years out, but you still might want to track them. So as you go through, well spacing changes and things like that, you have to decide at what point do we think this is going to be a real thing and create the ID. And that's the biggest thing. And again, to Zach's point, sometimes it's easiest just to use whatever you're using for production forecasting or economics to let the ID be generated there just because it is a natural fit. And then as you get bigger, generally, it makes more sense to spend more time on your own process to figure out No, we're going to create it externally, and this is going to be the ID that flows through everything.
And one point Zach made, and then have one part of your organization manage that, because that is the fight I've seen, Zach, where there was conflicts between who was control of that well list. And accounting says, no, I've got the well list, and reserves goes, no, I've got the well list, and they didn't match, just like you showed in your presentation. And then who's responsible for that? So,
well, okay, Alvaro, one question that did pop up during your presentation, and it might be going a little deep, but I know a bunch of these guys are engineers, so they'll probably be interested, or at least they'll understand it. When you were looking at doing the water projections off of those, you were using a linear function in time to a linear ratio function in time to derive it from your total fluids, which I really like the way you're using a total fluids projection and then treating all the reservoir, liquids and gases as a interacting group of fluids, right? I think that's a fantastic technique. Okay. Have you looked at using maybe a function based on cumulative oil production to manage that water oil ratio, where we're looking at something more equivalent to a fractional flow oil, water flood style calculation? I thought that might help improve, particularly the types of projections that are going to be high water cut. Was that something that you guys have looked at or thought about?
So we have looked at many data functions, many transformations. In reality, when you start with the total fluids, you don't have the oil, the water, and the gas yet. So you don't have those individual streams or phases separated. So the procedure is basically you need to derive one by one, try to split them out once you have your forecast. So the most direct one that we found is the fractional flow of water, which is for us the easiest way to do this extrapolation of the water. But certainly when we work with water floods, we use different types of diagnostic plots, like the total fluids versus cumulative oil, the water oil ratio, oil cut, voidage replacement ratios as well. So there are many types of functions and diagnostic signatures we use to fine tune our forecast. But to your point, we have looked at it, but in this workflow, a specific one that I show in the morning, we need to first do the water oil ratio in time, because we need to first get the water out of the total fluid stream combined.
Okay. What else we got?
Well, one thing that I kind of ties it a little bit together, what Zach was talking about today and your presentation, Alvaro, because one thing that I feel like is an issue with to talk what Dave's talking about, putting these streams together and then pulling it out, there ends up being a data issue. I mean, we just have this problem internally whenever clients just want to use some of the tools that we have, especially whenever it comes to normalization and they want to normalize on things like lateral length and proppant. And that's not in the publicly provided data. So many people are reliant on these public data providers in the various IHS and all that, the 98Cs and the DRI files and all that, and don't have that as part of their structure. And a lot of the data that you showed in your presentation, Alvaro, really requires like the operator to have it themselves. I mean, that's the kind of thing where, you have to collect that data yourself. Can you speak a little bit to maybe someone in an environment that doesn't have access to all that data, and maybe what that sliding scale is to get to the best result whenever you're relying on a data provider and you're not able to get that information from a field?
Yeah, I think that's a very great point, because these techniques really rely on high resolution data, meaning daily data, right? So we need daily data, we need pressure, we need water rates, gas rates with better accuracy than really the data providers can give to us, like in monthly rates, sometimes allocated, as David said, and sometimes even the water is allocated. So it's a constant ratio for many wells, and then it's not realistic, right? So So the reality is that you cannot expect the same level of accuracy on data that comes from the public providers of data providers versus what the operator has, because then the resolution of the data, the quality of the data is different. Having said that, sometimes you have just monthly data and you have to work with that. And I'm not saying that the techniques don't work with monthly, but you can apply those techniques to monthly. You just need to realize that you are working with monthly, and then you will have this uncertainty or these limitations. So if you understand that you will have these limitations with the monthly data, then you can use it. And whenever you get your results, you can do an assessment really on the technical uncertainty, on the risk that associated with that. But you need to understand that you started with data that is of lower quality or lower resolution.
You know, one of the things that you were doing in your presentation, one of the first things you did was the pressure normalization. I think particularly for a lot of these high volume, resource wells, that early time made the shape of that curve is highly dependent upon how the operator works that well. But when I look at a lot of the work that's being done out there with people doing full cycle, curve work to try and build type curves and things like that, there isn't a lot of recognition to that early period being contrived by the choke fundamentally. And then you see people starting to trying to curve fit more of that early time data and giving it a lot of weight, and giving it more weight than the later time data, which probably has fallen into more likely to be a boundary dominated flow, right? But at least more likely to be at constant bottom hole pressure, right? But you're seeing this over, in my opinion, over reliance on that earliest data, which I think has I would be concerned that it would have a tendency to overestimate reserves. Is that a fair conclusion, or?
Well, yes, it's a good conclusion, and that's the whole purpose of the methodology that we presented. Because at the beginning, if you have a couple of months of production data and you have a bottom hole pressure that is dropping, you may have a gas rate or an oil rate that is virtually flat.
Yeah.
And then how do you project that? And obviously you can't, or you will do it, but you will overestimate your volume. So the whole point of this methodology is you have short production data, then you can combine all the phases together, and you can use your bottom hole pressure data if you have available and come up with a meaningful, more meaningful result. And of course, you will always have analogs wells, right? So analogy from other wells in your operating area that will have longer production history that can serve as a guide as well. But yeah, the purpose of the method is to not to overestimate or come up with a forecast that is unrealistic or completely overestimating volumes, basically.
Yeah.
I have a follow-up question for Josh for you on this. So y'all build that validating tool, that pod2 validating tool that goes through and scrubs this data. Did y'all have internal discussions as far as, whenever you're building that tool, as far as what data you're actually having to validate? Is it this early time data issues with that, or is it just like broad strokes of like, the initial rate can't be an X or something like that?
Yeah, it's mostly the latter, because people know, for example, reasonable ranges for their area, and so maybe you do have analogs, and so you can set the ranges based on that, because you know that in this area I don't expect the B factor to be outside this range, I don't expect IPs to be outside this range, and they're rough heuristics, right? So we can't say for sure that this is a problem or not based on those ranges, but you have a good idea of this could be a problem, and I can go in and flag those wells and look at them to make sure that there is, it's intentionally done that way, and it's not just a mistake somebody made as they were doing bulk updates or something like that. So Yeah, for the purposes of QC, it was mostly about setting boundaries around like reasonable expectations for wells, and then a warning when you go outside those bounds, knowing that there are going to be exceptions to that. And other things like if you have certain streams and you see gaps in them, then you might want to flag that, because in some cases people are going in and auto fitting and they have gaps in their history, and because they're moving quickly through it, they didn't realize that it actually biased their forecast or something like that. So we try to catch different situations like that to let them know that we're not totally sure that this is an issue, but because there are these gaps in the history, you might want to compare your forecast against the history to make sure you didn't accidentally bias the forecast that way.
Well, I don't want to put you on the spot, Zach, but do you have any comment about this whole concept of like full cycle auto fitting and gaps in data and how to handle this?
I do. Yeah, I'm a technology optimist, right? So I'm kind of someone who comes at it from the perspective of, over time, given enough data, given enough smart people working on the problem, we're probably going to get to good solutions. I'll just put in a little plug. I'm on the board of directors for the Society of Petroleum Evaluation Engineers. And coming up in October, there's going to be a software symposium that I know PHDwin is going to be a sponsor of. We're doing a bake-off on automated decline curve analysis tools between 13 different vendors, and try to see how, what's the current state of technology there, and how close to reliable are these techniques right now. And a lot of my motivation for being involved is because I think if we do, rigorous kind of sort of scientific studies on these things, then we'll be able to provide feedback to the vendors and put us all in a position where down the road we could potentially rely on these and have it really make a difference for how much work can get done, and how confidently we can make our decisions in a time efficient way. I think one of the things I always really liked about the concept of Pod 2 Validator was automating your data quality work as much as possible. I think putting yourself in a position where you do not have to manually QC the work that you've done, where you are given summary information about where the data is more or less reliable, just every time you finish a run, trying to get that as efficient as possible makes a big difference for whether or not people are going to actually do it. Easily the most embarrassing story in my career as a reserves engineer was I published a reserves report for a quasi SOX compliant company that had the wrong differentials loaded on the case. And we had all put in an email what was supposed to be in there. Everybody knew what was supposed to happen. That isn't what got loaded into the final run. And we printed a third-party audited reserves report with the wrong differentials. Eventually it got discovered, we fixed it, and it was like a 0.2% difference of PV10. And at the end of the day, it didn't really matter. But that kind of thing really drives you crazy if you're trying to print clean results and make confident decisions. And so try to build workflows that make that kind of thing very easy to avoid. Don't be like Zach. Don't print a reserves report with the wrong differentials in it. Humans are human, and so to the extent possible, we should support them.
So Zach, I'll make you feel better. We had a client who had a lot of wells, and it's a name everyone would know, so we're not going to use it. And they were on a competitive software. They converted to us. This is many years ago. They converted to us. They had 250,000 ownership records in a table that they were supposedly using. The primary key between that table and their, we'll call it their master table, didn't match. And when you joined them, there were 0 joins. Okay. Everyone felt like they were using the data. They were maintaining the data. They were but when they made the runs, because somebody had reorganized that linking ID, they were actually never using them, and it had fallen back to a default. Everyone's going along, fat, dumb, and happy, like this is wonderful for a period of time that was longer than it should have ever been. And they were, and that was all internal. They were privately held, so it wasn't like these were SEC disclosures, but it was really kind of scary. And I think everyone kind of at that moment had a, oh my God, how could this have happened? They got lackadaisical with their data, and the way the system worked, they didn't have something like Josh's product to kind of QC that, and that's a big deal. And that happens more often than any of us want to admit, unfortunately.
One of my nerdy blog posts is called "Implementation Eats Selection for Breakfast," meaning that doing a good job of implementing your software is far more important than selecting the right piece of software. Now, this is a PHDwin week event.
Oh, no, I disagree with that, Josh. I'm sorry. You got to select the right one.
Right. But I firmly believe that doing a really great job of implementing whatever tech stack you have chosen is going to make you happier and is going to give you lower risk, higher confidence decisions in the long run. That is almost always your next best hour, is to do a better job of implementing the stuff that you already have, because you can avoid these kinds of data quality problems. You can put yourself in a position where you can maybe accurately calculate flow and bottom hole pressure, so you can do RTA for the first time. Those kinds of things are putting you in a spot where you can move forward and make good progress, rather than like spending 6 months ripping out a current piece of software and trying to put something else in. That's my personal bias.
What we see a lot of too is that the client pays the money for the product and think they've solved the problem.
Yeah.
That's the biggest issue. Okay. So one of the things that we find is our expertise is almost as valuable, maybe more valuable than our software, right? Yeah. Because I think that's the important part. Just because you bought the software doesn't mean the number of people that don't use our software to its fullest ability is kind of sad. I mean, and I think they could do better. All right. I think they'd be in a better place. And I'm talking about my own clients, and I don't mean to knock them, but I think that there's stuff that we can do. And yeah.
And I think, Dave, this is exactly why, John and I, whenever we're on sales, we make it to a point to support the client to the point where they can actually comfortably run PHDwin, because I think I'm on the same page with Zach, because you can have the best car in the world, but if you don't know how to drive it, you're not going to have a good time. Right?
Well, and that's also why I'm really insistent about us doing PHDwin Week and bringing on great partners like Gordon McNaught, like Alvaro, that shows a methodology that we think is a good methodology, right? Does a really good job of modeling. It's good engineering. And then that can be a flag that we can wave, so that whenever people come to us later and they're wondering best methods and all that, we have this we'll have this replay, and we'll be showing them this, and we'll be bringing them in. And so that way it's not us saying this is PHDwin's way of doing it. Instead, we point to key industry partners and we try to build that consensus, because, not everyone has all the right answers, but it's kind of Zach's talking about, if we can talk with each other and we can put together these solutions and we can go back and forth, then we can put our brains together, then we can have better quality work across the industry, no matter what software you're running, no matter who's signing the paperwork at the end of the year. And so that's why I really appreciate y'all coming on and contributing to PHDwin Week, because we're hoping we're moving forward that consensus.
But there have been some, and there's one sitting in the back of my mind that I won't address specifically, but there have been proposed techniques and methodologies for doing certain things that were very flashy and very cool looking, and really had a good sense of they felt right. Okay. But when push came to shove, when people really looked at it, it didn't work. It wasn't real. And this one was kind of a statistical methodology, and it was just the wrong application of statistics. But it felt good, and people just grabbed it and ran with it. And I want to say it was like 10 years before the SPE papers came out saying this doesn't work and this is why. But it felt right. So the marketing aspect versus the engineering aspect, that's a tricky thing. That's a tricky thing.
And sometimes it catches the best of us, right?
Okay, no, it does. But we have to be on on guard for it, right? If it feels too good to be true, it might be too good to be true. Bottom line.
General rule there, right? So.
Well, I think that from our side is that, or from the presentation that I tried to give it in the morning, is that we want to let the data speak for itself, right? We don't have to put our bias on it. We want to have data-driven methods that you found diagnostic tools that the data is telling you things. You just need to go and ask the data itself, what is it telling you and how to better address those problems. So if you go with your biases beforehand, like just saying, oh, the p-value in this area is this one, and you forecast all your wells like that, but maybe the data is telling you something different, right? So I think that's, I agree with that, trying to put your biases outside, let the data speak for itself.
Yeah, and as we go into this world of AI too, the programs have bias. I don't care what everybody says, oh no, we're going to let the software do it. It's not going to have bias anymore. I call BS on that. I mean, it would, you see it with the AI programs, right? They will give back, what is it? The
weighting. Yeah. How the weights are set up.
Yeah. They if there's a bad story out there, it's, factually incorrect, it still can be given a lot of prominence just because people believe it or it's talked about. And I think that leads to the engineering aspects. I mean, the Monty Hall, if you guys don't know what it is, the Monty Hall perspective, look it up. It'll twist your mind. It twisted mine for about a week. And I still don't think I understand it, but it's a statistical thing. And in the end, yeah, there is a right answer. But if you go out and you do Chat GPT on it, it's going to give you the wrong answer. Or how many R's are in strawberry? It's going to give you the wrong answer. But you've got to understand the technology. You've got to understand how you use it. You have to do the good engineering like Alra is doing, and that'll lead you to the right answer. Feel good can get us all in trouble. I mean, that's, yeah. Might be a pretty bridge, but it still falls down, right?
I think so. I want to be respectful of everyone's time. It's a little bit past 4, so what I want to do real quick is give everyone here a chance to kind of sign off and say some final words, and then we'll finish off this day for PHDwin Week. Let's go ahead and start with you, Josh. You kicked us off this morning. We'll go in the order of the presentations today. So go ahead, Josh. Do you have any final words for the audience?
Yeah, I think on data quality specifically, I think like everybody has to start somewhere. So you find where your process is currently breaking down and just go through it and try to figure out how you can make a step in the right direction. I think everybody is working towards the same goal here. So if we can find industry standard ways to help enforce that quality, whether it's certain ranges that we can share that help people determine whether things are reasonable or not, I think that's a great step in the right direction. But yeah, overall, thanks so much for PHDwin Week. I thought the whole experience was great. The fact that we are sharing these sessions openly, I think that does help to move the industry forward. So I'm a big fan of that and everything you've been doing here. So thanks.
No, thank you, Josh. And we're going to push that Slack channel out as soon as I figure out how. So thank you for pushing that along.
Sounds good.
Alvaro, do you have any final thoughts for us?
Well, just saying thank you to you guys for the opportunity. I think that based on the presentation I gave, I hope that intrigued people to look into diagnostic-based methodologies and come up with their own. We're still there's room to improve things. So just keep curiosity alive there, and then keep finding new ways to change the data and let the data speak to us for data forecasting.
I think that's great. I think it's a good point.
I think there's still a place for us engineers. I don't think we're getting replaced yet.
Not yet. Not yet. Hopefully not. All right, Zach, take us away. Do you have any final thoughts?
Yeah, I think bottom line, the reason that you use a piece of software like PHDwin is usually to make good decisions. And at heart, the work that we're doing around data quality or physics-based forecasting or planning software or any of those, we should always be kind of getting back to how is the work that I'm doing today going to make my decision more confident or higher quality, more accurate. If you can keep that at heart, then you're probably not wasting your time. You're probably doing the kinds of things that are going to help your business be more profitable in the long run. It can get kind of difficult to do when you're just under the gun for deadlines and things like that. But at heart, the reason that we do this stuff is to make better quality decisions. So thanks so much for the invitation. Enjoyed this panel conversation and look forward to seeing PHDwin Week 2025.
Oh, well, thank you very much. I appreciate it. Don't get ahead of me. These take a lot out of me, Zach. I need a nap or something between now and then. But thank y'all all very much for coming on. I really appreciate Josh, Alvaro, Zach. Thank y'all for coming back on this Q&A. Thank you for your presentation today. Thank you for making the industry better today. I really think y'all all did that. And so we really appreciate working with y'all all in the future. Y'all are all always have a friend here at TRC. I think I speak for all of us here that the door is always open. And so again, we're going to be starting at 9 a.m. tomorrow morning, and then we're going to finish out our last day for this PHDwin Week 2024. But for now, thanks, guys. We really appreciate y'all jumping on. Y'all have a great day.
Thanks so much.
Thank you.